Morning. Yeah?
Okay, I just want to make sure.
Yeah. Cool. Talk about Sam.
Alrighty. We're gonna, just a minute, people walk in, get in. If you're in the back, you might want to get closer to the front. There's a lot of code, and these are infinitely tiny screens. So tiny. I mean, embarrassingly tiny. Inadequately tiny. Insufficient. For a talk on microservices, 2 micro. There's this service application. Okay. Sorry about that. I had to do a quick run through of all the code. Things have just changed apparently in the last week, and it's been almost 6 days since I've done this talk, so wanted to make sure it was all good. It's a RC now, right? So stability is important, especially in front of an audience. Now, thanks for coming. I know you have many fine choices this morning. As I mentioned earlier, we're gonna go through a lot of code. I cannot warn you strongly enough that this is gonna be kind of a squint if you're not close to the screen. So if you fancy your eyes, come closer. It'll be fine.
You're going to be recorded throughout the session. So
Sweet.
You can, stay as close to the mic.
Oh, stay as
Unless you want to wear them off.
Yeah, I definitely need to wear love. I'm not gonna be able to do that.
Okay, that's
Microphone.
good. That's good for you.
Let's some power. Do it live. Doobie doobie doo.
Unfortunately, it's wired.
Yeah, that's fine.
I'm going to clip that on your belt.
Sure. Okay, disconnect. Can we make this a? Is this HDMI? No. Where's HDMI?
HDMI. Where do you put that?
Is that it?
Here
That's
it is.
it. Do 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 do. Okay, can you hear that? Can you see that in the? No.
Can't see it?
Not just yet. It's a little awkward.
Now we got it. You just got to switch it.
We have the technology. And now you can see me. Let me make it a little bit larger. Not really. Can you see that in the back? Nope, maybe. Eh? Okay. We're going to go with that then. Okay, so goodbye to you. Goodbye to this. Right, so thank you everybody for coming this morning, this wonderful, wonderful morning. I appreciate that you have many choices this morning, and I appreciate that you're going to spend them with me. We're going to go through, I need a presentation. What are we doing here today? We're doing the Cloud Native Java workshop. So let's pick a presentation. One of these will do. TSS. Okay. Ooh. There's that. Alrighty. Let's cut out some stuff here. Well, actually, I don't really need any of it. So, we can do better. We must do better. It's too much. Guns back to workshop. Maybe. Haha. Perfect. He's my spirit animal, but he's not involved in this talk, so goodbye. Right, okay. Welcome, everybody. Good morning. So thanks for joining me. I know you have a lot of choices. Like I said, this is a big deal that you all came here. We get to be here together. I'm going to do a lot of code today. The goal is not, at the end of the day, for you to remember everything I've typed. It's to remember that it's possible and where to go. We're going to cover both Spring Boot. How many of you have heard of Spring Boot? Oh, well, okay. That's more than if I'm honest, that's more than I expected. Right on. And then I'm going to cover Spring Cloud. How many of you have heard of Spring Cloud? It's the sensation that's sweeping the nation, my friends. It's good stuff. Now, you need one to understand the other, so we're going to go ever so quickly through Boot. We'll call it a boot camp. Okay. Now, if you have questions, if you leave this room more confused than when you entered, if you have any ideas, please don't hesitate to ping me. I'm there. I'm on the Twitters. How many of you are on the Twitters? It's 2015. Twitter? Anyone? Twitter? Twitter? That's very weird. Do you have email? How many of you have email? Email. No, no one. Okay, well, okay, if you have either of those, I'm there. I am forever at your service. This code is online. It's on that GitHub URI there, so github.com/JoshLong/beautiful microservices. Please don't hesitate to reach out to me. I'm the, how many of you have had the dubious pleasure of seeing one of my talks before? You poor bastards. Well, thanks for coming. I'm the Spring, well, no, the article has changed now. It's an indefinite article. I'm a Spring developer advocate at Pivotal. Author now of 5 different books, the latest of which is not quite finished. That's Cloud Native Java, due ASAP. And also videos, building microservices with Spring Boot and so on. Java champion, that's new. I wasn't a Java champion last year. I'm also an open source contributor, so lots of small things, lots of contributions, leading contributor of bugs to many fine projects like Spring Boot, like Spring Cloud, etc. And I'm going to go through. I work at a small company called Pivotal. How many of you have heard of Pivotal? Okay, so we're the new home of Spring. Lots of great stuff there. We're a startup. We started in 2013. We're a small company, but I've got a feeling we're going to be big one day. I've got a feeling. We're the home of lots of great open source technologies, not the least of which is Redis. How many of you have heard of Redis? Distributed data structure server used by some small mom and pop shops like Twitter. Tomcat. Anybody hear of Tomcat? Okay, good. Right on. Cloud Foundry, an open source platform as a service. It's a cloud that's optimized for the continuous delivery of applications into production. Spring. How many of you have heard of Spring? Spring. Okay. And then, of course, RabbitMQ. How many of you have heard of RabbitMQ? So all of these are great open source technologies. They're enablers. But fundamentally, we view them all as vehicles by which to deliver applications quickly and safely into production. That's all we care about at Pivotal. It's our raison d'etre. It's what we think about all the time. We have people in the office who, around the water coolers, the proverbial water coolers, of course, because it's 2015, and we all know that a water cooler today is a ping pong table, who fantasize about dream getaways to production, while others think about Hawaii and boring places like that. We love production. Production to us is the happiest place on earth. It's better than Disneyland. We think about it all the time. And we want our customers to be able to get to production quickly and safely. And that's very important, right? As long as these vehicles help us do that, then they're going to win. But if that changes, well, then we change what we have to do. And we've seen a lot of customers struggling to get there quickly and safely. We've seen a lot of customers and users trying to understand how to quickly move code to production. What we've seen is that for projects of a sufficiently large team size, there's gating effects, things that impede their ability to move code into production. First of all, we've seen that if you have a large enough code base, it becomes untenable to manage it with a small team. And if you have a large enough team, then you lose the ability to make a change, find a story, make a change, test it, integrate it, and then deploy it, right? That's part one. So we've seen that in order to break down applications and teams, they need to break these things into independently deployable pieces. That's one motivation for this idea of a microservice. But that's not enough. If you have a software team building small microservices, but you don't have a holistic perspective about it, you don't have a systems view of it, and an organizational view of it, you're going to find yourself flailing trying to deploy code. What happens is we see organizations that have product management and user experience people, and then the developers, and then of course the developers do Agile, they do story-driven development, they do TDD, they may do red-green refactoring or even pair programming. But then after that, they throw it over the wall, to the proverbial wall, to the operations teams, and that may entail, of course, your system administrators, your database administrators, your network administrators, etc. And these different groups, these different silos take the code one by one, each with a ticket as their message, into a queue. Each takes this code and does what it needs to, and then services it, and then deploys it. The problem is that there is this queuing effect. And so this queuing gates our ability to move, because for each transition, as we push this thing down the line, you have to wait for availability on each of these different groups, these different organizations. This is antithetical to Agile. It means that even if the developers are doing agile development and they're going as quickly as they can and they've decomposed their services into these small, singly focused microservices, even if they're doing that, they're gated by this constant queuing before and after from QX, product management and UX, and then onward to the administrators and so on, and the testing. We call this water scrum fall, right? When you have an organization that is doing agile development, but everywhere else it's doing waterfall, you may as well just do waterfall the whole way because you're not going to be able to move quickly enough, right? This is going to gate your ability to get feedback, to deploy. We see different approaches to fixing this. The most popular, of course, is to break down, to reverse engineer or hack Conway's Law. Conway's Law dictates that software will mirror the organizational structure that it serves. Right? Alternatively, restated that this is, if you have 4 different teams working on a compiler, ineluctably, it will be a 4-pass compiler. They've proven this out with different examples, different studies. They took open source code and proprietary code of the same sort of function and compared them, perhaps a word processor or something like that. And they realized that the open source code developed by teams spread across the globe in different time zones, different locales, had more formally defined module boundaries. And the reason is because they didn't have the ability to synchronize with human speech. These people were in different time zones. They needed to be able to carve off a piece and work on it by themselves, right? Whereas the proprietary software written by a company whose developers were all sat in the same office could just swivel their chair around and ask Bob or Bobette what the code is supposed to do. These companies had a less defined, less rigorously defined modular boundary. So microservices is another reaction to that. Microservices allows you to formalize this boundary between modules. It makes it natural for small teams to pick off a piece, work on it, test it, make a small change, and then get it all the way to production. But if you still have this gating effect, you need to get rid of that, right? So these feature teams are small teams. Netflix and Amazon call them 2 pizza box teams, right? Teams large enough that 2 boxes of pizza could feed everybody. And this meant that these people were all co-located. They didn't serve the large organization. They served this one product, this one feature. You think about Facebook. Facebook has the wall and the chat and the photos and all these different features. They are all independent pieces of functionality that could be developed by different teams. They don't need to share code bases or even implementation technology. By moving to this microservices model, you're able to say, I don't care what the front end of that other app is. There's no reason for me to use it here, right? I can develop the APIs. I can use whatever backing technology for my database, etc., to develop this microservice. And so all these things together, taken together, small functional feature teams, small microservices, API independence, technology independence, these all help you move faster, right? And that's what we're trying to do here, is we're trying to move faster at the end of the day. Microservices is a means to an end. It's a means to get there. If you embrace microservices ignorant of sort of this larger picture, it's going to be hell. It's going to be hell. Just understand that. You don't do microservices for scale. Most of us don't have Google-sized scale, right? You can probably, in the very beginning of an application in a small team, get away with a monolith. It's fine, right? It'll be fine. Just do that. You can tease out the boundaries more aggressively that way. You can get functionality up and running. And so we've seen that lots of different organizations started with a monolith, and that's fine, right? Again, if that may be the more productive way to go, especially in the beginning when you're still formalizing these boundaries, these modules. When you do make the move to microservices and you tease these things apart into small, independently deployable microservices, you've invited the complexity of distributed computing into your life. Distributed computing is not easy. It's not a message of hope, my friends. I know that's not something you want to hear at 8 in the morning on a Monday, but it's not easy. It's going to hurt, right? There are patterns you need to be aware of, things you need to be able to take care of, non-functional requirements that are going to plague you. And if you don't have these capabilities, life isn't going to be fun. In short, distributed systems are hard, okay? So today we're going to look at 2 different things. We're going to look at Spring Boot as a way of standing up APIs and handling the non-functional requirements that you need to be able to do so aggressively and consistently and quickly. And then we're going to look at Spring Cloud as a way of handling the non-functional requirements that you're going to need to address and you're going to need to have when you work with a distributed system. Thankfully, these patterns are not novel. We don't have to invent them ourselves. The giants of the web, the open web giants, the likes of Netflix, Amazon, Twitter, Google, eBay, they've all sort of solved these kinds of things. Some of them often in very similar ways. And some of them have even been nice enough to open source it. And where they haven't, we've tried to plug the gaps, right? So Spring Cloud represents sort of the best of breed integration of all these different technologies and where appropriate gaps that have been plugged. We integrate these pieces to provide a cohesive experience so you can build apps and not worry about these sort of non-functional requirements, just as Spring has always tried to do in the single app case. Okay, that was my slide deck. I think that was awesome. I think that was pretty awesome. What do you think? Yeah? Okay, good. So we're going to go very quickly through Spring Boot rather. Oops. I don't need this. Goodbye. I do need that. Okay, start.spring.io. Okay, can you all see that? Fabu. So I'm going to go here. This is start.spring.io. It's my favorite place on the web after production. If you have, if you want to start a new project, start.spring.io. There's actually integrations with this. It's a web service after all. There's integrations with this for IntelliJ, for Eclipse, or rather Spring Tool Suite, our IDE based on Eclipse, and for NetBeans. NetBeans? Anybody here? There's always that one guy in every country I go to. Always, everyone. I don't know how he follows me. It's a little weird. Oh, there you go. 3 of them. Okay, right on. So it works just fine in NetBeans as well. Start.spring.io. It's a place to go shopping and to develop your application. I'm going to choose to use Spring Boot 1.30 RC1, right? So this is awesome possum, good stuff. I'm going to build a sample application, and the goal right now isn't to show you everything, and it's not even to explain any particular thing. What I'm going to show you is sort of how easy it is to pull these things together quickly. So what we're going to do is we're going to build a service called the reservation-service, like so. I'm going to bring in Spring's web support. Great. I'll bring in REST repository support. There we are. I'm going to bring in JPA because I make poor life decisions. There we are. I'm going to use the actuator for non-functional requirements like state and health checks and so on. And I'm going to use the H2 embedded database because it's a demo and I'm lazy. And that'll do for now. You can choose Maven or Gradle, as you like. You can also, by the way, go shopping using this full menu. If you click the full version, you get an enumeration of all these different modules. I'm going to pick one simply for the side effect because I'm using a milestone. I want the dependency management section that'll bring in the Spring snapshots or the Spring milestones library because it's not GA and not in Maven Central. So I'm going to bring that. Actually, I'll bring in, what do we want? Where do we go? Config client. Voila. Okay. Other than that, I have choices here as well. I have packaging, right? The kind of artifact I'd like to build, a jar or a war. Now, if you are, by some fluke of physics, stuck in the distant past, unable to move forward to today, which is really not the future, it's just today, nothing to be proud of, then you should choose war. But if you're here with me today, in 2015, then you should choose jar. This is part of my personal philosophy of make jar, not war. Now, you have choices. You have options. Again, we're always supportive of all these things. Also, you could choose Java 1.8, 1.7, or 1.6, but you shouldn't. You should always choose 1.8, always. It's not even just an opinion. It's the responsible thing to do. Your employer has grounds to punish you for anything less. It's end of life, friends, save for security updates. Take that to your boss and say, I want a good language, and by the way, it's for your health as well. Right? So there we are. Good stuff. Java or Groovy. This is JavaOne, not GroovyOne, so I'll use Java. Why not? And other than that, I'm going to go ahead and hit generate. And whoops, nope, don't need that. I'm going to open up this little service in my IDE. We're using I like this new bit here. There's a Maven wrapper, which is great for continuous integration, right? If you're deploying services and you want to continuously integrate, you can be assured that the build tool that's on the continuous integration server, which is this Maven wrapper, is the same as you're going to use locally when you build it. It's mirrored, if you will, after the Gradle wrapper. Great idea, right? So guaranteed that if you anything you need to build this consistently, it's in this application. You don't need it, of course. You can just use Maven on your command line, but it is convenient. So I've opened that up here in my IDE. I'm going to make this font bigger. Bigger or more bigger, okay? Can you all see that? Groovy. So, typical sort of Maven pro forma boilerplate kind of stuff. You have a parent build here. Hello. You have a parent build, and this parent build in turn has a Spring Boot dependencies parent, and that in turn has a section that enumerates all the different dependency versions for common ecosystem projects. You're by no means limited to these dependencies, but it's nice to know that we've thought about the common ones, so you don't have to play whack-a-mole with version ranges. Okay, so this is nice. Things like Cassandra and Bitronics and Antler and ActiveMQ and the commons, Asterisk libraries, Derby, Dropwizard, Gemfire, Hazelcast, Hibernate, all these different things, not to mention Hibernate things and databases and the various Spring projects. All of them are enumerated here, right? So we're level setting all these different versions so that if you want to use library A and library B and there's a common logging library that may be 0.1 release off, we've level set them so that they just work together and you don't have to pull your hair out. In point of fact, that's why the good Dr. Dave Sire, who is the co-founder of both Spring Boot and Spring Cloud, it's why he's bald. He solved these problems for you so that you don't have to. Okay. Now, we have here a set of dependencies. These dependencies are opinionated dependencies. They correspond, each one, to a checkbox on start.spring.io. So Spring Boot starter data JPA is the JPA checkbox that I selected on start.spring.io. It's an opinionated dependency. It, in turn, brings in everything I'm going to need today in 2015 to be productive with JPA. It'll bring in the latest and greatest Hibernate. It'll bring in JPA 2 spec. It'll bring in the Spring support for JPA and JDBC. It'll just bring, and it'll also bring in Spring Data JPA. Right? So it just brings in everything you need to be up and running. Zero fuss, zero muss, right? The actuator, we saw that. We saw the REST support, web support, etc. And that's enough, right? That's our opinionated dependency. We've got H2, we've got unit test support. This is the side effect that I wanted, the dependency management section. That's why I chose this, and we'll disable that for now. Actually, that's fine. Okay. Other than that, pretty boring Java project. You have a static directory, it's empty. Templates directory, it's empty. Application.properties, also empty. And a very simple public static void main Java application. And that's about it. Okay. Now, this is a Spring Boot application. You can tell because it says Spring Boot application. It has 3 meta annotations that are transitively applied. So that is to say, any application annotated with Spring Boot application is by implication also a configuration class. And it will be subject to component scanning. That is to say, every bean annotated with @component or @controller or @rest controller or @service or @repository, or indeed even your own meta stereotype annotations, will be picked up in this package or any package beneath it, right? The current package, of course, is com.example. So everything in this package or beneath it will be picked up in that scan. And we also see that it's got the Spring Boot @enable auto configuration. This is the thing that turns on the magic. I'm just going to go ahead and lay it out. It's early and I don't care. Nobody can stop me. I know we're friends here. I'm just going to say that I think the name is pretty terrible. I think they should have changed it and given it a different name. Maybe something more like I want to go home early. Now, nobody on the Spring team listens to me. That's fine. Whatever, whatever. It's okay. I think this is better. But that's basically what it does. Okay, so now we can actually build an application. I'm going to build a nonsensically trivial application, the same canonical, stereotypical application that I always build. It's going to be an object to manage. It's going to be a class to manage instances of a JPA entity called reservation. Okay, so we use @entity here, and I'm going to give it a ID. So I'll say @ID @generated value. Whoopie-doo. Okay. And I'll say that it's going to have a single lone field called reservation name. This is to be the name of the group that wants to make a reservation at a restaurant. And I'll assign some getters. I'll create a few constructors. Great. I'll create another constructor for JPA, right? So there's that. I need a toString method. So here we are. Really? How's that even close to okay? So tell me about NetBeans. Anyway, so there's that, right? And that's it. That's my basic JPA entity. And I want to now insert some dummy data into my application. We're building just a simple REST API. I just want to build the simplest thing I could possibly build so that we have something to play with during our talk today. So that's part 1. I need a way to manage instances of this data, right? I'm going to use Spring Data repositories, which are a conventional configuration way to manage instances of various ORM solutions. So I'm going to say interface reservation repository extends JPA repository instances of type reservation whose primary key is of type long. And JPA repository is a Spring Data interface and has methods like find all, sort, delete, etc., paging, all this kind of stuff. And there are many others. There's Mongo repositories, Neo4j repositories, Cassandra repositories, Couchbase repositories, whatever. Right? That's the benefit here, is that you can handle the common create, read, update, and delete stuff pretty consistently across your technologies. And these queries, these methods are going to be implemented for you automatically by Spring Data. You can provide custom finder methods. You can say that I want to have a finder method, collection of reservation, find by reservation name, string rn. And what that's going to do is it's going to be implemented as a method that has a query that's basically of the form select all from reservations where reservation name equals rn. Okay? I don't have to worry about the implementation. It just gets done for me. If I'm using Cassandra, of course, I'll use CQL. If I'm using Neo4j, I'll use Cypher. If I'm using MongoDB, I'll use Bison. It'll all be done automatically. Right? So I get these benefits. And now, again, that's one of the benefits of microservices. There's no gravity compelling you to use, well, Oracle, basically. There's no gravity forcing you to add tables to a perpetually growing Oracle database. You can use the right database technology for the job. If you're doing a search engine, by all means, use a full text engine. If you're trying to do GIS, MongoDB has that for free. So does PostGIS in Postgres. Don't need Oracle Spatial for 90,000. Lots of good stuff. Lots of great alternatives to these different technologies that are more appropriate often. So because these are singly focused, independently deployed services, you can use the right technology for the job. One of the big benefits. So I'm using JPA, but that's because I'm lazy and I make bad life decisions. You should use the tool appropriate for the task. Okay. Good, so I've got that. Now I need to actually stand up some dummy data. And there's a few different ways to do this. I'm going to create a bean that implements the command line runner interface. Now, of course, this is Spring, so I can actually just create a component like this. I can say class my CLR implements command line runner. Nope. Hello, Josh. Hello. Good. So there's my method, and command line runners from Spring Boot. It's a callback interface. Any bean that Spring sees that has this interface will be called when Spring Boot starts up. The string args, the variadic array there, that's the public static void main string arguments array. And this is a great place to do kind of initialization for back office kind of work, ETL, whatever. Even if you have a web app, as we do here, it's a great place to do some initialization logic. But really, I don't really need the object, do I? What I'm trying to do here is I'm trying to stand up an object for the side effect. There's no actual state here. The pretense of a class is just because of Java. Now, in modern languages like COBOL and Lisp and Smalltalk and PHP and Forth and Haskell and Ruby and JavaScript and Perl and Python and OCaml and Objective-C and F# and C# and C++ and C. Modern languages from the last only 50 years or so, we have the ability to treat function references as currency, as primitives in the language. And it is thusly that I'm very happy that we now have lambdas in Java 8. So what I'm going to do is instead of defining a full-on object, just to have Java and Spring call this method, I'm going to define a bean. I'm going to define a bean provider method here in Spring. And I'm going to tell Spring to register this bean for me. And I don't really care about the object. I'm not going to reuse it anywhere. I just want the side effect. I'm going to say bean, return new command line runner. And I'm going to tell Spring that in order to instantiate this bean, I needed a reference to my repository. I'll say inject the repository reference. And I'm going to get rid of this. I don't need that. Right? I'm going to just use a little lambda here. It's cleaner. Good. So now I've got my lambda, and I've got my repository, and I'm going to stand up some dummy data. I'm going to say Josh, sure, okay, Phil, Dave, Spencer. Anybody? You guys are not helping. Mike, thank you, sir. Anybody? Tom. Okay. Thanks. Okay, here we are. For each name, I'm going to save a new reservation object in the database. And then I'll go down here and I'll ask my repository to find me specifically, the one record for Tom, and I'm going to call the for each method, passing in a method reference. So instead of passing in a lambda, I'm going to have Java just call a method each time. And I'll do the same thing here for every record in the database, all whatever it was, 6 or 7 or whatever, the handful we have there. And then I'm going to run it. Now this is going to use h2, which I've got on the class path. I haven't explicitly configured a bean whose return value is javax.sql.datasource, but I have a embedded database, h2, Derby, or hsql on the class path, and so by convention, Spring Boot will stand up that database for me, store the data, and so on. So that's all working. Of course, we have the output here, which is, let's face it, that was expected, right? We knew that was going to work. This is a demo. I don't make mistakes. I just wanted you to see this pretty ASCII artwork. Now, the ASCII artwork is one of the compelling defining features of the modern age. We've integrated it into Spring Boot for you. Now, you can change the ASCII artwork, but when people ask me how to do that, I start flipping tables. It drives me crazy. What arrogance. Do you think you could do a better job than that? I think not. I think not. Now, it's very, very well done. We have people on the Spring team that are doctors, my friends, PhDs. In their previous lives, they were nuclear physicists. They concerned themselves with the star stuff, the very celestial bodies in the heavens above us, the keys to humanity in the future that we will all share in one glorious redeeming horizon. They were working on that, and they decided that in order to better improve their lot and ours, they wanted to work on Spring instead. So it makes me happy to imagine that at one point they got a GitHub issue saying, darn it, we need good ASCII artwork. And they delivered. It's beautiful. Now, it's at this point that I wanted to take issue with IntelliJ. Okay? I like IntelliJ. I think they've done a good job. But this, what the hell? Who added that? Why? Why is that there? So I think maybe a petition is in order, change.org kind of thing. I don't know. We can stop this, my friends. Okay, so that worked. We've got an app. It's up and running. But it's 2015. And so, of course, we're going to have a REST API. If you build a microservice in the forest and nobody connects to it, did it really actually work, right? So I'm going to go ahead and stand up a REST controller. I can just do that like so. I can say at REST controller class reservation REST controller. And I'm going to say private final reservation repository. And I'm going to create a constructor like so at AutoWired. You could, and indeed I may, because I'm lazy and we have very small screen real estate, you could just inject the field directly, but that frustrates your ability to do unit testing, right? Every time you do injection on a field, a unit test dies, and that's no good. So I have a small screen buffer, so do as I say, not as I do, okay? I'm gonna leave it like that. You should prefer constructor injection. It's good, clean, object-oriented fun. Now, I'm going to stand up an endpoint here. I'm going to say request mapping / reservations collection of reservation, and I'm just going to return all the reservations in my repository like so. Okay, and restart and drink some water. Oh my goodness, it's good water. Localhost reservations like so. There we are. There's my data. Very, very simple. Not particularly amazing, but it does work, right? Now, let's face it, this is actually a lot of work for what I'm trying to get done here. I just want a REST API to map the state transitions that my repository knows about to HTTP, right? I want to handle the transitions of my state from creation, reading, updating, and deleting, and map them to HTTP verbs. That is REST, right? So I'm going to go ahead and remove all this extra superfluous code, and I'll just let Spring Data REST take me home. So I'm going to say at REST repository resource. Oops, hello. Nope, REST, no, REST repository resource. There we are. I'm going to map this to a path. I'll say that I want somebody to be able to find my search endpoint by the logical path by name. And I'm going to map my parameter here to an HTTP request param, query param, like that. And then I'm going to restart, taking water as I go. Oh. Okay, so now, restart. Now I have the same data as before, right? This is my reservations one, but I have more, right? This is hypermedia, links. If you think about the way we as wetware interact with the web, we go to a website, say Amazon or Google or whatever, and we click on links, progressively moving towards a goal, hopefully, right? Some of us just spend all day checking Facebook, meandering on the endless depths of somebody else's social life. But a lot of us use the web for functions, and in that goal, we have to click on links, and we take cues from the text that surrounds these links. We say, oh, to proceed to checkout, click this button, right? That tells you what to do, and you know to click it. That's a protocol of sorts that you, as wetware, understand when working with a web page. Hypermedia clients or REST clients want that same ability. They want the ability to figure out based on cues what they can do next, where they can navigate next, how the protocol should work for them to achieve a goal. And these links provide just that. These links, in fact, we already see them in our daily lives. If you know anything about HTML, you know there's a link rel, text CSS, source equals x.css kind of setup, right? Where we have an HTML element in the payload of an HTML document that tells the client, the browser, what it needs, what relevant or related resources it can use to style the document that it's looking at, the payload that it's looking at. This tells the browser that if it wants to know where the style sheet is, it should go to x.css. The browser doesn't know about one true location for x.css, right? There's no style.css default. It doesn't just load that if it's there. You have to tell it where it is, right? And that's good because you may change where the style sheet lives, and that's okay so long as this link is here. There's a little bit of indirection. The client doesn't have to have any a priori knowledge of where the resource lives. Similarly, if I'm using a REST API, I don't want to have a priori knowledge of where these different endpoints I need live. I want to be able to move them around. I want to be able to insert other steps in between. I don't want clients keeping the deep links of my API in their heads. Instead, I'd much prefer that they kept the rel, the text CSS, or in this case, self or reservation, or perhaps another link like for profile photo or whatever, right? That's the contract. The client consumes the link, not the URL. This promotes long-lived services. We call this hypermedia. And if you look at Roy Fielding's doctoral dissertation for his university, it was on hypermedia. It was on this idea of using the web as a self-describing way to achieve a goal, a protocol.
But should that be under the options method instead of get?
Options just tells you the verbs. It doesn't tell you the URLs. It tells you that you can use HTTP GET and post and put, but not delete maybe or whatever, that kind of thing. So yes, in tandem, and Spring Data REST will it'll automatically support the options verb for this as well. So that's hypermedia. It's an implementation of the design pattern called HDOS. Hypermedia is the engine of application state. For further reading, I wholeheartedly, full-throatedly recommend you read Dr. Jim Weber's amazing tome, REST in Practice by O'Reilly. Great book. But it's also one of the fundamental precepts of a good microservice API. Give your client the ability to navigate the API without any a priori knowledge. If you do that, your services are more immune to changes in topology. If you need to change your API, why wouldn't you, right? Your business is going to change. Certainly the API will as well. You don't have to make it a breaking change. Great. So now we have a REST API. And we can stand up clients that can talk to it, and indeed we will. But this is not all that you have to worry about when you build a service. Remember what I talked about earlier. We at Pivotal care about moving code quickly and safely to production. We don't care about building REST APIs. I mean, we do. But nobody wakes up saying the ultimate goal of our business, the raison d'etre for us, is to build a REST API. It's not. It's to help build APIs and apps that help get moved to production quickly, right? If you're not delivering business value to your customers, you're not earning your keep, right? So if it's not in production, it's not helping. The only differentiating thing, the only thing that we can do that differentiates our ability and our business's ability and our organization's ability to advance, the only thing we can do is write software and get it into production. Software that isn't shipped isn't software at all, okay? It's just waste, it's inventory. So what do we need to be able to move this code into production? What gates our ability to move this? There's lots of non-functional requirements that plague the deployment, and we all know how painful release can be, right? So there's all sorts of methodologies, things like continuous delivery and continuous deployment, and even the Agile Manifesto itself speaks in three different points. It speaks explicitly about the conveyance of code into production. But are there things we need to add to this application before we can get to production? Are there things that the operations team is going to ask us for before we can move this into production? No doubt, right? There's a lot of things that you need to be production ready. There's a great book by Michael Nygaard called Release It. How many of you have read that? Have you had a chance? If you get a chance, release it. Keep it under your pillow. Read it to your kids. It's a great book. Great, great tome. And it talks about all these sort of things that you need above and beyond. The punchline is code complete is not the same as production ready, right? But that's not differentiating software either, right? It's non-differentiated heavy lifting. All these other things, health checks and metrics and all these other things, they're there to serve your ability to understand what your app is doing in production, but nobody's going to promote you for doing it. Your boss isn't going to pat you on the back and say, well done, here's a raise for a health check, right? It's non-differentiated heavy lifting, which we need to avoid at all costs. So Spring Boot aims to sort of handle as much of this as we can up front, and to make it so that it's a upfront concern that you address quickly and early and you don't have to write or waste too much time dealing with. So to support that use case, we've got the actuator here. There's the actuator. Okay, and now I'm not too sure, but as I understand it, an actuator is sort of the physics equivalent of the Bruce Lee 1-inch punch. It's a way of turning a little bit of energy into a lot. I'm not, sorry. In our case, it addresses these non-functional requirements. So I've got it already on the class path. And if I visit my reservations endpoint, I can go to reservations 1. I can go to, whoops, that's cached. There we are. Reservations 1. Reservations 2, reservations, whatever, visit. If I go to /reservations, go to, I don't know, I guess that's it for now. Oh, by the way, I can also go back to /. You see there's a link of options here, a menu, right? So I can start from 0 and still figure out where to go. And then if I scroll down, you can see I've got a link to the search endpoint. I forgot to show you this. And the search endpoint, of course, has a link called Find by Reservation Name, which links to my search by name, and it takes a parameter, RN, and so here I can search for Tom, was it, and get that back. I can also do paging and sorting, and all that comes for free. So anyway, I've made requests now to several different endpoints. I can understand what I just did by going to /metrics. Okay, metrics is just that. It's a set of keys and values that give you information about the state of the application. How much memory do you have? How much memory is free? The uptime, the peak, the classes, and indeed the requests that were made into the system. So it looks like I made 14 different requests to /reservations, /1, 2, 3, whatever, and I had a status code of 200. I made 3 requests to just reservations, and I had a status code of 200, etc. Okay, so that's very convenient. But I also want to see a deeper dive. I want to see what requests were made, when, and what their headers were. So I can go to /trace. Trace gives me an enumeration of both the timestamp for a given HTTP request, the HTTP verb, the endpoint, and the headers. Okay, but it only keeps by default the last 100 elements in memory. So I'm not going to get 101 elements, but you can configure that to use a larger buffer, or you can spool it to disk. You can do whatever you want, but by default you get 100. Okay. I also have the env endpoint. The env endpoint tells me what my environment looks like. It shows me both system.get properties, right? All the different properties in my JDK, as well as my system environment, my get-env method, right? And thankfully, the sort of private bits, the salient bits, the access keys, the consumer key, the token or secrets rather, or passwords, all of these are masked off, precluding access, right? So you're not giving away the keys to the company here. So that's all very good, well and good. We also have beans. Beans tells me all the objects that Spring Boot has wired together for me, right, and their arrangement. So here, for example, is my reservation service application. That's the class that we've been working in that lives at this type. It's a singleton. We have the repository entity controller. It lives at this URL. We have, I don't know, whatever, right? We have all these different types, their scope, and their actual archive asset, the class, literal. I can go to mappings. Mappings tells me all of the endpoints that have been exposed to HTTP. So your security people will love this. This shows you which endpoints have been exposed, and where possible, things like the HTTP verb or verbs applicable to that endpoint, as well as any other metadata that we may know. For example, the content type that's produced by that endpoint. If you stipulate that in the Spring MVC request mapping annotation, that's all visible here. Okay. This is all very, very useful if you're trying to build a system that's certified for production. One of my favorite endpoints, of course, is info. It has an empty link. It's just a link at the moment. The goal here is that you should interpose your own useful values. Perhaps the git commit ID that triggered the release of the build. Put that here. Do Maven resource filtering and have that property added to the info dot asterisk property in your application.properties. Maybe you put the service ID, the Maven service ID, so that way if somebody wants to know which service is running on this port and service, they go to /info, and it shows them the git commit for the version or the service ID, whatever. Use Maven resource filtering, add all the interesting salient bits here. Another endpoint that I also particularly love, because I've worked on more than enough systems that had this particular endpoint, we had to do by hand, is /health. Okay? Health is just that. It's an enumeration of all the things that we can understand about the system by default. So the disk space, for example, we know how much disk space you've got. We know that the disk is up. That's helpful. We've got a database, and the database is in turn wrapped in a connection pool, which has a validation query. The validation query returns something like select one from dual, and the results are shown here. So select one from dual. We know that it's H2. We have all this. We can automatically infer all of this. But this is our application, and of course, we want to be able to inject semantics to these endpoints. I'd like to be able to create my own metrics, for example. I'd like to be able to qualify, from a business perspective, the health of my application. And maybe I'd like to secure these endpoints and move them to some place where they're cordoned off from general access. So I can go to my build here. We're going to start with application.properties. Okay? Application.properties is what Spring Boot will look at by default, although you can use anything. I'm going to do a few things. I'm going to say, well, first I'm going to use management.contextPath, and that'll nest or root all of my management endpoints, the beans, the health, the metrics, all that stuff will be rooted at /admin. I'm going to also go to my Java code here, and I'm going to contribute a custom health indicator. I'm going to say bean health indicator. And mind you, there are lots of other health indicators that Spring Boot already provides. For example, Cassandra, data sources, disk space, Elasticsearch, JMS, Java Mail, MongoDB, Reddit, RabbitMQ, Redis, and Solr all have default health indicators that, if the right types are in the class path, will be applied. Okay. But I want to contribute my own because why not? So here we are. It's a very simple contract. You say return new health indicator, and you return the health. Of course, this could be a bean, and it could even receive state notifications. Maybe you have a Spring MVC controller, something goes south, you can throw an event bus event, and then this component can listen for that if you want, or you can just call a method on it, do whatever you need to, but you can tell the health indicator what its state is from another component, naturally, right? And in my case, I'm just going to return the same thing every time. I'm going to say, I'm not going to say it's down or out of service or whatever, I'm just going to say status, I heart Java 1, okay? .build. Fairly simple. And naturally, this is a Lambda, so Lambda friendly. So good. Now I've got that. And of course, I've showed you the REST endpoints, the REST exposures of the state, but there's other ways to do it. So I'm going to go back to my build here. I'm going to bring in the Spring Boot starter remote shell, okay, and restart. Oh, can you guys hear that? That was amazing. Oh, so good. Sometimes you wake up and it just doesn't happen for hours here. Small things, man. Okay, good. So that's this. Doesn't work, right? /health is now /admin health, which means that I can apply a Spring security rule and mask off access to that if I want. Or indeed, just add Spring Boot starter security, and it'll apply default HTTP basic protection. But I've done none of that, so I've just masked it. And I've got my custom health indicator. There's that, right? This is one way to go, of course. I could also use JMX. Anybody here use JMX? It's the new old thing. Anybody here remember SNMP? No one? Okay, well, never mind. So anyway, connect, insecure connection, mbeans, org, spring, framework, boot, endpoint, and there's all the sort of endpoints that I had there before. Health endpoint, operations, get data, and there's my custom, there's my custom health indicator as well, okay? So you get that all for free. I added the remote shell, which I love. The remote shell, absent any Spring security configuration, is going to print out a default user and a default password. So that a user is called user and the password is here as printed out in the shell. You can use Spring security to talk to Active Directory or LDAP or PAM or Kerberos or OAuth or SAML or anything, really. I mean, there's a integration for all these different back-end identity providers. But absent that, I'll get a default user and a password here, okay? So I'm going to take that password, SSH-P 2000 user at 127.0.0.1, okay? Port, or paste rather. Good, quality, calming, refreshing ASCII artwork in a production crisis when you're under triage. This is something that'll be very, very helpful and relaxing. I'm going to ask for help, naturally. Here we are. I've got some options. I can look at various endpoints. For example, the metrics endpoint is here. This is live. I don't know if you can see the numbers animating in the back, but I'm not prompting it. I'm not touching it. I'm not provoking it. I can also look at the various endpoints. I can say endpoint list, endpoint invoke, health endpoint. And notice I get tab completion and all that. And there's my, I love JavaOne, my custom endpoint. That's there now. My favorite perspective, of course, is dashboard. There we are. It's a little wonky because of resolution. So that shows you Java top, basically, as well as all the memory pools that, the famed memory pools that make the JVM such a wonderful platform. All this information that you need to be able to fine tune and optimize and to measure. You can't fix what you can't measure, right? This is what this is all about, is getting feedback, understanding what the system is doing, and tuning accordingly. So you've got all that here as well. You're using Metaspace in Java 8, but if you're using one of those other non-recommended older JDKs, you'll get PermGen instead. Now, these are all views on the same state, and there's other ways to get this state as well, right? We even support exporters. So for example, the metrics exporter hierarchy, we have an interface rather, called metrics exporter and metrics reader, and they plug into back-end visualization systems, things you can use to get joined up views from your services across a cluster. It's nice that I've got all this information here in my single node, but what I really want is an aggregate view of all of this in a single place. And for that, things like Graphite, or OpenTSDB, or Ganglia, or StatsD. These are all invaluable, really, really powerful, battle-tested tools for visualizing these things. Most of them have to do with metrics, but some of them are about cluster visualization and so on. OpenTSDB is, I think it was developed by Twitter. It's based on HBase and so on, so it, mega scale. Graphite is dead simple to set up, and I've seen that work for millions of users. It's great as well. It gives you graphs, so you can emit metrics into these things, and it'll automatically visualize them along a graph in terms of a graph. You just plug in the bean of the right type, and that'll work. The benefit, of course, is that a metric in a single point at a single point in time doesn't tell you anything. You need to see what it's relative to. If it's at 10 now and it was 5 a minute ago, is that good? Is that bad? You can't tell unless you know both. So the graph gives you that ability. You can visualize these spikes. It's very, very easy to do. StatsD may be your most useful one, right? The StatsD metrics writer speaks the StatsD protocol. StatsD was originally a daemon, started by Etsy, I think. And the daemon was originally written in Node.js, so nobody uses it because it doesn't scale. But they do use the protocol. It's become sort of a de facto protocol for metrics shipping. And all manner of different technologies consume that same protocol. So if you use the StatsD metrics writer, you can plug into all sorts of other ones, even if we don't have a specific metrics writer. Going further, we also support the Dropwizard metrics library, right? Which we love, and it definitely inspired a lot of what we did in this support here, right? So if you have that on the class path, and you use one of the metrics exporters that comes from the Dropwizard metrics library, that'll just work, right? So it also gives you the benefit of having histograms and gauges, right? So you can actually get a gauge. We have counters. A counter is an absolute value at a point in time. A metric is a number that could change. So you may have I'm sorry, it's the other way around. A metric is a number that is an absolute value. A counter is a changing value. Maybe you have 10 jobs in the queue, and then you have 5, and then you have 100, right? The counter will tell you where you are relative to that. and so on. But a gauge is really nice because it gives you the histogram. It gives you the 5th percentile, the 90th percentile, the median, all these different other numbers. And it'll compute that using statistical sampling for a range of numbers. And it'll output all that. And if you forward all that to things like Graphite, the graph becomes even better, right? Now you have the ability to see all these numbers over time. Very, very powerful way to build a system. Which is what we want to do, right? You want feedback. You want the continuous integration loop. You want to be able to see what your system is doing and to react accordingly. Now, deploying this is also very simple. You have options, right? So I've got this application running here, public static void main. I can do a couple of things. I can, of course, I can deploy this to any cloud. So if you have a modern cloud platform like Cloud Foundry, which we have, or Heroku, or App Engine, or whatever, you can just do CF push, for example, and this jar will start up on Cloud Foundry and work. But if you're not doing that, you still want the ability to manage this stuff easily. This is in my downloads. Nope. Downloads, reservation service. CD. OK, there we are. Maven clean install. Did I kill that? Good. Drink some water. CD target. I have here a so-called fat jar. This contains everything I need to be able to deploy the application without any other dependencies. It's everything. I can just email this to my grandpa, and he can run it, right? He's got the ability to run applets. So if your operations team balks at having to deploy this, you can fire them. It's the law. I checked. It's OK. Because it's Java minus jar. It doesn't get simpler. It really, really doesn't get simpler. Now, of course, I may want to override things. I may want to specify different ports, for example. So I can say Java minus jar reservation service. I can say -d server.port equals 8010, right? So remember in my application.properties, I specified management.context path. I could have also specified server.port or SSL or whatever. All these other things that I want to configure, they can all be specified by properties. But if I want to override those properties, I can do so here. I can say server java.-d server.port 8010, and then run the application, and it'll spin up on port 8010. And the reason we support, by the way, the configuration of these kinds of things like gzip connectors and SSL and all that stuff, is because we've seen all too often teams have one app per container. I almost never see more than one app deployed per application server. And by far, the most common container I see these days is something like Tomcat or Jetty. Sorry? Oh. So here we are. It's on port 8010. And the point is, if you've got one app per container, and these apps usually have configuration that's specific in the container, and they have to specify it in the container, things like SSL, right? These are specific for the app, but they can only be configured in the container. This made sense 15 years ago. The economics bore out why you would do that. You would separate the container from the application because you were going to co-locate multiple applications per container and save space on the class path. Dynamically linked libraries were a thing 15 years ago. But the economics have made it so that we don't really care about saving 20 megs of RAM for jars anymore. Indeed, it's actually more trouble than it's worth. If you look at languages like Go, Go doesn't even have the concept of a dynamically linked library. It's just too much pain, right? Even .NET 15 years ago said, yeah, well, we'll just repeat the class path each time. .NET assemblies can have their own copy of the whole class path, so you can have multiple libraries loaded on the same system. It's time to let go, friends. We don't need that. We're not trying to optimize for saving space on class path RAM, which is great. But we still have this separation, this illogical separation between developers and operations. The developers build the assembly. The operations manage the server. Well, in every other aspect, we've managed to converge. That isn't a thing. We're not trying to be two different organizations anymore. I just talked about at length how we shouldn't be throwing things over the wall for another team to work on. There should be a communication cycle, right? These are the same teams. If you build it, you ship it. If you build it, you run it. That's what Amazon focuses on. That's what Netflix focuses on. It's what you should focus on, right? It lets you go faster. So we made it so that these concerns, which were otherwise teased apart, are now co-located. You can specify ports and SSL and all that stuff from a property. And you can override them here and, on the command line, or you can say echo server dot port equals 8020 or 8030 application dot properties. I could also use a YAML file. That's one option. I can also do things like export server underscore port equals 8040, and then do Java minus jar reservation jar. Now, I'm still going to have to write a script. I've got this jar. One of the things that people love about deploying into a Tomcat is because it becomes the surface area of the container is what operations knows how to use. Even if you're building a batch application that doesn't actually stand up a web service, it just does ETL or whatever, they still deploy into Tomcat because there's a start script and a stop script and it manages logs for you and all that stuff. Well, we wanted to make it easier so you don't have to recreate that each time. So that executable configuration thing I showed you here in the build, I added configuration executable equals true. That gives you the ability to just do this. Now, what I've done there is I've run the jar with // right? How many of you, by show of hands, know how the JVM reads jars? Does it read from the top down or from the bottom up? Or actually, how does the operating system read a jar or read an application? Does it read from the top down or from the bottom up? Anybody? Well, so an operating system reads from the top down. It'll take your file, find the offset into the disk that your assembly lives, and read down until it gets to the end of file. The JVM, on the other hand, gets to the end of the jar and then reads backwards. So you've got an opportunity to do some crazy stuff here, right? So what we've done. Oh, by the way, that was running on port 8040 before I killed it, right? There's that jar, the environment variable. So what we've done is we've mixed them. So I just did less reservation-service, and you can see we've got shell script, 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 bytecode, right? And you even see there's commands here. The shell script responds to systemd and initd callback lifecycle methods like stop, start, status, etc. So you can chuck this jar into your initd directory, and then you're done. It'll get started when the operating system starts. You can restart it with standard commands, halt it, resume, etc. It manages the PIDs and the logs. Yep?
What about memory configuration and stuff like that?
There's environment variables you can use to override everything, right? So same old, same old. But we make it as easy as possible to get as much as you want done. So we're trying to make it so you can get code safely and quickly into production. I think that's the takeaway with Spring Boot. What we've done thus far is make it so that the friction associated with standing up a new service is nil. It's as minimal as possible. We added Spring Boot actuator, added a health indicator, we added the executable configuration, and we've got something that we can deploy and manage easily. If you're using a platform like Cloud Finder, you don't even need the executable bit. It'll manage it for you. It'll wear the proverbial pager. All of this is working thanks to the magic of something called spring.factories. So spring.factories is a text file that lives in any jar. Your jar is included, if you like. And it provides, here we are. It provides, among many other things, an attribute. Org Spring Framework boot, autoconfig enables autoconfiguration equals, and then a comma delimited list of Java configuration classes. These Java configuration classes are myriad, right? So Cache, Cassandra, Batch, JPA, Mongo, Redis, blah, 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 right? All these different things. If I go to Rabbit auto configuration, here we are. Scroll down, you can see it's a regular Java configuration class. It's the Spring Bean definition configuration class, right? And these bean methods, just like my health indicator and my command line runner, return a bean that Spring is going to manage. But I don't want to define a RabbitMQ, for example, Rabbit template, if I don't have the right classes on the class path to be able to define that bean. So this configuration class is guarded with these conditionals. These conditional on class, for example, says that I only want to evaluate the contents of this Java configuration class if the type Rabbit template and channel are on the class path. Sort of the Java equivalent of if-def. Similarly, I want to define a Rabbit template, but only if the user, that's you or I, hasn't already defined their own bean of type Rabbit template. Right? That way I can exercise control and provide my default, my own implementation, my own specialized implementation. But if not, I get the right fallback. And these fallbacks are only activated if the types are on the class path. That's the benefit of using those starter dependencies. You add Spring Boot starter RabbitMQ. It brings in the right types to light these conditions up, and suddenly you get the right configuration out of the box. Spring Boot uses this mechanism to great effect, and you can use it yourself as well. If you have a lot of services, you're going to want to ensure that you have consistency across those services. You can stand up your own spring.factories text file and your own auto configuration like this one. Register, for example, your own security profile. Maybe your organization has a standard LDAP, service that you need to all services need to talk to, or maybe there's a OAuth or SAML flow that has to be consistent across all your services, or whatever. put that in a jar, put it on the class path, and voila, it's done. And then the users of that jar, instead of following a 20-page wiki document with all the steps needed to stand up a new document, a new service that can be deployed, they just add this to the class path and they're off to the races. The friction of standing up a new service goes away. A service that's production ready, no less, right? Great. So now we've got a service. We've got one service. That's all we've talked about in this last hour. But we did talk about a lot. I think you'll agree. But this isn't enough, right? We're moving into the microservices world. And as I mentioned earlier, there's a lot of friction associated with that. So in the next 15 minutes, I'm just going to cover everything I can. I mean, there's more, obviously, than I could possibly hope to cover. But what we're going to do is address common patterns typical of a microservices world. The first thing that a lot of organizations want when they, let me see, get rid of that. The first thing that a lot of different, yep, that's running, good. First thing that they want when they move to a microservices world is to be able to centralize configuration. I showed you that you can use -d arguments or environment variables or application properties or YAML files to provide configuration, locators, credentials, all these kinds of things that change from one environment to another. This should be externalized. You shouldn't recompile the service from one environment to another, right? That's just good, clean app and release hygiene. But doing so by using environment variables can be a little tedious, error-prone, if nothing else. Suppose I want to change a configuration property across 10 services. Do I have to log into every instance, restart the process, and change the configuration? What if that property is a password? Do I really want the password visible in PSAUX, right, in the environment variables? I could encrypt it, but who's going to manage the code to decrypt it? That's something you have to write yourself, right? What if I want to change a value live, right? You hear all the time about things like canary releases or feature flags, doing dark launches. You have a feature that's in the code, but it's latent in the deployed release. If you decouple deployment from releasing, then you have the ability to stage features for a small set of an audience and then activate it and make it live for a larger set when it's proven to be good. That's a very, very useful thing to do when you have this microservices model. But that implies that you have to have the ability to toggle things at runtime. For all of these reasons and more, the existing mechanism, -d arguments, environment variables, even application.properties files that live adjacent to my jars are not sufficient. So to sort this kind of scenario, we have the Spring Cloud config server. So what I'm going to do is I'm going to stand up my own config service here. Let's get rid of all this stuff here. Voila, goodbye. Okay, and I'll add config server. And that'll do, right? I've named it config service. Open. And what I want to do is I want to stand up a REST API that'll in turn manage a repository of configuration files, right? I want to be able to journal those configuration files, roll them back if something should go wrong. I want to be able to see who made a change. What if Josh goes to the amazing JavaOne community parties, gets all sauced up, and then starts logging into production and changing, properties? Shouldn't I have a way to audit what happened, when it happened, and what changed, right? It turns out that things like Git and Subversion are very good at just that exact chore, right? So I can stand up a REST API here that'll monitor and front a repository based on Git or Subversion or whatever. There's alternatives to this. We also support that as well. We have Zookeeper support and console support. So if you want to store your locators and credentials in those instead, it doesn't matter, right? Either way, the way you use it from the client side, from the Spring perspective, is the same. You can use @value annotations. You can inject the environment and ask it, programmatically for the properties and so on. But I'm going to use this. This is fine. So I'm going to say that this is a config server, like so. So @enable config server, and I need to configure what repository this thing is going to manage. So I'm going to say Spring Cloud config server git URI equals home desktop. I'm going to say beautiful microservices config. I think that's right. Let's verify. Desktop. Yep, there we are. So I've got a desktop. In my desktop, I have a set of files, .property files, but they could be .yaml files as well. And each one of these property files contains keys and values, just as we have in our application.properties. I want this REST server to be able to find them here, and I also want this REST server to listen on port 8088. So There we are. Everything else will connect to this REST API. So this is going to stand up, and it's going to be a sort of a gateway to all the configuration. Everything else will talk to this REST API instead of the configuration files. So now we have a central place to do things like at-rest encryption and decryption of properties, of passwords. We now have the ability to do feature flags because we can ask the client to just /reservation-service /master. And you can see here I've got my REST API. This is what for a service that identifies itself as reservation-service, this is the set of configuration values that it will receive. There's two property sources. There's, of course, the properties that live in my beautiful microservices config repository in the file called reservation-service.properties. And there's also the properties that live in the same folder, but application.properties. So only a whole its configuration. This I can say server.port equals the environment variable port if it's defined. Otherwise, fall back to just the literal 8000. Very convenient. I've got server.port specified here, and I have it specified here. But of course, because of the rules of priority that I just described, the more specific file here will override what's in application.properties. So this is the REST API. I'm going to connect my client. I'm going to connect the reservation service that we've just stood up to get its configuration from here. If we do this right, we should be able to inject this message called hello world, and we should be running on port 8000. So let's go back to our reservation service here. I'm going to add the Spring Cloud config server client. Okay, like so. Actually, I'll just do Spring Cloud starter config. It's even better. There we are. And notice that this is the same approach as before, Spring Boot starter actuator, but now I'm using Spring Cloud. It's just a set of auto configurations based on Spring Boot. Same approach, same everything, separate namespace. Okay. Once that's on the class path, I only need tell Spring Boot what to do. So I don't need this anymore. I need to give my service a name. It's going to identify itself so that it knows when it contacts the config server, it's going to say, my name is reservation service. Give me the configuration for that service. So it's going to say reservation service is the Spring application name. And I'm also going to tell Spring where to find the config server itself. By default, it's going to look at localhost 88. Right? So this is redundant, but I want you to see how to do it. And this information necessarily has to be loaded before the rest of the configuration. Naturally, it's a bootstrap, right? I need to tell Spring to get its configuration from the config service. So I can't load the configuration service at the same time as I'm loading things like the port and so on. So this goes in a file that's by default called bootstrap.properties. Okay? Bootstrap.properties. And that's basically the only boilerplate you're going to have from one service to another. As you add more microservices, you're going to have a file, a text file called bootstrap.properties that identifies both the name of the service and where it should find the config server. And indeed, even this, you don't actually have to define it here. Remember, you could have said export spring underscore cloud underscore config underscore server, or sorry, underscore UI equals whatever, right? It could have been an environment variable specific to the process. Okay, so now I've got the application. The first measure of success will be, does this thing start on port 8000 instead of 8080? We'll see if that works, right? The second thing I want to do is inject that message, that silly message, hello world, and do a live refresh. So I'll say at rest controller class, message rest controller, and I'll say at value. Now this is Spring's syntax for injecting a message key or property key, right? And it would work for any source. That's the value of this. Is that if it was in application.properties, if it was a -d argument, if it was application.yaml, or if it's in a config server far, far away, doesn't matter. Ultimately, it's available through this annotation. So I can say private string message, and I'll say request mapping message string get message return this dot message. Okay. And I want this bean to be refreshable. I want to be able to change the config value and trigger the class to reload itself, that one little property. I want it to be able to refetch its configuration. So I'm going to use the Spring Cloud's refresh scope. It's a scope just like request and session and page and whatever, right? Okay, let's see. The proof is in the pudding. Here we are. Looks like it worked. So it's on port 8000. Okay, that's part 1. Now if we go to port 8000 /message, we see the string hello world. That's a silly string though, we can do better. So I'm going to go back to my config repository on the file system, open up cd desktop beautiful show reservation service.properties. I'm going to change this message here. I'll say hello JavaOne command X git commit -m YOLO git status. Oh, what? -a. Okay. That's the droppings from my editor. It's just a little tilde file, so I'll delete that. Hello. Yep. Good. So now if I go to the config server here, this is the old state. If I refresh it, you'll see it says hello JavaOne. But my service itself hasn't been updated to reflect that new value. I want to be able to change the value in my service, which is getting its information from the config server. To do that, I'm going to use the actuator endpoint, a new actuator endpoint that's been contributed by Spring Cloud, to trigger the refresh. I'm going to say curl -d, curly bracket. That basically means empty post, localhost, colon, and then I'm going to trigger the reservation services endpoint. Okay, so it's port 8000 /refresh. There we are, right? So I was able to change the value live without having to restart the process. This is very, very powerful. Now, naturally, this is still a little tedious because you'd have to visit every service. So you can use the Spring Cloud bus, that's just another checkbox, and have federation through RabbitMQ. So you send a message on RabbitMQ, and every connected microservice will automatically refresh itself. All beans so annotated will automatically see the new values with one message. The burden from your perspective is instead of saying curl -d local, blah, 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 refresh, you say bus refresh, if you have that, to any one node, and then the rest of them will automatically refresh themselves. So this is one way to go. This is, again, you could use console or Zookeeper as a configuration source as well. This is nice, I think. Now, there are other patterns we need to move on to, so I'm going to go quickly here. When you have a distributed system, configuration is certainly one thing you want to take care of. Another one is service registration and discovery. In a sufficiently distributed system, sorry friends, I'm fighting a cold. So in a sufficiently distributed system, you can't afford for your services to be coupled to their host and port, right? As services come and go in a microservice world, in a cloud world, your applications are going to change where they live and their host and port and how you can find them all the time. And indeed, even if they aren't, you still want to be able to choose. You still want the ability as a client to these different services to be able to choose which instance to route the request to from your side. That is to say, instead of letting a router, which sits in front of a load balancer, instead of letting DNS, which sits in front of a load balancer, manage which instance of the service gets called, make the decision on the client. This is called client-side load balancing. And the reasons you might want to do this are many. Suppose you wanted to do round robin. Naturally, any decent router will do round robin. Any decent load balancer will do round robin for you, no problem. What if one of those instances is sick? Your load balancer has to have some pretty sophisticated controls to figure out that an instance has fallen down. It may still try and request or route requests to that sick instance. There's no way for you to ask the question, are you sick? You just have to trust the load balancer. Even if you're not trying to do, what if you're not trying to do load, round robin? What if you want to do multi-tenancy? Maybe you want to route certain requests for certain ID ranges to a certain set of nodes. How do you do that? You have to program that into your load balancer. What if you're trying to do sticky sessions? Maybe you want to have, maybe you're streaming video and you need to call the service specifically on that node for a given client, token or session cookie or whatever. Lots of different reasons why you'd want to change the routing. But the point is, if you have that baked into the load balancer and in the router, you lose the ability to evolve that configuration without, first of all, asking somebody else, and second of all, possibly disrupting other services. Much easier to instead keep that information and keep that responsibility on your side. So Netflix has a library called Ribbon. Ribbon is a client-side load balancer. You provide an algorithmic strategy. By default, it's round robin, but again, you can plug in your own implementation. And it'll choose from among the available instances which node to call. So you need two things to make this work. A service registry, a phone book, if you will, that maps from logical service ID to a one-to-n collection of services. And you need the Ribbon client-side support. So we're going to add that to our reservation service. First, we have to stand up a registry. We support lots of different options, right? So I'm going to use Eureka. You could, of course, use Console or Zookeeper or etcd. That's in the works. It's not GA yet or on this checkbox. You can also use Cloud Foundry or Lattice. They all provide the ability to act as a sort of logical phone book from service ID to host and port. And other than that, I'm going to remove this. I'll say I want to be a config client. So here we go. And I'm going to say I want to be a Eureka server. So again, this is a little weird. I'm going to stand up a Eureka server here. Most of what you're going to do when you talk about service registration and discovery is going to be acting as a client to some other already stood up service. Console, for example, is from HashiCorp. It's written in Go. So you don't use Spring Boot to install the Go language console service registry. But because Eureka is so tiny and so amenable to Java programming, we can let you stand that up using Spring Boot here. So I'm going to say that the name of the service is Eureka Service. I'm going to go ahead and hit Generate. Here we are. Open. Drink some water quickly. And same as before, I'm going to point this to my config server as I did before. And I'm going to tell it that its job is to be a Eureka server. Let's see. Where's my bootstrapped up properties? Okay. Paste. Bootstrap.properties. And I'm going to name this Eureka service. And then I'm going to stand it up. So I'll go back to my Eureka service application. Here we are. And that should come up as per configuration on port 8761. So I'll go localhost 8761. Hello. There we are. So there's my Eureka service registry, listening and ready for action. It's going to eventually bulk at the fact that I've stood it up by itself in a single node configuration. It'll give me, the Eureka equivalent of the finger, telling me that this is a really stupid idea to leave this in a single node configuration. You'll see a big bloody exception in the console. This is its way of telling you that it cares, and for now it's okay. But you do want to have at least 3 instances of this in a highly available fashion. What we want is to see our services registered here, and then to be able to resolve them once registered. So we have to fill this applications table out here. So let's go back to our reservation service and teach it how to talk to our service registry. Okay. So I'm going to go back to my build. I'm going to bring in dependency Spring Cloud Starter Eureka. And I'm going to tell my reservation service that it is a discovery client. So the discovery client abstraction provides discovery client implementations for, as I mentioned, etcd, Zookeeper, Console, Eureka, Cloud Foundry, Lattice, etc. We've added the Spring Cloud Starter Eureka jar or starter to the class path, and that in turn contributed the bean that implements discovery client that this annotation will discover and then make available. What it means for us is that when this app starts up, this particular implementation, which is aware of Netflix Eureka, is going to go ahead and try and find the Eureka that we've pointed it to, that's in the configuration, and say, I'm here. If you need me, I'm on this host, on this port. My name is reservation service. Okay? So we'll get that for free. So that's enough for this app. Let's start that up and see what happens. Refresh, 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 refresh. Oh, maybe I should just drink water. This part's the hardest. There it is. Took forever. So it's now here. And you can see it says reservation service. So that's the logical ID that we had before. It lives on this IP, and of course the port is reflected in the link there. So if I click on the link, it takes me to the info endpoint on my reservation service. So now any client that connects to the registry can ask, give me any available instances of the reservation service. If there's 10 registered, I'll get a collection of 10 instances back, right? So I see here only one instance, but it's one to n. Now I can use this to make routing decisions as a client, which implies that we need a client. So now let's go back to our start.spring.io, and we'll use reservation-client. Okay, and I'm going to basically add a bunch of things here so we can test out a few things. First of all, I want the discovery client, so I'm going to Eureka Discovery. Great, I've got the config client support as well. I want Zool for microproxy support. I want MVC support, web, so there's that. I want Hystrix for circuit breakers, okay? I want, don't want anything else? Sleuth, we'll get back to this. Zipkin and RabbitMQ. Okay, we'll disable some of those, but we need a lot of pieces here, okay? I'm going to hit generate. Here we are. Open this in my favorite IDE. And I'm going to take this bootstrap.properties, copy pasta. Okay, goodbye to all of you. Voila. So that's my reservation client, and this is going to talk via the registry to the reservation service, which we've just stood up. So it's going to be, first of all, I'm going to stand up a REST controller. I'll say class reservation API gateway REST controller. Now, what I want to do is I want to stand up a service that will talk to my mid-tier service, my backing service, the reservation service. This is going to I'm going to stand up the service, and I'm going to expose this at the edge of the network. So if I have an HTML5 client or an Android client or an iOS client, they are not going to talk directly to Eureka and to my backend services. They're going to talk to something that lives through DNS, that's exposed through DNS, and then calls these backend services. It's an intermediary, right? And the reason you want to do this, and the reason companies like Netflix, high-performance organizations like Netflix do this, is because different clients have different security constraints. Often they have different protocols and constraints. And sometimes they have different functions, right? So it doesn't make sense for every, actual client, like a phone, to talk to the same ensemble of services, even if it was practical, which is not, right? A lot of times your clients may have, they want a smaller or changed or transformed view of the data. So that's called payload transformation, or protocol, or payload transformation. They may want a different protocol. Maybe instead of speaking with JSON, they want to use Google protocol buffers, right? Or some binary format or whatever. So that's protocol translation. Either way, you can't retrofit every single microservice each time a new client gets introduced that has a specific quirk or use, right? Security, too, is a kind of a bugbear here, right? You've got to think about the specific requirements of the client environment. All these and more suggest that you need an intermediary, something where you can adapt or stand up a service that's specific to each client. Netflix does this. They may stand up a Roku, a PlayStation, an Xbox client, and then stand up an edge service that handles traffic from those clients to these back-end services, this back-end suite of services. So we're going to stand up an edge service. There's a couple things you can do in an edge service, actually. I shouldn't get too far ahead. Maybe you just want to proxy requests from the outside straight to the backend services. Maybe you have an HTML5 application, and all you want to do is send requests to the suite of backend services, these backing services. If that's the case, I have one problem, which is that I can't run afoul of cross-origin request scripting limitations, right? I can't make service calls from different hosts and ports. And of course, I could go back to each microservice and add a policy that allows cross-origin requests. But if you have more than a few of those, that becomes a pain, right? You lose the ability to do upgrades if you have to stand up or restart all of these different microservices. So it's best to avoid that. Another reason you want to have this intermediary. So what I want is actually a proxy. So I'm going to use @enable Zool proxy. Now, if you know your Ghostbusters mythology, right? So Ghostbusters Zool. Oh, isn't he cute? So that's the gatekeeper, the guardian of the underworld in Ghostbusters. And it sits between the world and the underworld, right? We want a proxy that'll stand between our clients and all of our backing services. So we're going to use Netflix's Zool proxy, which I've got on the class path. I've said @enable Zool proxy. I'm going to hit run. And this is already configured to run on port 9999, I think. Could be. So localhost 9999. And what I want to do, yep, 9999. What I want to do is I want to call the reservation service from this proxy. I don't want to have to call different services. So I want to have every service in my registry available from the same host and port, just a pass through, right? So I'm going to go 99.99/reservation-service. This is the logical ID of the service as it exists in the registry. /reservations. Okay. And then I'm going to be sad because it didn't work. Oh, no. Rats. Sorry, friends. Forgot to disable 2 bits because we don't need them just yet. Goodbye. Hello, computer. Okay, so that's going to be, we'll take that again from the top, this time without the fail. There we are. So there's port 9999, but I'm calling service ID /service. If I had foo service and bar service in the registry, I could access them as foo and bar service / whatever, right? Now, maybe that's enough. Maybe I just add SSL support to this, maybe add some HTTP basic authentication or OAuth, and I'm done. Right? That could be enough from HTML5 client. I've now got a door that's secure and that's ready to be used from any HTML5 client, and I don't have to worry about running afoul of cross-origin request scripting. I can send anything that I would normally send to any other REST service through this proxy. Maybe that's enough, right? But of course, that would be a terrible demo. Terrible. So it's not enough, right? We're going to also talk about API translation and protocol translation, or rather, this approach here. This is called a micro proxy. That's the design pattern, but we're going to create an API gateway, something that does a little bit more sophisticated than just proxying through to the back end. So let's go back and bring this thing here back to life. And we're going to stand up a simple endpoint that just transforms the payload from the reservation service into a collection of string names. So instead of the actual reservations, we're going to get out the names and just return the names. Simple example of API translation. We'll just do that, okay? So I'm going to say request mapping, method equals get, value equals reservations, actually names rather. And I'm going to map the whole class, this whole gateway. I'll map that to reservations. So it'll be reservations /names is how you access this endpoint. And all I'm going to return is a collection of string names, right? Whoa. Names. And I'll say @AutoWired private REST template. Now, this REST template is provided by Spring. It's a client for making HTTP invocations. It's been around since 2009. Very, very powerful. It makes short work, one-liners for all common HTTP interactions. And in this case, I want to make a call to the service as it exists in the registry. And of course, I don't want to have to call the registry and extract the host and port. So I can use an interceptor that's been automatically auto-configured for us to make that call much more readily. So I'm going to say this.resttemplate.exchange HTTP reservation -service /reservations. Okay? And I'm going to say that I want to make it an HTTP GET call, and that I want to specify no body since it's a GET, not a POST. And I need to tell the return value. I need to tell Spring and Java, indeed, the return value of the object that I want to get back. So remember, it's going to call this service. This is not DNS. This is the service ID as it exists in the registry. The interceptor is going to see that you have given it a service ID. It's going to go to Eureka, extract all of the instances, pass that collection of instances to Ribbon, which will then apply whatever programmed algorithm for load balancing, the load balancer strategy, and then pick from among the available instances the right one, and then make the request to that host and port /reservations. You can plug in your own load balancer strategy, as I say, but by default you'll get round robin. And it's going to, when it calls reservations, remember it's going to get that hypermedia API with those links. So I want to get a collection of hypermedia resources, which in turn have payloads and links. So I'm going to use the Spring HotOS library, to marshal or convert or map the JSON from the service into an object, an envelope of resource and links and so on. So I'm going to say Spring Boot Starter HotOS. Sorry. all this is going to do is it's going to map JSON, but I want to map that weird link envelope structure from my Hypermedia API into something useful. So I'll say resources. What I want to tell Java is to use the org Spring Framework HotOS type of reservation, right? That's what I have on the service side, after all, is a reservations or resources object, which is a collection of resources with links and payloads. And inside of that, I've got a payload of type reservation. Well, of course, I don't have the reservation type on the class path here. That's in my service. I could just extract it into a jar and share them among types, but now I've got exactly what I'm trying to avoid. I don't want my client to be beholden to the service implementation. I don't want to be able to share types like that. In theory, and this is just a theory, I've never seen it proved to my satisfaction. In theory, that service could be written in something besides Spring. Now, I don't want to, I'm not going to go there, but it's a thought, right? Scary though it may sound. So I don't want to rely on the fact that that's written in Java and Spring. It could be written in some of those other non-Spring Java technologies. Now, because of that, I want a client-side DTO. I'm going to say class reservation. And I'll say private long ID, private string, reservation name. Get some getters. And there we go. I'm going to use that. Now what I want to be able to tell Java is, give me a resources of reservation.class. But of course, that's not going to work, right? Java doesn't support generics. At runtime, Java loses its mind about the generic parameters in an instance variable. So if you have a list of string, x, at runtime, Java has no idea. It can't answer the question, what is your generic argument? It doesn't know what it is. It's just object because of type erasure. Okay? You can change that. You can say class x extends array list of string. There you are. And that bakes in the generic information into the hierarchy. Right? So now if I do list of string x equals new x, at runtime I can ask what's your generic argument, and because it's been baked into the parent-child hierarchy, it'll say it's string. So the only way to capture generic parameters at runtime is to subclass. Nasty, but them's just the breaks, right? So to support that, we use the type token pattern. This was introduced by some of the Java architects. I think Brian Getz actually, like 2005, right? So it's an old idea. Parameterized type reference of resources of reservation. Okay, and all I'm doing is I'm creating an object that'll capture its own generic information through subclassing. It's abstract, so I'm forced to subclass it. And in so doing, my PTR captures its own generic arguments, which I can then pass to here. And I can tell Java that I want, as my return value, a response entity that contains the status code and the headers of my HTTP request, containing a payload of resources, which contains a payload of reservation. Okay. And once I have that, I can say exchange.getBody. I don't need the status code or the headers, but I could if I wanted to. I'm going to say give me the body of resources, get the content, stream, map from reservation to reservation name, collectors to list. Right. So very, very simple functional programming in Java 8, nothing fancy. All I'm saying is go ahead and map from reservation to reservation name. And if I was using more than one service, if I were invoking more than one service, I'd use something like RxJava to reactively call two services concurrently and compose the final result. Right? But since I'm only calling one, it's moot. Okay? So I can restart now, and if I did that right, then I should be able to go to /reservations/names and get that transformed view of the state of the data. Come on. Okay. So that's my new endpoint, reservations names. There it is. Right? Coming back from the reservation service. So I'm actually making a call to another service here. I'm getting the transformed view, and I'm sending that back. Great, right? I'm now reading data from another service. I've got a read-only view. But what about writing? REST is very powerful, but I wouldn't, it's not transactional. If I want to synchronize the state of my different services, I can't rely on a REST service being available. And the lazy architect will reach, in this case, for something like distributed transactions. I urge you at all costs to ignore this idea, this impulse, this sickness. Please, please. I'm here for you. If you if you need help, call me. We'll talk about it. I'll walk you off the ledge, talk you off the ledge. This is not a good place, especially in a microservices system. More than one or two services, and that starts to become a pause the world solution, and it's a very bad idea, right? So what distributed systems use to synchronize state across multiple services these days is eventual consistency. Eventually consistent, that is to say asynchronous, something like messaging, right? So we can make that very simple. So I'm going to go ahead and stand up another endpoint here that'll simply take a message and then talk to another service and then write the results. I could do this all manually, naturally. I could stand up a Rabbit template and make the call, or I could stand up a Redis template or a Kafka template or whatever, synchronize all the code on both the client and the service. But what I really want to do is be able to logically talk about streams of messages and how they get composed together. So we're going to use a module here called Spring Cloud Stream, which in turn supports 3 different bindings at the moment, one for Redis, one for Kafka, one for RabbitMQ. So I've got RabbitMQ running on the background here. I'm going to go back to my build in both the client and the service. I'm going to bring in Spring Cloud Starter Stream Rabbit. How's that for a mouthful? Okay. And I'm going to go up here. I'm going to say @enable binding. Now this is a bit of a, this takes a minute to sink in. So remember, this is the client. I'm going to have a REST request that comes into the API gateway. It's going to post a reservation, but then I want to immediately fire a message off and then write that to a buffer somewhere, a queue, so that eventually it'll get processed even if the service that is responsible for processing it is down. Guaranteed that it will get processed. I want to tell Spring that I need a channel, a Spring integration channel, a Spring channel, a message channel. A message channel is a named conduit between one component and another, and it can be backed optionally by a message broker like Kafka or RabbitMQ. And I need it to provide, any number of different channels. The default I'm going to use here, the use of channels is so common that, hello, computer, there we are, that Spring Cloud Stream provides an interface approach to defining these channels by convention. So I'm going to say that Spring Cloud, I want a channel named output. It's a message channel named output. And I want to connect that channel to another service. So I'm going to use configuration to logically bind messages sent on the output channel to a broker somewhere else, and then receive the messages on the input channel on the other end. That configuration lives external to the code. So our interface, our contract here, is an interface that has a method of type message channel. I can have one to many, but the input-output scenario is so common they provided predefined interfaces here. If you had your own messaging-based system where you had 5 different message brokers, you could define 5 different interfaces and then map in configuration what those logical names map to in terms of actual destinations on the broker. Okay. So I'm going to go back to my build. I've got Spring Cloud Starter Stream Rabbit. That's already there. And if I go to my configuration here, github.com, Vodafone microservices config, you'll see that on the reservation client.properties, it says Spring Cloud Stream bindings output. So this is the logical ID that we've created in the message channel there, equals reservations. So the reservations is the actual thing on the broker, Kafka or RabbitMQ or Redis or whatever. It's the place where the actual memory meets, where I can, as a client, consume and as a producer, produce. But on the client side, my logical name is output. On the flip side of this, I'm going to have input. These are just predefined names, but you can use whatever you want. It could be foo and bar, right? Spring Cloud Stream bindings.foo equals reservations rabbit. It could be whatever you want, right? So this is a configuration matter, which means I can rewire the flow of these messages later on. And by default, it's going to connect to my RabbitMQ instance. I could provide a default implementation. That's what Spring Boot is doing. And I can, of course, provide my own, my own implementation and specify host and port. So here we go. This is the client. I'm going to make it so that when somebody goes to /reservations and sends a post, I'll send a message, public void post, and I'm going to say that I want to receive a request body of type reservation, and I'm going to inject the message channel that Spring Cloud has auto-wired for us. I'm going to use the qualifier notation. Of course, this is just convenience. I could have just used no qualifier. I could use this, if there's only one, this would be the same. There you go. And indeed, I don't even need to do that. I could do source.output. Right? That's the public static final string that has the string output. Right? I'm telling Spring to inject the bean that's created based on convention by looking at this interface. And it's annotated it with this qualifier annotation. This annotation is it's entirely arbitrary. You could use your own. It is just a syntax shortcut for @qualifier and a string value. It's just a qualifier. It's a type-safe qualifier, and it passes through the string if you want it. So I'm going to inject that message channel, and whenever somebody says make a reservation, it's going to post to this endpoint. I'm going to say this message channel dot send message hello builder dot build or with payload r dot get reservation name dot build. Okay, so that's going to build an object of type message that has headers and payload. It's going to send it on the message channel, and then on the other side, I want to have the recipient receive that message and process it eventually if it can. So I'm going to flip the code around. I'll go back to my reservation service. Let's restart that. Whoops. I meant to restart the service, but whatever. I'll say @enable binding equals sync.class. Okay. I'm going to go back to my build here, and just as before, I'm going to add Spring Cloud Starter Stream. Where did I put that? Oh boy, we're down to the last 10, friends. Can we do this? It's going to be tough. Okay. Here we are. Here we are. So that's going to be a sync now. So before it was a source, right? A sync. And a source is the producer of a message. The sync is for the recipient of a message. Okay. So that's just source and sync. That's messaging jargon. There we are. And just as before, I'm going to say that I want to be a messaging endpoint. So I'm going to use the message endpoint annotation from Spring Integration to create a component reservation message handler or whatever, I'll say service activator. So I'm saying whenever a message comes in from source.input, same as before, right? Source.input. Sync.input. Public void accept new reservation. I'm expecting a string of type, a payload of type string. And I'm going to inject the repository, the JPA repository that we had before. Private reservation repository. And I'm going to write the repository. I'm going to write the record that was just sent to the repository. But of course, this message handler won't get invoked until the service is available, right? So if the service is offline, it'll be buffered in the message queue. So this is an asynchronous handler. Whenever a message comes in on this logical channel, it'll get called, and this method will be called. It's the Hollywood principle for messaging, right? Don't call me, I'll call you. It's like a message-driven bean for, in this case, RabbitMQ. Okay, so message endpoint, enable binding, so this the flip side of the other one. So I'm going to restart that. I'm going to go back to this, restart this. And if we did that correctly, I should be able to post a message on the API gateway and see it delivered and reflected in the output of the actual service. We can go to the service here, localhost 8000/reservations. This is where we all started. Oh, there it is, yeah. So there's the output, Josh, Dave, Spencer, Mike. And now if we go to the API gateway at 9999/reservations/names, no available. Oh, give it a second. The registry is still coming to life. Reservation client. Just restart it. We don't have enough time. Come on. So what happened is I made the call before the actual service was registered. So it called the registry and something failed. We're going to talk about how to fix that in just a second. So there's the name. So now what I want to do is add one more person to this endpoint. I want to make a post. I'll go down here and I'll use the advanced REST client. I'm going to make a post to port 99/reservations. And it's going to have this payload, reservation name equals, somebody give me a name?
Nate.
What?
Nate.
Nate. Nice to meet you, Nate. Thank you for playing. So here we go, application JSON. There's Nate. So it's published. Now let's talk about that other problem that I just had. I called the REST service, this one right here, and the registry wasn't available. Or the service wasn't registered, and it blew chunks, which is exactly what we don't want in a distributed system. So I'm going to use a circuit breaker to ensure that if something falls down, I get resilient behavior, right? Think about the human body. If you were to prick your finger, you wouldn't just blue screen, right? You'd gracefully degrade, one hopes. So your distributed system should behave the same way. Netflix does this all the time. Suppose you go to the search service on Netflix, and you look for something, and the search service is offline. It'll say, well, it's offline, but here's some recommendations from across the web. You get something, right, rather than just a big stack trace. So let's go ahead and make our reservation endpoint here, this reservation's name, just a little bit more resilient so that if something should go wrong, it'll gracefully degrade. So I'll go here to my reservation client, great, and I'm going to make a fallback method here. I'll say get names, and I'm going to copy the same contract. I'll say public string get names fallback. And in this case, I'm just going to return a empty collection, empty list of names. So that'll be the fallback. And what I want to do is I want to say at the top here, I'm going to say @enable circuit breaker. And I'm going to use something called Hystrix from Netflix, which is a circuit breaker. And I'm going to say @Hystrix command fallback method equals get names fallback. So if something should go wrong, if this should blow chunks or throw an exception or whatever, it's going to stop traffic from going to that broken path, right? I don't want, just as I'd rather not overwhelm the house circuits and cause a fire, I'd rather just lose the lights for a little bit and have no power. I don't want traffic to cascade and cause the other parts of my system to fall down. So I'm going to create that fallback. The other thing I want to do is I want to be able to visualize the flow of messages between my systems, right? So I'm going to go ahead and Hail Mary, let's see if I can do this in the next 3 minutes. Bring in distributed tracing support. So we're building on top of something called Spring Cloud Sleuth. Sleuth has one implementation called Zipkin. Zipkin is a distributed tracing technology from Twitter. So I'm going to bring this in, and I'm going to add a bean of type always sampler. So I'll say bean always sampler. And what I'm doing is I'm telling Spring Cloud that I want to visualize the flow of messages across different systems. If I have 3 microservices and one calls the other and the middle one falls down, how do I visualize that? How do I see where the error happened, and how do I correlate the requests that caused that outage, right? I need to be able to have a trace across these different systems. So Zipkin is a great way to collect and visualize that information, but you have to tell it what to collect, right? You have to provide a bean of type sampler. And because this is a demo, I want every request to be traced. But normally you wouldn't want to do that. If you're going to have an error, you'll get it with just 10% of your traffic. And you don't want to overwhelm your traffic tracing tool with every request, right? So I'm going to bring that in here to client and then to my service as well. Okay. And I'm going to go back to my, oops, this is the Eureka server. Reservation service. Oh, it's going to be tight, my friends. Bear with me here. Can he do it? Spring Cloud Starter Zipkin. I'll take anything now, please. Zipkin. Okay. There we are. Okay. So this is the reservation service. I've got the sampler. I'm going to restart that. And I've got the client here, and it's got the sampler. I'm going to restart it. Okay. So now we should see 2 things. First of all, I'm going to call the endpoint, the API gateway, get the names, and then we'll kill the reservation service. Okay. After that, I'll also show you what Zipkin has collected from these traces. So this is hopefully working. I've got a graceful degradation because it hasn't registered in the service registry yet, so I got empty collection first of all, right? I've got nothing. It's doing the right thing. It's not showing me a stack trace. And as the service becomes available in the registry, one hopes, in 30 seconds, whatever it is. Reservation client. Come on. Registry. Faster. Son of a gun. There's like, oh, there you go. So now it healed itself after a timeout. There's 30 seconds where it takes to register. Great. So we saw the circuit break already working. I made the call from the client to the service. The service wasn't available. It fell back and gave me the empty collection. Great. So I'm not spewing stack traces in the client. Now, having made that request, and the system healed itself, right? So you know that for common stuff, your system is resilient to failure. Now, the last thing is, what has Zipkin collected? So I'm going to say echo Docker IP. I've got this running in a Docker image in the background here. Look, I'm going to enter this, :8080. There we go. So I have a little dashboard here, and I can see reservation client, reservation service, right? So I want to visualize a waterfall graph of all requests made. I'm going to start from tomorrow. There's a weird bug where it's like not exact, so there you go. This is about a minute ago. You can see it says about a minute ago. These are the requests that I've made into the system. I click on this, and it shows me a waterfall graph of the request that goes to HTTP reservation names. If I click on that, it shows me the headers and the in point and out point of the message, as well as the headers for that HTTP exchange. And then you can see it went to HTTP reservations on the service, on the API gateway. And it gives me the headers on that. It'll automatically instrument RabbitMQ, Kafka, Redis as well, and give you the headers for that. It'll automatically instrument the microproxy. It does a lot of this stuff for free. All you got to do is add the right dependency and a sampler. And now you've got distributed tracing, as well as timings that show you when it started, when it stopped, and so on. We didn't get to really talk about a lot today, did we? I'm really sad about that. What'd you think so far? Maybe? A little bit? Okay? I know we covered a lot. I know this is a lot to, grok. My name is Josh Long. I am forever at your service. I'm here if you have questions, and I expect you might. I don't expect you to remember everything. Please keep that in mind. What I wanted to really, really drive home is that there's a lot of patterns, a lot of things that you're going to have to care about that aren't fun. None of this is like this is everything except for the client and the service is undifferentiated heavy lifting. So at least you don't have to write this stuff yourself. You can build on you can stand on the proverbial shoulders of giants here, right? By using Spring Cloud, you can pull together the best of breed from Netflix, from Twitter, from Apache, and from Contool, and from all these different technologies. We have a slew of other technologies and other features that you can use, including single sign-on and security, right? If you have microservices, you don't want to have to reinvent that proverbial wheel each time. By the by, if you're on the Twitters, please find me, carry the discussion forward online. I really appreciate your time, friends. Thank you so much.
Okay. Bem, primeira tela, falar da falsa discussão entre desenvolvimento e operações. Talvez seja aqui que a gente possa falar a história do sistema, né? Ou aqui, todos no mesmo bar. Não sei qual que você prefere, mas eu falo aqui da falsa dicotomia, a gente fala todo mundo no mesmo barco, o foco é em entregar, aí você fala dessa história. Beleza? Aí a gente já fica aqui, senão não tem o que falar aqui, né? Tá? Aí, então assim, tenho certeza que você já sentiu né, todo mundo contra você, etc, né? Eu falo assim, nós somos também consultores, tudo mais, não sei o que lá, como vocês, desenvolvedores, tudo mais, então assim, né? Você já se sentiu assim, já se sentiu amarrado na sua cadeira, arrastado em reuniões chatas, com pessoas mais chatas ainda, fazendo trabalhos mais básicos e tudo mais, certo? Então, porque mudar a cultura é difícil. Você até pode falar a história de mudar a cultura, que você tem, né? Tá, deixa esse slide para você falar, né? Certo? Aí a gente vai, bem, então tem hora que você precisa ser pirata, né? Você tem que chutar tudo em cima da mesa, tem que pular da janela, tem que pular do precipício, né? Tem que enganar o chefe às vezes, tudo mais. Então a gente quer que você seja agente de mudança. Faltou agente de mudança, ele não apareceu. Não sei porquê. Verdade. Né?
Cool. Hey, I'm going to slide this over to the other side because it looks like it's too far to the right. I heard it sounds good when you turn to your left, but it doesn't sound so
Okay,
good.
do you want to put it here instead of on the flag, because the flag moves.
Yeah,
Unfortunately,
it's
when
gonna-
you move, the flag moves.
Yeah, but if it pulls back up on top, then I lose it. Then it won't work so well. But if
All right.
it moves with this, it'll be fine. Yeah,
Whatever.
I'll make it work.
Yeah, all right.
I'm going to do my best.
Okay, yeah, I know the flag is always a little bit of a bother. I know this. Então é aqui, ó. Where flag? Sistema, aí os passos são automação, eliminar reputações repetitivas, fala um pouquinho aqui. A gente tem que lembrar que sempre nesse passo aqui, com nossas ferramentas, a gente tem que falar do que a gente quer que o cara faça, que a gente não tem um slide para isso. Tá? Visibilidade. Né? Dashboard é medir, certo? Aí, visibilidade é criar métrica, né? Visibilidade, tem essa historinha aqui que acho que sempre está um pouco longa demais, mas tudo bem, agora não é hora já. Né? Certo? Aí, então, nosso objetivo é focar nas métricas que são importantes. Aqui uma coisa que eu vou adicionar nessa métrica aqui, eu vou falar da história de que, vou mudar um pouquinho, falar da história de que às vezes a gente está, as métricas internas, né, os problemas internos que são muito grandes, a gente não vê os problemas externos que a gente acaba minimizando, entendeu? Vamos falar um pouquinho disso aqui, tá? Fica um conteúdo um pouco melhor nessa parte. Aí o negócio do teste, né? Tem que pular do precipício, certo? Isso é você confiar, né, no seu time, em você. Virtualização, certo? Aí falando em importância de virtualização, importância de containers. Né? Beleza? Tranquilo?
Back here. The hell.
Going back, all right?
Yeah.
You okay?
Because it doesn't stick on the metal. It slides right off.
Oh, I see, okay,
Okay.
all right. Okay? Long journey. Aí aqui o finalzinho é só o finalzinho pra gente ter, assim, né? Todo mundo no mesmo barco, na mesma direção. Infelizmente não todo mundo, às vezes a gente tem que deixar alguém pra trás. Nosso objetivo é que você tenha vida, né? Life. Ok?
Okay.
E morreu meu laptop.
Acabou a bateria.
All right. Okay. 1, 2, 3. Do we have audio? Yes? Can you guys hear us?
Hello?
Okay, good. Hello, how are you? So it's funny how things work fine, right? We checked the last slide, the laptop shut off because lack of battery. That's pretty good, right? And I'd like to start, still have 1 minute, right? So I'd like to thank someone that I don't know exactly who he was, but already came here, took a picture of the slides, and already posted on Twitter. That's great, thanks. Thanks a lot. And I think that's part of, one of the things that we'd like to say a lot is that the reason why we are here at an event is to meet people, right? We're not here in an event to necessarily watch talks. I mean, watch talks is nice, right? But, this talk is being streamed, for example, and you could watch this talk later, but the guy sitting right beside you, that's an important person that you need to meet right now. I like to see on the events, you see like, 2 guys, and then there's a chair in the middle, and then there's 2 guys. I bet you guys know each other. No, you don't, right? That's rare, but Huh? Yes, you do know. Right, okay. And then there's a chair, and there's 2 guys, and then there's a chair again. Is because we're all nerds, right? We don't talk to each other, right? So, so that's a good moment right now while you still, we have 1 minute before the talk starts to say hello to the guy sitting right by you. He's interested in DevOps, right? Exactly like you are. Yeah. So maybe that's, yeah. So maybe that's exactly the guy you need to learn. You need to know something about. You might. Yeah. So lots of talk. Yeah, that's good. The guy sitting by you is probably the person that has the same problem as you have. Or maybe, he's trying to do the same thing in a different project. So it's a pretty good opportunity. So take this chance. You're here, you're spending time, you're spending money to be here in the event. Use that to meet people, because that's what makes a big difference in our lives. Okay, do you want to take the chairs out?
Yeah, leave it. Just to limit the space.
Right. Leave right here?
Yeah, so that we know.
Oh, okay, because we are on camera, we can't move farther from the chairs. Okay, so that's good. All right, guys. Thanks very much for everyone to be here. We're going to start here. We're going to talk a little bit about the Pirates of DevOps. I think most of you probably know the movie, the Pirates of the Caribbean. This is one of the less known movies, I guess, the Pirates of the Caribbean, but it's an interesting movie because, as you know, the main character of this movie, Jack Sparrow, on this particular movie, he doesn't do anything. He's the guy that's he gets arrested, put in a ship, and everything he does the whole movie, someone tells him to do. He doesn't, everything. He doesn't have the power to do anything. But by not having the power to do anything, he completely changes the story, right? He gets everything. He gets people to do things. He completely changed the outcome that everyone expected. And I think that sometimes we feel like this, don't we? Right? Sometimes we feel like, we don't have the power to change things, that we are just following orders. And so that's the analogy we're going to do here, right? It's, we sometimes have a lot more power than we think. And to talk about this, I have here with me my good friend, Edson Yanaga. Edson is the most recent Java champion. He was just voted as a Java champion a couple of weeks ago. He is a very well-known developer in Brazil. He works a lot with, he's a consultant, works a lot with companies that are trying to implement those kind of things in their projects and everything. And Edson has a very interesting characteristic. He's a promoter of the software craftsmanship movement. And I love this because as a software craftsman, you take very good care of what you deliver. And I think that this is the most important message that we have here, is that we're going to talk about DevOps, we're going to talk about delivering software. And if you want to talk about delivering software, we have to care about the process of delivering. So, a hand of applause here for Edson.
Thank you. Thank you. Well, hello, everybody. I like the message that we have to deliver software. It's left.
Okay.
And that as developers, our mission is to change people's lives for the better with the things that we do every day. And we can always do better. We can do better code. We can deliver better software. And to talk about DevOps with me, I have Bruno Souza. I'm pretty sure that most of you already know him. But he's the guy that brought Java to Brazil 20 years ago. He's known in Brazil as the Java Man. He's a Brazilian Java Man, aka the guy with the flag. So.
Yes. This year is a special flag.
Yeah,
just to promote
he's not wearing a Brazilian flag. He has 20 years of Java flag.
Yes.
So that's a very special date for all of us.
Okay, so let's talk a little bit about about what it means to be a part. But first of all, this whole discussion about DevOps, right? We have this false fight in our companies, in our projects, between the team that does development and the team that does operation, right? Throughout the years, we kind of created this notion that, developers have to innovate. Developers have to create new stuff. Right? Developers have to, that's our job, right? We have to create new ideas and create new software that doesn't exist. We have to innovate, so we have to be fast, we have to be agile, and all these kind of things. And then the guys on operations like, oh no, we have to keep the quality of the system, right? We have to keep the system up and running. We have to guarantee the performance. So, to guarantee quality, to guarantee it's up and running, we have to minimize change. And then, developers have to maximize change because that's what we do. And then the operations like, no, we have to minimize change. And so we kind of create this idea that, we are like fighting each other. You can choose which one you are, right? Right? And you're trying to fight each other here to try to get something. But the truth is, service, it's software running. There's no fight in this discussion, right? If we think that what we need is provide value to our end users, right? What we do, right? Why we do what we do, right? So we don't do software just to do software, right? We do software because we want to improve someone's life. There's someone in the other side of our application that wants better entertainment, wants an easier way to rent a hotel, wants gets a cab because he needs to get back home. This person needs a better life somehow. And that's what we provide, right? We don't provide software, we provide better life, we provide value to our users. And there's no value if there's no software. And there's no value if it's not running, right? So it's a false discussion because our objective is to deliver software, good quality software, right, with new functionality in the hands of our users. So the whole objective here when you talk about DevOps is that development and operations need to focus on delivering software. Not focus on writing software. Not focus on getting quality of the software. Focus on delivering software. Right? We all need to be on the same boat. Right? And if we realize that we are in the same boat, that makes things a lot easier.
Yeah, I'd like to say that development and operations is a false dichotomy. Because usually, as Bruno said, each of these parts are interested in a different thing. And usually, we only care about our own job. Developers care to code. Operations care to keep it running. And when you have a system, you have the theory of constraints. When you have a system of a process, where each process follows one another, when you try to maximize each one of them, you never get optimal output. So instead of trying to maximize your own job, we should try to maximize flow so that we can deliver better software to the users instead of maximizing code and maximize operations.
So that's kind of the idea of DevOps. But the problem is we are all developers here, right? And so we all don't feel that we have the power to change things. And one of the problems with DevOps is that we talk about culture, right? Everyone that talks about DevOps say, DevOps is culture. We have to change the culture of the company. Do you feel that you can change the culture of your company? Right? You're a developer. I'm sure you felt like this. Everyone is against you at some point, right? So how do we change culture? And the worst of all, me and Edson, we are consultants. Right? It's even worse. When a consultant is the guy that comes in and everyone assumes that we get more money than you do. That's not true, right? Everyone assumes that we know less than you do. That might be true too, right? And everyone assumes that we're there just to tell you what to do and then we're going to go away, right? So no one wants to hear what we were talking about,
right? So how can we actually go inside a company and say, we're going to change your culture, right? Culture it's not what we want to do. Culture is what we do, right? So, we feel like this all the time. Everyone's against us, right? I'm sure you felt like this, tied to your chair. You can't get out, even to go eat lunch or go back home, right? I'm sure you also felt like being, dragged to endless meetings that you don't want to participate. Worst of all, you have to find very boring and painful people in those meetings, right? And so, and then, you are always put to do the worst job of all, right? And, how can you actually do anything? How can you change culture if that's your daily life, right? So, and then I'm sure you feel, no, I don't have the power to change the culture of my company. So when you hear about people talking, oh, let's do DevOps, right? And you're like, oh, this DevOps thing is all about culture. Let me just keep doing what I'm doing because I'm never going to change the culture of my company.
And we say we must have a culture change. We must change it. But every CDO, CIO talking about changing company culture. I like this definition. Culture is what we do. So how do we change what we do? That's the thing that we must have in mind when talking about DevOps. Because DevOps, it doesn't follow a top-down approach. DevOps rises. But what can you do to make this change rise? That's why we say we must provide a system of very small steps that can change your everyday work, because culture is what we do. So how can we provide a system of very small steps that we can practice and do every day to improve the things that we do every day, so that later, it doesn't matter if it's a week later, a month, or 6 months later, we can have and be able to say that we are doing DevOps.
So we're inviting you to be part of this, what we call the Pirates of DevOps, because sometimes we've got to be pirates inside our own company, right? Sometimes we got to get on the table and kick everything. Sometimes, we got to jump out of windows, to get out of that environment, right? Sometimes we got to jump out of waterfalls in this case, right? What do you do if your boss tells you to jump out of a precipice, right? What do? You jump, right? It's your boss, right? So we're going to teach you how to jump out of a precipice when your boss tells you to do. Jack had to do that in the movie. A lot of times sometimes you might even have to trick your boss, I guess. So Jack had this moment on the movie where he basically had to trick his boss to save her, right, from the destiny that she's going to die at some point. So we are actually inviting you to be agents of change, right? To be the person inside your team, inside your company, inside your project that does those small steps every time, and then, even if no one else wants to do anything, even if it's not a top-down approach, even if your organization doesn't want, but if you focus on delivering, you can change all those things, and you can make those things daily.
Yeah, we're asking you to do the only thing that you're capable alone of doing. The only person that you can for sure change is yourself. You need to change. And we talk about system. We can't change people. But you're able to change yourself. You can't tell someone, oh, tomorrow you're going to be a DevOps guy. Tomorrow you're going to do DevOps. We can't change. We can't tell anybody to do that because they want. But we can change the restrictions of the system. When we say that culture is a system, this is another definition of relationships between people. So how do we change these relationships? How do we change what people do? We change the restrictions of the systems that are applied to the people instead of trying to change the people. One of the things that I like to say that which kind of restrictions can we change in our relationships? One of the best words that we learn in restrictions change is about saying no. Because I guess it's all around the world. In Brazil, we're very used to say yes to everything, but then we don't. Yeah? What about we start saying no to something? That's a change of restriction. Because if people are used to hear something from you, but you don't, then you start saying no. But when you say yes, you really do it, it's a change of the restrictions. And I'm just saying a very small example of what your attitude of changing a single restriction modifies behavior of other people. So what we're trying to show you is that we're going to create a system of very small restrictions changes that you do every day to implement culture, to change what you do and what people do.
Yeah, so so we're proposing here 5 simple steps that you can do every day. Take an hour a week to do those things, for example, or that you can do every day, or one of those steps each day. Small things that you can add to your project, and then in a few months, that will change a lot of things for you, and that will change a lot of things for your whole project.
Yeah, I guess everybody here can take at least 1 hour per week to do one of these 5 small steps to improve your career, to improve your software development process, to improve the things that you can do to change people's lives.
Right. So when we talk about DevOps, there's a lot of there's several different definitions of DevOps out there. And Edson said, you got to be a DevOps. Sometimes, if you have DevOps in your title, people say, if you have a DevOps in your title, you're probably doing it wrong, right? So, but one thing that we notice is that the one thing that we like to say a lot is that DevOps is us together doing continuous delivery. It's us together delivering software. So when you get on this mindset that your whole objective as a developer, as a company, as as a project, is to actually deliver software, because unless you deliver, nothing is going to happen, right? If you get on this mindset, those little steps are going to help you actually focus on delivering. We gotta get over the fear of delivering. It's so funny that as developers, our whole objective in life is to create something that other people are going to use. So our whole objective is to deliver software. But we are all the time creating excuses to deliver software. Oh, it's buggy. Oh, it's not ready. Oh, I need to test it one more time. Oh, there's one more meeting. Oh, someone has to approve. Oh, I can't do anything about that. Oh, it works on my machine. Right? Why? It's not going to work on the customer machine. We're all full of excuses because we have this huge fear of delivering the software. So many people. I'm from the open source. I'm one of the directors of the open source initiative. So many people tell me, "Oh, I don't participate in open source because if I put my code out there, what are people going to say?" Yeah, we're all full of those excuses. We gotta get over them, right? Because that's our objective, is to get software in the hands of people. So let's make it happen. So what are those 5 steps? First one of them, it's automate, right? You got to do automation. One of the funniest thing of all is that developers, one of the best things that we got to do is, the things that we do all the time is automate other people's life, right? Isn't what we do as a job? Right? We automate how people register for a hotel. We automate how people register for a conference. We automate how people ask for this or do that. And then when we get to what we do, we say, oh no, it takes too long to automate things. Right? I'm going to do this tomorrow. It's just one time. Right? I'm not going to automate this now because I'm just going to run this one time. And then we're running for the 100th time, like, oh, that's the last time I'm gonna run this by hand, right? So I'm gonna not automate now because I don't have the time. So automation is something that we do for everyone else. We gotta focus on this on our life, right? So we have to eliminate repetitive tasks.
We must automate to save time. So what we're proposing that during the next week, because here this week you're at JavaOne.
There's the tools first.
Yeah.
Tools?
Okay, talk about tools. And what tools you can use to automate your tasks every day? We selected some, all of them are open source. We work with Java, so some of the tools that we can use to automate daily steps are, for example, build automation, Maven, Ant, Gradle. You can use infrastructure automation tools, just like Ansible, Chef, in Puppet. You can automate schema evolution of databases like Flyway. In fact, many of these tools, we presented them last year, so there's a presentation available on Parlays. If you'd like to know more about these tools, we have already explained them in an online session. And we can use, and one of the most important tools of automation is the continuous integration server. So we selected 2 open source continuous integration servers like Jenkins, which of course is the most popular one. And we also provided Go, which is a tool that was recently released as open source by ThoughtWorks. The main difference between Jenkins and Go, Jenkins has a much bigger user base, much more plugins, but Jenkins focuses on jobs, individual jobs, and Go focuses on software pipelines. So you can have the whole view of what you're doing in every one of these steps instead of individual views.
So any one of those tools will allow you to do a little bit of automation in whatever part you are. So if you're working with the database this week, maybe you could try Flyway and automate the creation and migration for your database, right? If you're doing builds, you could use one of those tools to automate your build. Anything that you can do to improve the automation of your process, any one of those tools that you can learn to do those things, that's going to improve the way you do automation.
Yeah, don't spend more time creating that email to the DBA. Whoa, when the next software release gets on air, you have to apply this SQL script to be run on the database. No, automate it. Use a tool to do this job for you. So this time we're proposing that during the next week, you spend 1 hour automating the task that takes most time of your week out. So take anything. If you have to upload a file, you have to execute 5 single steps on the command line to do something, take that, put it on a script. It can be a shell script, it can be a PowerShell script, it can be an Ansible script, it can be a job on Jenkins. Do anything that you need to do to automate 1 single step to save this time for the next week. So you spend 1 hour this week to save a lot of hours in the next months that they're about to come.
And it's funny that a lot of times we don't realize how much, if we don't have the mindset of automating, we don't realize how much steps we do by hand. I remember that I got in a project one time, and the guys were having like a long problem with deploys, and when I got in, I was a consultant, right? So everyone was against me. So I sat in a meeting, and the guy said, "No, it's all automated now," right? And so the manager was like, No, it's I don't know. I didn't see it yet. I said, okay, so they're saying it's automated. So let's just assume that it is. Let's just see it. And she got mad with me because you should have told them it's not automated. I said, well, I don't know. They said it is. So we went, and the guys did automate lots of interesting things. And then when they showed me what they're doing, they had 56 steps to do a deploy. 56, right? And they had automated 4 of them. And and for them, it's all automated because they didn't realize how much of the other steps they were actually doing it. Sometimes we don't see until we actually put on paper everything that we do, right? So this is really important for us to get in this mindset.
Automation has another advantage. It prevents you to put things on paper. Right. You can put it on codes, which is a live representation of what you're doing. That's process documentation. And a script is a live documentation of what you're doing.
Okay, so that was first step. Second step is dashboards, right? As when you're in a ship, you're trying to navigate in the middle of the sea. I'm sure you have a map, right? I'm sure you're looking where you are right now and where you want to go, and you're taking a look at all of these. And a lot of times we are trying to do things, and we don't have visibility on those things. We don't map what we're doing, what are the results we're getting, and where exactly we want to be, right? So there is a whole lot of dashboards, open source dashboard software you can use just to see how your project is right now. It's extremely important that we track how our project is, how we're going, how we're actually getting where we want to get.
Yeah. How do you know if you're delivering good software? How do you know how much time are you spending on delivering this software. How do you know if you're improving or you're getting worse? You must measure something to get this kind of sight. So what we're asking, instead of I think I'm doing this week better than last week, in fact of just thinking about it, what about creating a number? So what we're asking you this week is to get and provide one number that will represent what you do. This number could be the total count of bugs that you fixed this week, the total downtime of your service in production this week, but we want you to create a number. It doesn't matter if you create a script, automated script of course, to issue a query to your database and get the number, but you will simply provide a number that means something to you. And when you say, what am I going to measure? Measure something that is important for you, measure something that is important for your boss, but just create a number. We need numbers to check out how we're doing.
And there's a lot of interesting tools out there. We just select 2 here that you can easily use to do those things, because one of the problems with the number is that a number by itself means nothing, right? You have to have a history of numbers, right? If you get to your boss and you tell your boss, so this week we had 50 minutes of downtime, he's probably going to get mad with you, right? You know, he's probably gonna say something bad to you. Now, if next week you say, boss, this week we improved it in 50% our uptime, right? Now he's going to be happy. So we got to get those numbers. So Dash Builder is an it's a nice little JBoss tool that you just upload to your, just a WAR file that you install in your application server, and it will run queries in the database. You will get numbers out of a CSV file. It gets numbers out of a lot of different places and drop, plots things to you and make sure that you have the history of the things and showing a nice dashboard for you. But if you think that's putting Dash Builder and finding the numbers is too hard, maybe you just want to install Sonar, right? Sonar, you just install it, point to your source code repository, and then it just creates a lot of dashboards for you. So now you can select some of those numbers to keep paying attention at. You can start with some small things. Don't need to look. Sonar has all kinds of different information. Don't need to look at all of them at the same time. But at least you have some ideas. Would be nice.
Yeah, Sonar Cube is a very valuable static analysis source code tool. It can provide you a lot of numbers, including the amount of cash you would have to pay to resolve your technical debts. And Dash Builder is much more flexible because it's a kind of a BI tool. You can run anything that you need, a SQL query or even a script, just to provide anything that you run that can return a number, Dash Builder can save.
Yes, and this whole thing adds some kind of really quick to talk about your technical depth, and that is one important thing that will interest a lot your boss, right? So if you don't measure, that's we're going to talk about visibility in a minute. But one of the important things for you to give visibility in your project is how much you're acquiring of technical depth, because a lot of times we take decisions like there is a competitor that just released something, or the marketing guy just asked something really important, and so you had to do a workaround to implement that really quick. Every time you do this, you acquire technical depth. If you don't deal with the technical depth, and eventually your application is going to be so complex and so hard to change that you won't be able to do any change. So the sooner you start paying your technical depth, the less is the chance of your depth actually exploding at some point. So, but the funny thing is that when you have depth in your bank, you see this every month, right? You receive the bank statement, your debt is increasing, so you're willing to go and pay and do something to pay that debt. But technical debt is usually hidden somewhere, right? It's in the middle of your code somewhere. You don't see it. And since you don't see it, you don't realize how much it is. And you don't realize that you do have to spend time paying for that.
Yeah, we're not discussing if the metric or the number that SonarCube creates is real, but at least it's a number. It's something that you can see and check.
And you can track and see if it's improving or getting worse. A lot of times it's not, it's not the number specific that's important, but it's, how it's growing or reducing, right? And one of the problems that we have also is visibility. We're talking here about putting numbers, but Jack on this one of the steps they had to do in this trip, they had to capture a mermaid, right? And so they put a little bit of visibility. They wanted to do this. They kind of put a beam of light over there somewhere in the sea, and so they were able to put some lights on the mermaid they want to capture, right? So this, so just a little bit of light, we can start seeing things. But sometimes, the problem that we have is that, we don't keep our focus on the objective, right? We get fascinated by this one thing that we are able to see, and you say, okay, so this is so great. I'm being able to see my technical depth, for example, and you lose focus. That our focus is on delivering software. And a lot of times what happens is that, we get fascinated and we don't realize what's worth, right? We see this beautiful problem that we just are focused on. And funny enough, we do have two different types of problems, right? We have all kinds of internal problems. Our application has problems. Our code is messy for some reason, etc. And then our end users also have problems. And a lot of times we focus so much on the internal problems that we think they are huge. So we say, last time that we tried to deliver an application, we had this problem with the database. Oh, it was a huge problem, right? So we're going to delay our next delivery. We're going to have more meetings. We're going to have more discussions because it was a huge problem with the database last time. And our end user didn't notice anything, right? Because our end user was not accessing the application at the time or whatever. Our end user didn't see all this big problem that we had. So we are now delaying the application. We're now not putting new functionality in the hands of our users. We're not improving their lives because we have these huge internal problems that we didn't know how to handle it. Because sometimes we just put the light in our internal problems and they get huge, they get big, and we forget that our biggest problem of all is our end user not happy, right? And that's hard to measure, that's hard to see. So a lot of times we gotta, and then what happens is that, we end up getting beaten by our problems, right? So sometimes we gotta Jack did this. He's exploded something internal, right? And put a lot of light in the size of the problem. Then we see, oh, come on, the problem is it's different, right? So we gotta focus on the right problems. We gotta give visibility to the things that really matter. We got to give visibility to the things that matter for our project, the things that matter for our customers. So we actually have to focus on delivering software and give value. What are the things that we got to measure to give visibility to that part?
And when we talk about visibility, we're talking about metrics. We need that numbers that we gathered last week that we're using. We have an X number last week. Now we have an Y number this week. We're going to compare. Just as Bruno said, one number alone usually never means anything. But you need two numbers to compare, if you're improving or if you're getting worse. So instead of just getting those numbers saved on a database, we're going to see and compare. We're going to create a metric that will trend upwards or downwards, depends on what we need. And what kind of metric can we provide to our system? So we're asking you now, the next week, to create the numbers that you used the past week and create a metric. What kind of metric must I choose? If you want to convince your fellow colleagues that, oh, look what I'm doing. I'm trying to do some DevOps here to improve our jobs. You're going to use a metric that can improve their time. If you want to impress your boss, you're going to create a metric based on the value that the software that you're creating can provide to your users. Oh, this time I'm selling $10,000. The next week I'm selling 10% more. That's kind of metric that you must create.
Okay, so now we're going to teach you how to jump out of the precipice, right? So at some point, Jack on the movie, his boss tells him, you got to jump. And he said, I can't jump, right? Of course you can't jump over a precipice. So, so he, but he didn't have an option. Isn't this how you feel a lot of times? Your boss says, you got to put this software in production. And you're like, come on, I'm not ready, right? I don't know. Is it going to work? What's going to happen? So, the way for you to jump out of precipice, you all know this very well, is testing, right? So Jack does this. He gets a voodoo doll, and he throws a voodoo doll under the precipice, right? So when the doll gets in the end, well, he's still alive, so he knows he can jump, right? So testing is pretty similar like this, right? We gotta do testing. But the thing is, we gotta test the important things. A lot of times, of course, unit testing is extremely important. Of course, TDD is extremely important. I'm not discussing this, but a lot of times we kind of create all this test infrastructure to test technically only. And we forget that the most important thing is that our end user is able to use the application the right way. It's able to use the application. So, for example, if you're doing an e-commerce application, right? There's a lot of things you can test, right? You can test if the labels are pretty right, if the image of the product is okay. You can test all those kind of things, and you can spend years testing all of these. But really, all you want to know is if the user can buy or not, right? Because if your last application, the designer made an error on CSS and the buy button disappeared, it doesn't matter if the rest of the site is beautiful or not, right? It's simply not going to be useful for a user, not for you. So sometimes we have to streamline and find exactly what are the most important testing that we got to do. Like Jack did. The most important test is he's going to be alive or not, right? Everything else he can deal with it, but that was the most important testing. So we got to focus on testing what is really important for us.
Next one.
No. Tools.
Yeah. And what about the tools that you can use to test your software? Of course, we have JUnit. Everybody knows about JUnit. You can provide your unit tests, your integration tests. JUnit is a testing framework. To provide some integration testing, you can use Spring Framework if you're a Spring user. If you're not, you can use your Archillion for Java EE software. And you can also use for iteration testing, like for web pages, you can use Selenium. These tools are new. They're very consolidated in the markets. But more than just using the tools, what we're asking you to do the following week is choose what to test, because we know it's impossible to test everything. So instead of focusing, JUnit is important for code quality. Integration testing is good to see if my code is issuing correct queries to my database or to different providers. Selenium tracks the user interaction with your system. But we're asking you, what would be the smallest simple thing that you can test that will provide confidence to you that you can put this software into production? Sometimes you can test the login. Sometimes you can test just if some number is appearing. But just as Bruno said, take the smallest thing that you can test that will assure you that you can put this software in production. Sometimes is, can the user get the product and put it in the shopping cart and press pay? Because anything else usually doesn't matter. He doesn't have to check his orders. It will not prevent him from buying. So take the most important value metric that you can provide and test it. And we say testing, test it in your software development pipeline, and later you can monitor these tests also in your production servers.
And of course, that's how you jump out of precipice, right? When you have trust, when you trust that you can jump, that's nothing going to happen, right? When you have confidence that you can actually do it, and then the whole team works a lot better, right? Because this is a very important step for you as a developer, but a very important step for the whole company. If the company trusts that you can actually jump out of the precipice without a problem, it's going to be a lot easier right, for you to deliver software. It's going to be a lot easier for you to innovate faster. It's going to be a lot easier for you to actually focus on delivering, right? And that's probably the step that will help you most resolve your fears, because not your personal fear, but the fear of the company, right? The company has a fear of somehow making a bad thing for the user, right? So those tests are the ones that will get everyone, both the development team, the operations team, but also marketing and management and everything, the confidence, the trust to actually do and move faster.
Yes, and testing is so important because usually when we talk about DevOps, we're trying to, we must automate our software deployment pipeline. But nobody usually tries to automate because, I'll never know if it's working before I put it in production. So testing is one of the most important things that you can do to provide the enough confidence to create a continuous delivery or continuous deployment software pipeline. You must do it. That's the technical thing that you can do that will improve the most, that will create the most confidence in you that you can put your software in production.
So, next step is virtualization. Everyone is talking about cloud computing, right? Yes, cloud computing is great, but what's behind cloud computing is virtualization. Right? So you don't need, my company is never going to go to public cloud. I'm never going to be able to put anything on Amazon. Or maybe you're the other way around, right? You're already using all those stuff. So virtualization is the important thing. Because you can use cloud technology, it's virtualization, in your laptop, in your internal server. You can use anywhere. And that's extremely important for us to do things. Especially one very, very important thing, there's the containers, right? Here we have a whole ship inside a bottle, right? In a kind of container, but it's probably the most important thing that we can do right now. Cloud technologies are important, but containers are going to be the most important thing for us, developers and operations, to do DevOps.
Yeah. We like to talk about virtualization and containers as the single responsibility principle. Just, I don't know how many of you have heard about clean code and the solid principles, but this S on solid is single responsibility. And just as we use the single responsibility principle on code, we should apply the single responsibility principle on infrastructure. Because what does this principle applies to code? It minimizes the changes or possible outcomes that you can have on a given class. So, but when we provide a server for production, usually we install a lot of different things running on the same server. It makes it very hard to change. I have a full stack of things running on the same server, but I can't just choose one to upgrade because it will broke the rest of the things. I can't change it individually, and usually you can't maintain history of what changed during that time. So that's why we ask you to apply the single responsibility principle on your infrastructure, so that every piece of software that you need to provide your service running will run on a different container. That makes it extremely easy to scale, to replicate, to upgrade your different kind of services that you need to run in production. So
there's a lot of different tools that you can use out there for containers. Docker has created, for the first time, containers is a technology that's reasonably old, since from the 70s. We discussed containers, but Docker, for the first time, created like this standard that we can actually build a container and run these containers in all kinds of different providers in different places. So with that standard, for the first time, we're actually able to move containers between providers and move containers and create a clear interface between what we do as development and what we do as operations. A lot of people think that DevOps is development operations working together in the same room. So there are companies that do this, right? You have a war room where developer and operation kind of sit together side by side and work like this. That works, right? You can do that. But that's usually a huge change in company culture that's probably not something easy to do. So you can actually do a much better way of working together. It's making a clear interface between what I developer do and what you operations work with. Containers is a very, very good interface between development and operations, and that's an amazing way to do DevOps, right? Without having to sit down side by side. Because you build your container, and the guys from operations, he doesn't care what's inside. He knows how to stop, start, backup, disaster recovery, scale the container. Doesn't matter if you put Java inside, or Ruby, or PHP, or Node.js. Doesn't matter what you put inside, right? So that is a very clean, good interface between those two teams. Okay? So what we're asking you is spend some time the next week to get one thing of your application and put inside a container, right? Just whatever it is. You know, download a pre-done container with Tomcat, for example, and just install your application in it. Whatever you do, it's going to be a huge step forward, because that's, you know, containers in the next 2 to 5 years, containers will completely change the way we develop software.
Yeah, and some of you might be thinking, but my company doesn't use the containers yet, so how am I going to do it? What, instead of containers, if you can't use your company's infrastructure, you can virtualize anything on your own machine. So you can just download VirtualBox, which is a free virtualization tool, install it on your machine, and we're asking you to take anything that you use every day and virtualize it into a VM or into a container, into anything that's possible. Even if it's just for that, the next time you need that tool, if the next time you need to upgrade that tool, you won't have to format your machine and reinstall it again. So that you can upgrade the tools that you have on your notebook individually. So that you can have both running. Oh, I'm going to test a new version of that tool. Install it on a virtual machine or in a container. You can test it. If everything goes right, you can use the new version. If anything goes wrong, you already have the older version running into a virtual machine or into a container. It allows you to change your tools into your notebook independently. So if you can't change your application in your production infrastructure, you could at least try into your notebook, because in your notebook, you usually don't have to ask anybody. Okay, so we just some tips here. It's usually, you know, this parts of DevOps thing is usually a lonely journey. A lot of people, you know, you're gonna have to keep doing it until other people kind of start seeing the results. So that's normal, right? And we can do a lot of things without having to change everything in the company, right? But one thing that we want, the same way that there's in the movie, that they're looking for, you know, the water of life, right? That's what we want, right? We want that you have a better life, that you have a better career as a developer, that you can work better on things. So what we want is everyone in the same boat, go in the same direction. DevOps is we all together doing continuous delivery. One interesting thing is that when you say about continuous delivery, oh, do you mean like I commit the code and it goes into production? No, that's not what we mean. We mean that if you deliver software once a year, let's see what you can do to deliver software once every 6 months, right? If you do deliver software once every 4 months, let's see what we can do to deliver software every 2 months. If you already deliver software every week, let's see what we can do to deliver twice a week, right? Let's cut by half the time that we take to put a new version in production. Yeah, let's cut the risk in half. Let's cut these delays, the cost of delays that we have in our system. So, so just to say, we'll repeat the 5 steps that you're going to do in the next 5 weeks. So you're going to automate, you're going to measure something, you're going to create a metric that represents something to you or to your company or to your boss. You're going to test if the software can go into production, and you're going to virtualize anything that you need that you can use any day. That's the 5 single steps that you can do to provide, because we know we are what we do. Culture is what we do. So we can change things by changing the things that we do. And we learned from the many years that we're working on it, to change anything that you do, you must practice. So why 5 single steps? So that you can practice at least once a week what we do to change your culture.
And unfortunately, not everyone, right? That's the same in the movie. In the end, Jack had to leave his boss away, right? But not necessarily your boss. But sometimes some people in your team, some people in your company will be the naysayers, going to be, that's not going to work, I'm not going to do it, I'm not going to change. That's okay, right? Just keep doing what you're doing. Just keep focused on delivering software. That's the important thing, right? So you can have life, right? A better life. That's what we want. You know, if you can do like Jack and his partner with hands full of containers, you know, going home on a nice time, that would be wonderful. And just to end here, and I'm not sure if we have time for questions. I think we're already over time here. We do have those slides, and we're gonna send you some bonus material if you want it. There's a form here, jav.mn/career. You know, you can get you can access there, and we're gonna send you the slides and links and information about this, and keep you up to date on things that you can do to improve your project, improve your career. Can I finish?
No, it's okay.
Okay, thanks very much, guys. Yes? No? Time for questions? Yes? Oh, we have time for questions. Okay, so anyone has any questions or comments or? Yes. There's no microphone. Yes.
Just want to find out, how do the automation tools like Chef, Puppet, and Docker container, how do they coexist? Do we really need both layers, or like right now or in the future?
Okay, I'm not sure.
Okay, so the question is how software configuration management tools like Ansible, Chef, and Puppet can coexist with Docker,
Right.
yeah, in containers in a general way. We believe they're a perfect match. They're complementary. Yeah, you have to. They work very well. So particularly Chef and Puppet, they were designed to manage virtual and real servers. So you have a Chef server and a Puppet master. If you change anything, it rolls back your modifications and turn it into its original state. But Ansible, for example, is a tool that was designed just to have an SSH connection. It connects and it provides your infrastructure. But in a simple mode, it installs everything that you need to run your application. So the best thing about containers, I like to say container is a diet VM. So what we do in software development pipelines, we use tools like Docker and Ansible or Chef or Puppet to provision the container image. So we use them, there's a blank container, use provision and save. So what you put in production, you just instantiate that image. So these tools are used to create container images. Another tool that's very useful for this pipeline is Packer. Packers allows you to automate the creation of your virtual appliances. Because appliance is a term that when you pack infrastructure and your application in the same thing, we call it virtual appliances. So Packer is a virtual appliance creation tool. That's one you should be using. But we will, if you subscribe, we will send you the links.
Yeah. So basically, what we want is immutable infrastructure, right? So all those Chef and Puppets are used to kind of evolve the infrastructure, right? You know, we can use them to kind of create the infrastructure that's immutable later. So they work very well together.
Yeah, there's a phrase we say about servers when we talk about cloud computing, that is cat or kettle. If you deal with your infrastructure as cat, because cat usually is our pet, we give names. This is my cat, this is another. We cherish our servers. But when you say kettle, usually you don't want to know from which kettle came your steak. So it's like it's cardable, it's disposable. So when we talk about containers, usually it's a high level of DevOps because you're already caring about this disposable infrastructure. It doesn't matter if it goes down. It's much easier to spin a new one rather than figuring out, what happened with that.
Right.
Okay.
Yeah. There's another question over there? No?
Yeah. Okay, that's an excellent book, The Phoenix Project. In fact, I recommend if anybody haven't read it yet, The Phoenix Project is great. In fact, it doesn't even appear to be a technical book. Yeah? It's a funny story. Yeah?
What was that called again?
The Phoenix Project. Yeah, from Gene Kim. Yeah.
Yeah, it's like a novel of DevOps, right? So it tells a lot about our lives.
What we like about what we usually try to say about the business value, because big companies are used to have ITIL to provide the software configuration manager to control what changes. But in fact, when we control what changes, you increase the delay, and the delay it has a cost. Usually, people prevent change because it prevents risks. But with DevOps, it's the opposite. You increase change to prevent risk. It doesn't sound economical, but when you think about what usually break things in production, change of things. If you increase the batch of the things that you change, you increase the risk of something going wrong. But instead, if you reduce the amount of batch and you put in production, the only risk that you have, that little modification that you had in your code might go wrong. So if anything goes wrong, we are sure that that method that we changed provided the fault. So you know exactly where to look for. But when you increase the batch of changes, man, I changed 3,000 lines of code. Which one is causing the problem? It's much worse. I know we have a hard time convincing business people that instead of increasing the delay, we must reduce. But that's what Pratt has proven to us. You reduce the batch of change, you reduce the risk. In fact, in most of the cases, when you have a very small batch put in software production, it's much easier to spot the problem, correct it, and put another in production than rolling back. Because ITIL requires you to roll back, but I've never seen a successful rollback in production. Every time somebody has to do something to put back in production. So what we're asking, it's economically, if you think better, it makes economical sense to reduce the batch size.
Right.
Yeah.
And that's why, so reducing the risk is so amazingly important for you to deliver software, right? That's why automation and virtualization are so important. Because our whole objective is to be able to really fast put another version in production. So it has to be automated. It has to be virtualized, right? And you have to have some form of testing if that's working. You know, if you don't have those things, how can you quickly put a new version in production? You can't. So the whole objective here of those steps is to reduce the risk, put less things in production, and get more. So actually, it's a funny thing, right? Because we at the same time we reduce the risk, we accelerate the delivery, and we get more value to our customers. I mean, it's like a win-win-win situation all the time, right? And the problem is that we are so afraid of it that we kind of generated excuses to not do it, right? Although it's only wins, we say no, something is going to go wrong, so let's just delay it, and delay it, and delay it, and delay it, and we never do it, right? And then the worst thing of all is that we delay, and then suddenly someone's saying, we have to put this now. And then you put whatever you have. I mean, that's a huge risk, right? Because now you don't even, all the proposed improvements that you're thinking that you're gaining by delaying, you actually lose the whole thing because now you have to put in production rushing.
Yeah, the fact the action of you have to put it now is one of the key chapters of the Phoenix project. Yeah, right. You have to deliver now because that's the dates, man. Yeah. It's not because it's ready.
Yeah, not because it's ready. Yeah.
Yeah, but DevOps. Yeah, in fact, all of the steps that we told you about trying to improve DevOps will allow you to deploy it anytime because you will be ready at any time. Yeah, so you can reduce that risk.
Okay, guys. I think we're out of time here. Just let everyone, whoever, we're going to be here discussing more things, right?
But you have to leave the room. But we'll be just aside.
Yeah, but we're going to be here, right? So whoever wants to ask more questions, we're ready. We're going to be here the whole week. I'm easy to spot, right? So, but just, thanks very much for being and staying for so that long. Thanks a lot.
You.
Bum bum. Yeah. Hold on a second. Phone to mute. There we go. Ready to roll? Yeah. Super. Thank you everyone for coming today. Really appreciate it, particularly coming in after lunch. My name is Aid. I am the SVP of engineering for Gilt. I lead Gilt's engineering teams in New York and in Dublin. And I'm kind of presenting today on behalf of them, effectively, the story of Gilt. We have a very sophisticated microservices architecture. I think it's proof of existence that microservices really can work. I want to spend today kind of showing you how we got there, lessons learned, but also as well, what are still the challenges? Because there's a number of things that we learned along the way that we did not expect. And I think that these were really interesting challenges. Some of them we've got a really good handle on, and some of them we don't, okay? Yet, so we're still working on them. Apologies in advance as well. I have been a Java programmer for 20 years now. I do not have a code demo today. Okay, so if you're looking for a code demo, not this trip. Okay, so let's talk a little bit about it. So first, I realize in America, Gilt.com is a very well-known brand. What's interesting though is in Europe, it's where I come from, nobody actually knows what they are, what they do, right? I think it's really important to understand sort of the complexity of Gilt.com, okay, and the core business idea. So here's the story, right? What we do is we source luxury brands, luxury fashion brands, and then we make those available to our members at highly discounted prices. Okay, so these products, these could be things that are maybe like last year's stock or excess stock, or it could be brand new inventory that we get our hands on. We do these deals with these designers, and effectively they give us the inventory, and we get it in front of our members. So a lot of the time, one of the things we discovered is working with these designers, sometimes they don't actually have great editorial shots of their product. And so what we do is we take the product, and in many cases, we actually shoot that product in our own studios. Okay, so product comes in, we take the photograph, and then we ship back on to the warehouse. We've got a real warehouse. We're a real company, right? This is our massive warehouse out in Kentucky, and effectively that's where we receive, we store, we pick, we pack, we ship. We do the whole deal in terms of fulfillment. Okay, now. Why am I kind of telling you this? I guess I'm telling you this because there is no kind of off-the-shelf software that you can buy to run a business like Gilt. It's very different in a number of different dimensions. And so the software that we make, both the software that you guys see when you go to Gilt.com or when you use our apps, and the software that actually runs the entire business, that's actually all been written by Gilt Tech. Okay? So pretty, sophisticated set of software. One of the things I think that makes Gilt unique and to me interesting as an engineer is this property. So the first thing is we sell every day at noon. So we get all this inventory, and all of these sales go live at the same time at noon. Okay. Now, what actually happens is at 11:45 New York time every day, we start sending out our emails and our notifications. So we send 5.5 million emails every day to our members. About a third of those, we have enough information to personalize every single one. Okay. So we personalize all of the content in terms of, hey, we know you like this brand, so we're actually going to show you this brand or this sale much further up in the email to grab your attention. Okay, and likewise, the same for our notifications, our push notifications. We want to make sure that if you like a particular brand and we've got it, then we're going to send it to you. Okay, so then all of our customers come in hordes to the site. This is what our customers look like. A steaming herd of wildebeest. They're actually far more attractive than that and far more lucrative. But it's nice and fun to think of them looking like this. What they really look like from an engineering perspective is this. Okay, and this graph I think captures what's really interesting I think about the Gilt business model. Okay, it's the spike or what we call the pulse load at noon every day. So what happens is, and you can actually see that there on the graph, there's sort of like, a build up in the early morning, and then just before noon, we get this cliff. okay? And there's a number of interesting properties. Any software that we write has got to be enormously solid, right? It's got to be able to scale and handle that change of dynamic in a 15-minute period from, you know, very, very little traffic to completely off the chart traffic, okay? So that's actually, you know, really, really important. And of course, you know, while this is like an average day, when we have a really, really big day with a really, really big brand that goes viral, we need to be able to handle, for example, 2, 3, 4 times our usual peak load. So that's what makes, I think, Gilt very interesting from an engineering perspective. There's another piece as well to this slide that I think is interesting, which is the cost of failure is non-uniform throughout the day for us. Okay, you know, effectively, the period of the day where we earn most of our money is in that period between noon and, let's say, 2 o'clock or 3 o'clock. Okay, failure in that period of the day is enormously expensive. Okay, failure in the rest of the day is actually reasonably cheap. Okay, so it's really, really important for us that when the traffic comes, that we are up, that we are stable, and that the site looks and feels really, really great. Okay. So, I want to talk about how did we get to where we are today. Okay, so like many kind of shops, we've got this rails to riches kind of story. And effectively, the idea is you know, a small bunch of engineers kind of get together working on this idea called Gilt, and they hack out a prototype super fast in the programming language that they love, and that language is Ruby. Right, Ruby is an amazing programming language. It's absolutely fantastic. It's obviously there are some things that as Java programmers we would dislike, but overall, you know, Ruby's actually pretty cool. Okay, and so the original Gilt.com site was all written on Ruby on Rails. Okay, and effectively we had this architecture, right, which is like architecture 101. It's box, box, cylinder, box, right? Very, very simple. Okay, we had a big fat app server, right, called I don't know if they called it application servers then. We had basically Ruby on Rails. Okay, Ruby on Rails was hitting off our big database, which was Postgres, and still is Postgres in many parts. We do a lot of work with Postgres, and it's really, really fantastic for us. And so you can imagine as a company in those early days, it's like, well, that was fine, okay? We had all of our traffic, both our internal traffic to actually set up the sales and put up the products and take the photographs and handle the warehouse. All that code was in that monolithic database, but also all the code that handles every page rendering from Gilt.com, like from our customers. So the kind of things that you do to scale when you've got Ruby on Rails is you can see here we've got, you know, add memcache, right? And you try your best to avoid hitting the database as much as possible. Okay. So this worked, and it worked until it didn't work. Okay, but that I think the biggest kind of eye opener for us was a sale of a brand called Christian Louboutin. These shoes went live on Gilt.com. The whole thing went viral, and then effectively the site went down. Right, and you know, it's interesting. Sometimes we think about that. You know, the site going down is a very, very bad thing. Okay, sometimes it's not a bad thing because there's so much pent-up demand then that when the site comes back up, they all come back. Right, so it's actually kind of interesting. Okay, anyways, so when I joined Gilt in 2011, there had been a migration to a new technology called JAVA, or Java technology, okay? And there was a very, very interesting and I think kind of, you know, pragmatic change. So the business had grown hugely in the first 4 years of its existence, going from $1 million of revenue in its first year to $400 million in year 4, okay? That's just an incredible amount of growth. So with all this extra traffic, there actually was, you know, like a bake-off or a fist fight, a knife fight even, if you will, between the Ruby engineers and the Java engineers, right? And it turned out at the end the decision was made to go with Java. We simply couldn't scale Ruby to make it do what we needed to do. Okay, that is not a slight on Ruby. We love Ruby. We still do a lot of work in Ruby. It's just, I guess, a pragmatic fact. Okay. So what you see when you look at kind of the architecture at the time is, you know, to the far left, you see we still have this Ruby on Rails. So we're still using Ruby on Rails for our internal development, okay, for our internal staff, for our internal tooling, okay. Very fast, very easy to get stuff done. You know, and in terms of the Active Record is just an amazing tool in terms of productivity. So a lot of good stuff there in Ruby. But the core part of the site was actually all served using Java. Okay, so how did it look? Right. Well, what we had done was we had realized at noon the last thing you want is traffic, consumer traffic, to be hitting the database. The database isn't fast enough. It never will. It never will be to scale at that level. So what we did was we built a service layer for the classic kind of entities that you would expect: product service, user service, cart service. And these services effectively pulled all of our live data for the day into memory. Okay, so that every page hit was effectively being served from data that was in memory in those services. And that actually works pretty well for Gilt because 95%, 97%, a huge amount of our traffic is actually read-only. It's getting product listings, it's getting data about what we're selling on a given day. Okay, so that's the bottom layer there. And then what you see is this repeated kind of layer cake, a two-tier kind of approach to how we created our services, or created our site, okay? So what we had was, the top tier is a tier that effectively does the page rendering, the generation of the HTML content. And all of our content is server-side rendered. We're actually changing that now. We're doing a little bit more work with client-side rendering, but the bulk of what we serve is actually server-side rendered. Okay, so the idea then is you've got that top layer, and then it hits off a bottom layer, which is this content or page assembly layer. Okay, and so the idea is it makes a hit on, or the front end makes a hit on those services to get all of the data to construct a page. Okay, and for example, we've got a service there called PageGen for page generation, and it turns you out a whole bunch of JSON, and then you use that to render your page. Okay, so this is the way that we looked at the world. Okay, you see a number of different kind of pillars there. Like there's Gilt.com, GiltCity.com, Gilt.com/home, Gilt Taste. These were all businesses that we were running and experimenting in. And effectively, we had a different stack to render each business. Okay. Now, what were the problems? So a bunch of things, I think, that again, like when you're growing and moving fast, you make these mistakes, and they accrue over time. First was that our service layer, they were very, very large services, right? Product service is one of our biggest, right? It loads up our entire product catalog, but it also has things that are nothing to do with products. It has sales, which are actually lists of products, right? It has other endpoints that really aren't, logically coherent with the idea of a product service. The other thing as well, which drives me absolutely mental, is that these were very much loosely constrained or loosely typed services. Okay, effectively, with our heritage of Ruby, where effectively everything's just a map, give it a shot, right? That's how our Java engineers had done a lot of the work. They were throwing maps around, and when you throw maps around for your data, then you lose a sense of type safety, and you lose a sense of the compiler being able to help you. Okay, so that I think was a problem in those early days. Okay. We had multiple teams all focused on these different business lines, trying desperately to get code through. Okay. What's interesting, though, I think, is that most of the teams were all handling the channel under Gilt.com. That's this Swift thing and this PageGen thing, right? And when you've got 40 to 50 engineers all in contention on the same code base, that's actually a real problem. Effectively, this Swift app serving Gilt.com became a huge monolithic Java app and became a huge barrier for innovation. Question?
Is that Swift the Apple thing? Or?
Oh, it was a good question. It was not Swift the Apple thing. We all laughed heartily when Apple invented Swift. And we were like, oh, those guys. Right? No, absolutely, yeah. This is a Java framework for rendering for rendering JSPs. Okay, and we call it Swift. Okay, great. Hidden linkages and buried business logic. So one of the big problems that we found here was the whole idea of the layer cake, which you kept your rendering separate from your business logic, right? And the problem was on any given day, somebody wanted to get a feature in and they just janked it in, right? So they'd kind of make up a quick link to the database, do a query and get some data, and that was the quickest way to get something done, okay? And these build up and accrue over time, and you lose control over the code base and what it's trying to do, okay? And there's for me personally, an interesting example of this. So at the time that we wrote Home, the Gilt Home business, what I was looking for, what I needed was the marketing message of the day. And this is a very, very simple concept. The marketing message of the day is something like, free shipping for you or 10% off for you, my friend, okay? Now, this message is, as a service endpoint, is very simple. It's like, I'm going to give you a user GUID or a user email, and you're going to give me the message that we should show that particular user, okay? And so I was new to Guild at the time, and I was like, okay, hold on a second. So how would I get that information? Okay, and it turned out the way to get that information was to go into PageGen, get a rendering of the entire front page of the site, go 7 level deep into the JSON, forget everything else, and pull out that one string. Okay, and that was just for one little string that's probably about 80 characters long, right? So I sensed that there was something wrong here, right? And I proposed in a conversation with Mike Brzyk, the great Mike Brzyk, who was our CTO at the time. I said, so, I think we got this idea. I'd like to write a service. And the service is just going to have like one endpoint, right? And that endpoint is going to take a user GUID and it's going to give you the marketing message of the day. It would be brilliant, right? And everybody could use it and it would be the same logic in one place and it would be amazing, reusable, everything, And he was like, that sounds kind of crazy, right? So what we're going to do is we're going to hoist up 3 or 4 Java virtual machines, running this service endpoint just for this one thing. This is like clearly a crazy and stupid idea, So we did it, okay? That was the first microservice at Guild, okay? And it was amazing. It was like, we did it, we built it, and we're like, wow, it's the right thing to do. Okay, so that was in 2012. And effectively at that point, while we were thinking of what it meant to do services, we were actually asking, I guess, sort of the big questions. The big questions for us were this point 4, the huge bottleneck for innovation. When you've got, let's say, 6 or 7 engineering teams writing on the same code base, and when as well you have a separate QA team from your engineering teams, right? What you've got is a recipe for incredibly long cycles to get anything to production. Okay, you get a team who's blocked by another team, and then when they're unblocked, eventually 2 weeks later, their feature goes to production. Turns out it's broken, so we roll it back, and then it goes back to the team who started on something else. It's just not a happy scenario. So we said, well, how can we actually arrange our teams so that they can follow strategic initiatives, get stuff done, and get it done super fast, okay? And that's effectively where we got to today, okay? In 2015, we now have approximately 250 of these microservices and apps. So our landscape has changed hugely, okay? And effectively, so the world has changed quite a bit there. To highlight some of the key things, north, towards Guild.com, we realized that having everybody contention on one web app was actually really difficult for us. And so we broke up the web application by page almost. So we have a different application that serves our listing page or our search page or our product detail page, okay? And we call that LOSA, lots of small apps. And these were all implemented using Play Framework. The other thing then as well is we do a lot of work now with Scala. Right? I'm secretly hoping that next year we'll call this JavaOne and be done with it. So we have a lot of fun with Scala, and of course the general build system that we're using is SBT. We've got a lot of tooling built into SBT as well that helps us in terms of our continuous deployment and continuous integration. So that's what the world looks like now for us. We've got much more fine-grained web apps serving the experience. And then we've got a whole flock of services underneath that, okay? Interestingly, we still do have, those big chestnuts, the core services that we had before, And when you think about it, the innovation cycle, like you innovate towards something, you try something out. You don't necessarily adopt a full clean slate and say, let's wipe out everything that we've done before, right? So we still have our heritage or our kind of our legacy services that are there. And some of them, by the way, are rock solid. You think about your architecture, right? And if it was a city, the microservices are the really, really new, clean areas of town where all the hipsters live. Some of our older services, like our inventory service, is just like a Roman castle. It's just rock solid, built using Java, and it's just fantastic, okay? So you're going to get that mix in your architecture. Okay, so how did we get to this microservices architecture? So one of the things that I think is clear to me now is, or that should be said as well, we never once got into a room and said, let's actually, get a really, really big whiteboard and draw out all the possible services that we might need, and then that's our architecture, let's go implement it, okay? It simply didn't happen that way. So effectively, what we did was we put the mechanisms in place where teams could build whatever they felt they wanted and needed, okay? And therefore, the architecture emerges, right? And that was actually really, really interesting. So things that we did, we gave more autonomy to teams. We let them build whatever they needed to solve a given problem for Guild. So for example, hey, we don't have search on guild.com, okay? Let's create a team. You guys are the search team. Go build whatever you need. Okay. Likewise for personalization, right? We don't have personalization on the site. We need more. You guys do whatever you want to do, okay? Another thing as well, I think that was really interesting for us as a social experiment that I think has really, really paid off is the concept of voluntary adoption. At Guild, when something is good and people adopt it without being told, then you know it really, really is good, and it sort of becomes part of the lingua franca, part of the tool set that we all use. Okay, if people don't adopt it, then really it's a kind of a Darwinian force that tells you that your idea wasn't good enough or the tool isn't good enough. So we really let folk figure out for themselves, in the large part, what are the tools that they should be using. So there's a couple of other things there as well. We moved, as part of giving full technical freedom to the teams, we simply said, hey, here's a KPI. We want you to change conversion on the site, okay? Do whatever you want, right? And actually giving them that freedom, telling them what the goal is, but not actually telling them exactly how to do it, was really, really great in that way. Okay, so back to tech. So if we think about the way we adopted services over time, so this chart shows effectively the growth of services at Guild. There's a point of inflection that happened in February 2012, where at an architecture summit in New York, we realized that we were all writing far more Scala than we were writing Java. And that was a real interesting point because, as you can see, there's a point of inflection there as we all of a sudden write more and more services very, very freely, right? Now, part of that's not saying that Scala is ultimately a more productive programming language than Java. It's simply saying that when folk were given the opportunity to program something new, right, then they didn't need to code it in an existing repo. They basically just started off something themselves. Okay, so that was a very interesting point for us. Okay, so when we think about what does a typical Guild service look like and feel like, so effectively it's something like this. Okay, that's sort of a generic kind of architecture idea here. So basically all of our services, practically all of our services are deployed using a Java virtual machine. Typically, there's some kind of framework that you're using to kind of expose what are largely, in almost every case, RESTful endpoints. We don't do SOAP except for integration purposes. Sometimes we listen off queue technologies, but largely it's all RESTful calls over HTTP. Okay, your code goes there. Very interesting point is that for me, when you think about microservices, it's really important that the service owns its own data. So typically, each microservice has its own data store. That data store is owned only by that service. Okay, and that's a really, really important distinction. If you have the same data store owned by multiple services, then it means that schema upgrades and general ownership of the data gets very, very hard to manage. Okay. So then you're going to have some kind of solution for monitoring and something for logging as well. So what you're probably more interested in is, well, what are the choices that we use? We've got a very, very lightweight framework built over Jetty, which we call the Guild Service Framework, right? As a general rule, I'm really sorry, Larry Ellison, right? As a general rule, we like our frameworks to be as small as possible. Right? Like we don't use, I still call it J2EE. We don't use JEE in any way, all right? We use a very, very simple frameworks to get our services into play, okay, into place. So we have Guild Service Framework. One of the other things that we found for our JSON over HTTP services, which is a very surprising result, is that we use Play Framework for those. Play Framework is actually intended for building applications, web applications. It turns out it is very, very good for building services that return JSON over HTTP. We did not expect that when we started. So programming languages, people are free to choose whatever language they wish. Generally, they're Scala and Java. There we go. Question?
With regards to using Play, so while
Yeah.
I agree that Play works really well for RESTful services, it also comes with, it's very pervasive, it comes with a lot of kind of cognitive overhead because it's so big, it does so many different So how does that jive with your earlier comment that you prefer lighter weight?
That's a very, very good call. Effectively, we're using a fatter stack than we need for our Play services, right? That's actually very true, okay? Typically, the way it's just emerged is guys are using a small amount of the JSON rendering and then the general HTTP request response flow, and they're just ignoring the rest of the stuff. You're right, if Play actually cut down or restricted just that core piece, then that's the piece that we will be using for the services. But it's absolutely a fair point. Okay. Other things I think that are interesting there are in terms of the JVM and the actual container that we use. What we're finding now more is that people are more likely to use Node.js. We're starting our first kind of foray into using Node on the front end, and we're actually very happy with that. What's interesting there is Node appeals to a certain kind of engineer, a certain kind of developer, and we're kind of keen to support them in that. For monitoring, we use actually New Relic quite a bit. New Relic is quite incredible at just how completely easy it is to set it up and have it working, right? So we use that pretty much across the board. We also now use CloudWatch as well because we've moved most of our stuff is now running in the cloud. For monitoring as well, I'll talk a little bit about Cave later on. We've written what we think is a very interesting approach to monitoring and audit, and I'll give you more details on that later on. Okay, service discovery. So people have asked me before when I've given this talk, at Guild, how do you do service discovery? Okay, and service discovery can sound like an incredibly hard problem. It turns out actually it's very, very easy. It's very, very straightforward. I think when you think of service discovery at runtime, you've got a client and it needs to know what's the URL I should resolve to hit a particular service. Okay, very, very simple pattern, right? So the client, right, calls some kind of store, right, which is a map of strings to URLs, and says, hey, give me the trolley URL. It gets it back, and then it makes a RESTful call, always to a load balancer, right? Everything we do goes through a load balancer, right? I've seen frameworks before where you do kind of client-side load balancing, and we don't do that. Everything goes through a load balancer of some sort. And then the load balancer makes a call through whatever the service is on the right here. So what does that look like? For us, we use Zookeeper. Zookeeper is actually fantastic at providing a single point where we can serve in a very fault-tolerant way our configuration information. Likewise, Zookeeper allows you to register for triggers or changes on given configuration points. And that's actually very, very useful if you want to have all of your fleet of services get updated when some kind of some kind of configuration piece changes. So our load balancer that we use is Zeus, right? Through the miracle of marketing and mergers and acquisitions, it changed its name multiple times over the last year. It became Stingray, then SteelApp, and now it's called Brocade. But we find that to be a very, very good load balancer. All of our service traffic goes through that. And effectively, what happens there is, while you're rolling out, if you've got 4 instances of a service, while you're rolling it out and you take out one of the instances, Zeus figures that out, right? And it redirects, it says, yeah, that instance is down, let me redirect to one that's live, okay? So having a really smart load balancer in front of your services is a great way to make sure that all of your high availability, your fault tolerance, and your scalability is all met there. Okay, so we've got all these services. What are they doing? Okay, I built a word map by taking the names of all of our repos and effectively then saying what are the most common words. Surprisingly enough, service gets a big mention there. We've got also other services names that kind of pop up there. For example, user, data, admin, recommendation, email, search. I mean, effectively, our microservices stack is spanning every part of our business. Okay, so it's kind of nice to kind of see the cloud form and to see kind of the key contenders rise up. Okay, but that's actually kind of hard to manage. Okay, so we had this really funny moment where we were like, oh my God, how do we manage all these services? How do we think about them? Okay, and one of the guys was like, I know, let's write a service to manage all of the services, right? And you can appreciate there's something gently and playfully recursive there. And, one of our senior engineers, our distinguished engineers, actually just put his hand up and said, why don't we use a spreadsheet? Right, and we were all like knocked out by the simplicity of the concept. A spreadsheet? What is this technology? So it's Turing complete. You can share, you can collaborate. It's actually pretty awesome. So we used Google Sheets, right? And it's kind of interesting. We went from being a hard problem to simply being a list. Here are all the services that we've got. Here's who owns them. Here's what the service does. Here's some notes on what we think has to happen to the service. And we share that across our whole tech team. And we call that the Guilt Genome Project. And for any of you who are going down the road of building a large microservices architecture, particularly if you're going to do it in a sort of an emergent way, then actually this is a pretty good way to get a handle on how things work. Okay? So one of the things that we did recently then, and this was another very interesting learning for me, when you think of a list, the human mind can only hold 7 plus or minus 2 concepts at the same time, and we've got in the latest version of the list, I've got 265 services, right? How the hell do you go through all those and keep them in your head at the same moment in time? So we did something very, very simple. We added columns to the spreadsheet where we created a very simple taxonomy in terms of the major functional area of the site, okay, the system that the service was involved in, and then a subsystem if that made sense. So we made just 3 levels, okay? And what we found out then I think was actually very interesting, right? In terms of the architecture being emergent, what we also saw then was an interesting result. Some services and components are really simple, deceptively simple. By that I mean, you see the service, you worry about it, God, what does it do? I'm not quite sure. And then you go in there and you realize it's incredibly simple, or it's really small, totally contained. You could rewrite it in a day if you needed to, totally fine. But other services are simply deceptive. Okay, they look simple, but you can only understand their context when you figure out the constellation of services that it interacts with. Okay, this is something that Dan Salt and Jessica Kerr mentioned in terms previously of saying the complexity that was in our big services has now actually moved out into the white space between the services. Okay, so we've kind of just moved the problem around a little bit in terms of how we manage complexity. So. Deceptively simple. Why do I say that? It turns out that when you look at the sizes of our services in terms of lines of code, right, most of our services are pretty small, less than 2,048 lines of code, right? That's 2 to the 11, I think it is. That's actually great. That's a great result. Particularly when you think about, you're programming in Java or in Scala, and there's a lot of model files and things like that that are kind of, boosting up or kind of, bulking out kind of the number of lines of code that you've got. But for us, most of the services are actually pretty small. With 2,048 lines of code, you can go in there and you can figure out what the service is doing in about half an hour. Okay? And that's been a very, very nice outcome for us. So lots of these small services. Likewise, in terms of the source files per service, what we're seeing is most of them are less than 32 files. Okay? And again, that's not too bad. It's easy to get around a code base of that size. So that I think was a very, very good result. Okay. But when we think about complexity, right, the taxonomical approach that we took, the 3-level hierarchy, showed actually something really, really interesting. Okay, so based on a pivot table that I built in terms of the number of services per area, I got a structure that allowed me to build the following architectural diagram that was very useful to me. But what I noticed was that if you look down here at the service constellations, and I think you can just about see it, the resolution is kind of a bit grainy there. What we realize is that some parts of our business have a very large number of services related to them. Okay, so when I look down here, for example, inventory has 6 services. All of our inventory management logic is actually spread over 6 different services. That's a very, very interesting result. Okay, our distribution systems, they're split up over 9 different services. Okay, so this is actually a very interesting result for me. What it suggests is that this as an area is either necessarily complex, and we made a good decision to break it down into 9 or 10 different things, or we introduced too much complexity, and it's an area for us to go into and figure out what do we need to change, what do we need to merge, what do we need to rewrite there to make it a much simpler system. Okay, so we think an analysis like this, it's not rocket science, but for us it did actually turn up something very, very interesting in terms of our systems. Okay, so this year was very big for us because we used to run all of our services on bare metal in a data center, or 2 data centers in Phoenix and in Dulles. And effectively this year, the first quarter of the year, we moved everything entirely to the cloud. Okay, when I say everything, there's a little bit left in our data center to do with our data warehouse. But largely every component that you see if you're using our app, or our website, is being rendered from Amazon. Okay, how do you do that? There's a number of choices you have to make. And just to give you an idea, the approach that we took was kind of like two-phased or twofold. Okay, so the first thing is effectively what we call the lift and shift. And what we've done is we simply created a VPC with Amazon. We've connected that using a product that they make called Direct Connect, which is a dual 10 gigabit line with just 2 milliseconds of latency. Okay, and effectively what we did then was we were deploying services previously to our machines on the data center. So what we did was said, well, why don't we just deploy them to machines in Amazon? Okay, and so away we went. We had the big long list. We knew what we had to do. We divvied up the work between the teams. And in a period, when everything came to the crunch, in a period of 2 to 3 weeks, we moved all of our service infrastructure incrementally to the cloud. Okay, yeah, question.
In regards to service discovery,
Yeah.
did that mitigate the complexity of that task? I would imagine if you're working with microservices and service discovery, you could simply deploy piecemeal
Yeah.
to someplace else.
That's right. So the question is did our approach to service discovery, having a load balancer in the middle, did that help? And the answer there is yes, because if you think about it, you've got a service with, let's say, 3 endpoints, okay, which are in our top existing data center. And what we did was we said, right, well, let's actually launch another 3, right, in the VPC. Then we've got 6, right? And then once you've got 6, then we just simply removed the 3 that were in the old data center, and all the traffic just kept on going through automatically. So all in all, very straightforward. Nobody noticed, okay, which was exactly what you want, okay. What's interesting though is that's a very static move from the data center to the legacy VPC. And that's actually okay. It's the quickest way to get from A to B, right? We're simply deploying to machines that are hosted somewhere else. The next challenge then for us is moving to what we call department accounts for elasticity and for DevOps. So effectively, the original infrastructure is all moved to the legacy VPC. Now teams are writing new services and they're moving the services they own down into their team accounts. Okay, and into those team accounts, then they have full DevOps control to create whatever services, databases they need, and to do whatever elasticity or scaling that they want to do. So it's very much a move to DevOps for us. And the kind of infrastructure that Amazon gives us makes that possible. Okay, some things along the way. When we deployed to Amazon, one of the decisions that we made was to deploy every service to a single machine. To a single instance of an AMI. And that was a very important decision for us. What we learned in the past was in our data centers, we had many JVMs running on the same physical box. That means you don't get isolation between services. It means that from a performance perspective, it's always possible that a service could take out another service at noon. Okay, and a lot of our big major outages were actually caused by those circumstances. So effectively, when we moved to Amazon, we basically said, let's figure out the size of our JVM that we need. Let's get it onto a right-sized machine in Amazon, and then let's see what goes on. Okay. The more recent boxes that we're working with in the team account, we're using Docker to provide a kind of a thin layer then around that running instance. Now, the reasoning behind that then is that effectively what's in the blue layer there, what's in Docker, constitutes an immutable service deployment. Right? Once you've got that Docker image, that's it. That's the version number of the service, and you've confidence that will always run. Okay, but what we do is we allow the AMIs to be slightly mutable. So that we can, upgrade or change or do things there. And that's, I think, something that's worked very well for us. So at Guild, we're using Docker extensively, but we really are just using core Docker. We're not using any of the more fancier orchestration features or things like that. When we go and we deploy services to the new team accounts, effectively the implementation of this simple discovery model is slightly different. Effectively, we're still using Zookeeper for our repository, but we're using Amazon ELB as a load balancer. Okay, so we just kind of changed our approach there. Yeah, we have a question.
Client in this context just be an app that's trying to build a page, and so it's looking up the next services to get its info from?
Correct, yeah, exactly. So the client there could be, hey, I'm the search web app, and what I wanted to get is the user information so that I can put the username on top of the rendered output. So I'm hitting a user service through some kind of load balancer, and I'm getting a response on the user's information. Yeah, okay. Okay. So the number of running instances per service then, so when we think of the number of instances of any given service, right, then it's usually 3. So that's actually grand. There are some services that, due to the extensive amount of load and computation that they get, we have a much, much larger number. Okay, but on average, most of our services are simply deployed on 3 instances at a time. I think this is really interesting, this slide, because it shows that we're actually living the dream very much in terms of microservices. Because if you look, the bulk of the machines that we're deploying to are micro and small. Okay, so and that actually kind of makes sense, right? We're deploying the services, a single service to a machine, and we're just using the right size machine for what we need. Question?
Deploying to AWS, did you see like a large spike in the cost of hosting?
So that's interesting, actually. So deploying to AWS, our costs have come down. Right, now it hasn't been like a crazy, hey, we're doing it for nothing, right? I mean, like we got a little bit of a benefit in terms of cost. What I think is interesting, though, is we now have a way of tying the cost of our services and our initiatives directly to the teams that are actually doing them. Okay, so on a monthly basis, we now review our Amazon, our accounts, and we spot, hey, personalization, you guys are spending 40% more than you did last month. What's changed, right? And then you discover, oh, we implemented a new service and we forgot to resize it, or we left something running, and then you turn it down. So that kind of, closed loop from the people who are spending the cash, like having them see the bill has actually been really great in terms of driving down the cost. So, so this is the overall kind of picture of the entire evolution of Guilt in one step, right? And it captures those major moves, right? From large teams all competing on a small code base to massively kind of distributing the architecture, and then finally moving to the cloud. So. So things that we learned. Okay, so number one, we do love microservices. Okay. What it has allowed us to do is to code faster. We have lesser dependencies between teams, right? I don't have to wait for another team to get their code done to get the whole service out. I can code whenever I want. And we used to have this thing at Guilt that, during 11 o'clock and 3 o'clock on a given day, you were not allowed to deploy anything new, okay? Because the risk associated with that was just too high. But when we went to microservices, we were able to easily deploy any component right the way through the day. And that was actually one of our goals. Like, how do we make it so that we're always deploying software, okay? So without the dependencies between teams, there's lots of initiatives that I get to work in parallel then. That's actually been very, very nice as well, right? So you don't have to kind of have that bottleneck. we allow people to use, whatever technology, language they like. Generally, we're still on the JVM. We're still using JVM-based languages, okay? But the option is always there to try something new, okay? One of the things there, I think, is by looking at Docker as the unit of deployment, that actually makes it, a very level playing field for someone to deploy, whatever they want. Graceful degradation of service. It's quite possible on any given day that some of our services might break or we might expose a bug that we weren't sure of, right? What's interesting there, though, is the core e-commerce flow is not actually affected. And that's been really, really nice. Parts can break. We'll rush to fix them, but the whole experience will actually keep on running, okay? One of the other things as well that was really good is this idea of disposable code. We've implemented whole features like from web application to services to databases, where we've implemented the feature. For example, at one stage we implemented reverse auctions on Gilt.com. We tried it out. We found it confused and distracted our users. Our users didn't like it, and so effectively we just turned it all off, okay, and archived the code. And that's actually really great. You know what I mean? To be able to just remove code that really isn't adding to the business. It's very, very nice. Okay. Also as well, I think in fairness as well, we pretty much love the cloud, because while we always wanted to do DevOps, we found that it just was very, very hard to do when we were running our own data center. Since we have moved to Amazon and since we've taken on this idea of the larger teams owning their own accounts, this has meant then that we can actually get a lot more done, and we can really do DevOps. We weren't really able to do that before. Okay, so lots of goodness there, lots of greatness. Actually, as well, you can see there the low barrier of entry for new tech. Our engineers can experiment with new data stores, new queuing systems, whatever they like. The other thing we do get as well, which is really important for our business, is isolation. The idea that software running on these different machines, they don't actually cross over or affect each other. That was a big problem for us. Okay, so it's all rainbows and unicorns, okay, except when it isn't, okay? So there were a lot of things that we learned along the way, and so I want to kind of share things that were hard, okay? So first, one of the big problems for us that we didn't expect is that when you've got 250, 300 services, right? It's actually, you need a new approach or a new way to think about how to do your testing, environments. Because if you think about it, like we had, let's say, 5 or 6 different testing environments previously, and they were all running around 20, 30 services and everything was fine. And all of a sudden then we're in a situation where each environment we need to run 250 services, right? That's really, really hard to maintain and keep those environments up to date. And what happens then is you're testing an environment that's out of date. You think it's all going to work. They then deploy to production, and it doesn't work because the original test environment wasn't actually reflecting what was in production. And that's actually a real problem, okay? So what we've done is we've invested in saying, how do we test in production? Okay. What are the techniques that teams can use to deploy code safely to production in a way that they can verify that everything is working, but also that our customers are not affected? Okay. So we have a lot of automation. We use initially dark canary code, so that's where we release. Our engineers can see the changes, but our customers do not. Then we upgrade to an actual canary release, which is where of the 4 services, one of the services is running the new instance, okay? And then finally then you roll out. So that kind of staged rollout can be very, very good. There's also some really good ideas from ThoughtWorks on this idea of, you're better to do as much of your testing within the repo itself in terms of unit testing, and then go up the pyramid, okay? And when you actually get to this final stage of deploying to production, then your testing is smaller. It's a smaller amount of sanity testing to make sure that everything is okay. Okay? So there's it's still an area of big debate at Gilt. For some teams, testing in production is a no-brainer. They do it all the time. For some teams, right, it's not, okay? And what we found there was, for example, if you're the order processing team, right, and you're testing software that actually could send stuff to a user or have a payment or an account credited, that's a very delicate area of the code, and testing in production, is hard, Okay, so effectively what we've done there is we looked at ways to create a minimal testing environment for those teams. And there's only 2 teams actually that actually need to have a staging environment now. And that's something that we learned along the way. Okay, so I would say if you're thinking of going down this road, please think about how you're going to test. Very important. Yeah?
Replicate the whole thing, or it's just like you have those 2 services and connect devices?
So yeah, so basically we've created one kind of sandbox/stage environment where we've hosted only the services, which is a subset, probably I think around 90 services that those teams need to verify their code. Okay, and that's been a compromise over time that we've landed on. Okay. Okay. So ownership is massively important, okay? Ownership is important because, the guys who write the services, they capture the domain knowledge of the business and the domain knowledge of the code that they've written, okay? What you see over time is that tech organizations change, right? Great people come to your organization, great people move on, okay? And it's very easy then when there's all of these services, it's very easy to lose track. Okay, and figure out, like who actually owns this? How does this thing work? Okay, and so I've got a couple of reasonably new slides on this. We've thought very, very deeply about ownership and the way an organization should own software. Okay, so the way we're looking at it is this, right? The teams of, let's say, 4 to 5 engineers, right? They're responsible for getting their code written and they're getting their code into production. Okay, so they're responsible. We don't have a separate kind of site reliability engineering team that runs your stuff. You're responsible to run it. Okay, so the engineers are responsible. Okay, now we group those teams into teams of teams. We call them departments. Okay, and that's led by a director. Okay, and that director's got a good engineering head on him or her, and effectively that person is accountable. They need to make sure that whatever the changes in staff, okay, that the main knowledge of what these services do, right, and how we run them is kept, within the organization. Okay, so they're accountable. Okay. Separately, then, we've built this virtual architecture board by plucking principals and senior engineers from various departments, right, and saying, right, we want you guys to get together, right, and give guidance to the organization, right. So those guys are great. They're not an ivory tower. They're actually very much embedded in their own departments. What they do is they give guidance to all of the engineers at Gilt. And what's great is, as an engineer, you can completely ignore what the architecture board has told you to do, right? You have that right, okay? But you do so at your peril, okay? If you really want to, ignore the smart folk who maybe have experienced this and done this before, then away you go, okay? And then last of all, tech exec, they remain informed, right? Effectively, so we let the people running tech at Gilt know, here's what's going on. Okay, this has been really, really important for us. Another thing that's been important is classifying ownership. This is a gift that I give to you because this has turned out to be really useful for us. Okay, we decided to think about the software components that we had, and we said, well, any given service, if I own it, right, it's either active ownership, I'm developing on it, the code is clean, it's absolutely fantastic, I feel great about it, okay, or it's passive ownership. Passive ownership is, haven't touched it in maybe 3 to 6 months, but we know what it does, feel good, can hop in there at any time and fix something if there's a problem, okay? At-risk ownership is WTF. Why the hell have I been given this service? I don't think I should own it. I never wrote it. I don't like that code. I don't want to go in there, okay? We call that at risk, right? What's great though is when you classify the services in that way, and it's a very simple classification, you end up then having, these, I call them an ownership donut. That's just the way I drew the graph. The ownership donut can show for any department how much risk they're carrying and how good they feel about the software that they hold. Okay, but also when we think about the amount of at risk, which is in red, that means we can actually use that to inform our technical strategy. Right? Hey, it's clear this particular team has a lot of problems in terms of ownership. In the next 3 months, we need to do something about that. Maybe that's rewriting a service. Maybe that's just documenting a service. We need to do something about that. And this has turned out to be very, very useful for us. Okay, so some other quick areas. Deployment. When you deploy to the cloud and you deploy your services, having great tooling around deployment is really important. We have lots of great tooling. We have too much great tooling around deployment. We have about 7 different ways to deploy services right now at Guild, right? And that's because there's so much change in this area. We're kind of honing in on a core set of AWS deployment tools that make a lot of sense. However, one thing that we have worked on as well, and we're still using, is something called Iron Roller. And this is a really, really neat tool for having this continuous deployment, okay? And it handles the entire life cycle of rolling out software to a brand new set of nodes in Amazon, gently migrating the traffic over, keeping the old instances running so that if you need to do a rollback, you can roll back instantly, okay? And that's actually been a very, very nice tool. So github.com, Guild Iron Roller, we open sourced that recently. One of the other things I think that is super important is lightweight APIs. We made a big mistake, I think, about 2 or 3 years ago. It made a lot of sense at the time in terms of handwriting client APIs to handle these services, right? These clients were written in Scala and Java. And the problem that we had there is that the client had dependencies, and the dependencies had dependencies. And so basically, to use any client, you were pulling in a whole tree of dependencies. And that, it turns out, then causes lots of problems in terms of future upgrades and conflicts in software. So what we're actually moving into now is, I guess, 2 things here. First, REST. We make sure that everybody does proper REST APIs. We document them in a non-programming language, right? We document them using apidoc.me, something similar to Swagger. But then we generate clients, and the beauty of the client code that we generate is that it's a single file, and it only has no dependencies, right? It uses whatever APIs are commonly available on the platform that you're working on, okay? And that means then you've got 0 dependencies, and it's actually very, very nice. Okay. The other thing then, so we've got this tool called Cave. So you're deploying lots of software regularly to production. One of the great ideas that I picked up from the guys at Nearform is this idea of saying you should look in your system for the things that should always be true. And you should monitor those things that should always be true. And that way, when they break, right, when they're no longer true, then you know there is a problem in your system. This is a great idea. So we have this software that we wrote called Cave. And what it allows you to do is to create rules like this one here. The number of orders that have shipped to the US in the last 5 minutes should not be equal to 0, right? Or rather, if it is equal to 0, then we need to raise an alert, okay? So by tracking business level metrics, then we know that with any given deployment, we can look back and go, hold on a second, something broke after this deployment. Let's find out what's happening there. Good question, yeah. What, which does? Riemann. I don't know Riemann. It could be. It could be.
Riemann will similar to Esper, I guess. I mean, it seems there are already tools to do this. I'm just curious why you ended up.
So we started Cave about 1.5 years ago. Okay, and I think at the time, doing this kind of time stream analysis, we couldn't see a tool that would do it as effectively for us. Okay, so we wrote something ourselves. But certainly, if there's something there now, I mean, I'd be very interested to look about it. So maybe we would chat afterwards. That'd be great. Okay. So 2 other quick things before I run out of time. I/O explosion. This is something that you really have to watch out for. If you have services that on a given path call other services, and those services call other services, and they call other services, you end up in a risk of having all of your code just kind of fan out. Okay, with all of these extra calls. Okay, and I think that we've discovered there that this very, very free and open and almost anarchic way of writing services, we've actually left the possibility now for lots of services to be overcalled or undercalled. Okay, and so we're looking at different approaches now for this. We're looking at Lambda architecture for critical APIs. So the idea would be that for some of our critical calls, why don't we pre-compute as much of the answers as possible, store them, and then it's just an order 1 lookup or a constant time lookup for the results. Okay, and that's actually a very, very nice kind of way to look at things. That's I/O explosion. Last thing that you need to watch out for is your data team. Because what happens when you explode out all of your services and you explode out or you decentralize all of your data? And so previously, the data team was able to join everything, right, and do these queries for your business intelligence or your insight, okay? And the problem that we have when you split up all your services like this is the data team will go, where the hell is everything, okay? So effectively, we've built services to ingest events from all of our microservices, so that we can pull them into, or we store them on S3 in big buckets, and then we pull them into our data warehouse so that we can still get the business intelligence that we need, okay? I'd say it's really important, have a strategy or have a think about how you want to pull the data back together, okay? Very important. Awesome, so that's it. That's my 7 challenges. Thank you very much for coming today. I'm around here for the next couple of days, and if you have any questions, that'd be great. Thank you. Question?
One on the transaction thing, when there are different services talking to each other, how are you managing the transactions if any one of the
It's a good question. So when you say transaction, I presume you mean like a transactional context. So we avoid distributed transactions like the plague. We simply don't do it. So we try and make all of our services idempotent so that if we have to do a replay from a client that hasn't got a receipt, then we do that. So all of our kind of error handling around that would be handled at an application level. I think the experience that we've had has simply been that we've never found a good distributed transaction processor that could be used across the entire board. So that's our case there. We move it all into the application level code.
Second question is,
sure.
Since you migrated from the old legacy system to the new one, and it's like you migrated in the services way where you created different schema for it.
Yeah.
How did you manage the data between these two systems? How did you sync the data between these two?
Yeah, so it's a good question. So one of the big things that we did was we moved all of our user data from a system built on Postgres, the original system, we moved it to MongoDB, okay? And effectively, as part of that transition, we built the code to sync forward the data into Mongo. But then once we made MongoDB writable, we synced that information back so that all the information in the old Postgres table was actually always kept up to date. Okay, so there's no simple answer to that. It's like if you need to have the data in multiple places, you have to write code to do that, to do the move, the migration. Take out one here, yeah.
You said that you work with ThoughtWorks.
Yeah.
And that made answered a big question for why our service. Because I'm with Saks Fifth Avenue, and we're working with. It turns out almost step by step, almost exactly the same as what you're doing at Guild.
Okay, cool, awesome.
We're working with ThoughtWorks also.
Yeah, awesome. Okay, cool. Cool.
We're doing the same thing. We're scaling up with an emergent system with a bunch of microservices and everything as we're migrating to a new platform for Saks.
Yeah, nice, awesome, cool. There was a question there. Yeah.
How do you handle microservice API security?
So we're actually very fortunate in that regard. Right now, we don't have a security issue because most of our payload is just plain text, right? It's non-actually insecure payload or payload that needs to be secured. Okay. What we're moving to is a model where again, so we have closed doors around, or like a closed firewall around all of our internal traffic. What we're moving to a model is as we push APIs and move them to the front where public can actually call those APIs, we're looking into using Amazon's API gateway to provide token-based authorization and authentication at that level there. Okay, so yeah, cool. I'll take a couple more. Yeah. So it's a good point. So the services deployed as clusters, generally it's a mixture of availability and scale. Okay, so we took a general, like top of the head rule, 2 is not enough, 3 for most services should be enough. Okay, and that's what we typically deploy to. But some of our services may have like 10 or 12 instances as required. What we're now moving to is like typically we over provision. That's what we've always done at Gilt, and that's what we're currently doing in the legacy VPC. However, newer services are actually being provisioned using auto-scaling groups. So for example, our cart, which we recently rewrote over DynamoDB, it's usually down at 2 instances during most part of the day, and then it scales up to 6 during noon. So we find that's actually been very effective for us. Yeah, cool. Sorry? Oh, sorry, I couldn't hear that, sorry.
You mentioned some of the data stores components that you're using for these small services.
The stores component?
The databases that you're using.
Oh, what kind of databases we're using? Okay, so typically, so we've used a number. Postgres, very popular, right? We use RDS. We also use Voldemort historically, but we're moving away from that. And the things that we were using in Voldemort, we're now using DynamoDB for. Okay, we still have MongoDB as well, but we're for some of our services we're moving off MongoDB. I think the thing that we face is that whenever we implement a new service and we're in the Amazon kind of environment, then it's usually a choice between Dynamo or RDS. We find that's the case. Okay, great. Oh, I'll take this one. Sorry. Service versioning is a great question. So one of the great things about API Doc is that it actually allows you to version your services, right, with a major minor update or a major minor patch scheme, so using semver. And what's really nice about API Doc is it will actually tell you, if you make an update to the service and you upload that change, it will say, okay, this is actually a minor update because you added something. But if it sees that you've removed something or changed something, then it will actually say, it will force you, right, to say, yeah, this is a major update, okay? So typically, like that's been a nice kind of thing to have now. But for all of our services over the last 2 or 3 years, like before API Doc, we've simply, just gone through great pains to make sure that they were backward compatible, right? That just always make it backward compatible. Because in general, you don't have control over the number of clients who are using your software. So realistically, you've got to keep backwards compatibility for as long as the clients are out there. Okay, cool. I'll take maybe one more. Yeah, great.
How can you continuously push the product and when you have database changes in the schema?
So we put our database changes as well are always backwards compatible. Okay, so. And that's been important for us particularly. So if we look at our legacy large Postgres database, there are so many services that are using that if you were to make a breaking change to the database, effectively there's no way that you could restart all 30 or 40 dependent services at the same time. So as a result, on those databases, we've just moved slowly to get the upgrades being incremental. Okay, all right, cool. Great. Okay. Maybe we should wrap up. And like I say, I'm around, open for beers or coffees or whatever. So please, kind of come up. All right. Thanks very much, everyone. Thank you.
You guys really good at coming out to conferences and stuff.
Okay, thank you. Hi, everybody. Thanks for coming today. My name is Patrick Chanezon. I work at Docker. And today we're going to talk about Docker orchestration. And the talk is subtitled Welcome to the Jungle. First, because I love that album by Guns N' Roses. Second aspect is that when I started digging into Docker orchestration, I think more than a year ago, I really felt like a monkey lost in the jungle. It's really, when you started to use Docker as a developer, it's very easy and straightforward. As soon as you try to put it in production and orchestrate it, there are lots of different systems out there. So I've been giving this talk for the past year, making it evolve with time. And the goal here is to give you some kind of an idea of the various orchestration systems out there, the various choices, and also I'll tell you about the latest updates from a Docker orchestration point of view in Docker 1.9 and Swarm 1.0. So I was joking with a gentleman at the front row just before I started, because the stuff I'm going to present today, especially the demos, the paint is really still fresh on that software. And here I'm talking about the documentation for it is in a PR on the Docker GitHub repo. I'm using Docker 1.9 RC2, which was released, I think, beginning of last week. And Docker Swarm 1.0 or RC as well. So all this stuff should be pretty available, I'd say, in the next 2 to 3 weeks. But right now, it's like I made it work. It's like I'm crossing fingers that it works again. All right, so let's go into it. So first about myself. So I'm French, as you can guess from my accent. It's my 3rd or 4th time at JavaOne. I'm a Java developer. I spent the first 10 years of my career building platforms at Netscape, AOL, and Sun, and then the next 10 years doing evangelism at Google, VMware, and Microsoft. And there at Google, I was involved in the cloud platform that evolved into Kubernetes right now. At VMware, I was involved in Cloud Foundry, so I have a strong interest in cloud platforms, and at Microsoft with Azure. And 6 months ago, I joined that startup called Docker. And the reason I joined Docker is that when I started playing with Docker, I think it was a year ago, while I was at Microsoft, my role then was to try to bring Java developers and Linux developers to the Azure platform. And I started playing with Docker, and I realized, hey, that's the best way to build microservices-based applications. And the impression I had after playing with it for a few days, building applications, was exactly the same impression I had when I joined Netscape. When I tried the Netscape browser in '97, I really thought this is a new way of building applications. And with Docker, after using it day to day, I had the same feeling. So today we're going to talk about orchestration. It's really a jungle out there. There are lots of different players. Basically, you have the 3 big cloud players at the bottom, Microsoft, Amazon, and Google. All of them have hosted software as a service orchestration platform that you can use. Giant has one as well. On top of it, you have Tutum, which has been acquired by Docker, I think last week. So that's a pretty recent news. So Tutum is kind of in the middle. They're an orchestration platform that's hosted in SaaS mode. So you just create an account over there, but you can bring your own infrastructure to it. So you can build hybrid systems with it. And then you have all the systems that you can install behind the firewall or in any cloud. So the big 3 are Swarm, Mesos, and Kubernetes. And then there are lots of other players like RancherOS. Cloud Foundry is reinventing itself as an orchestration platform. Bluemix by IBM is mixing Cloud Foundry plus some Docker services in there. And Aprenda, which was a PaaS that was focused on Java and .NET developers, added Docker support to their offering. So basically today, if you want to run containers in production, you have lots of options of offerings, some open source and some that you can buy from some of these colorful characters in there. So Back to the Future. This week is Back to the Future week, and that made me think about that quote by William Gibson. The future is already here, it's just not evenly distributed. All throughout my career, I just tried to be at the top of the wave and trying to go to companies that were trying to invent the future. I think with Docker, and especially in the orchestration area, there's lots of things that people are using today in production that still need to get deployed into the enterprise. So Docker's mission is to build tools of mass innovation. What we mean by that is that we're trying to make the internet programmable right now. That's our main focus. So right now, when you want to program for different devices, there are silos, and what we're trying to create is that unified software layer that will allow you to create distributed systems in an easy way. That's a slide I was using when I was at Microsoft to explain to my team why Docker was important and what was Microsoft's position in the cloud market. Right now, basically, the cloud market has these three giants, Google, Microsoft, and Amazon, who have public cloud, and public cloud is starting to get adopted right now. And then on the left, you have VMware, who owns private cloud and is trying to get to public cloud with vCloud Air, but it doesn't take off really well. And in terms of strategy, the different players have different stories there, and I illustrated that with movies. So on the left, you have VMware. I compare that to the movie 300. They're super courageous, they have great technology, and they shout Sparta, but at the end, we all know how it ends for these guys. That's my point of view. And I spent a few years at VMware, so I feel free to put some jabs at these guys. Now they're part of Dell.
That's even worse.
Yeah, So then you have Amazon, and that's a Microsoft point of view. So Amazon, they're like these monsters in Pacific Rim who comes from a fault at the bottom of the Pacific Ocean, and they invade the enterprise market by surprise. The goal at Microsoft was to send them back there, like in the movie. But they're very strong in public cloud. Then you have Google, and Google, I spent 6 years there, the last 2 years on the cloud platform, and I tried to go sell Google Cloud Platform into enterprises. I told them, okay, this is PaaS only, it's only hosted, there's nothing you can install behind the firewall, and they told me, hey, just come back to me when you have a serious offering, because we want hybrid, and we want to have choice. And to me, Google really felt like that character Marty in Back to the Future when he's from the 80s and he comes back to the 50s and he starts playing rock and roll in that scene. And people in the 50s, they are ready to discover rock and roll. They like it. But then at the end, he starts playing hard rock, and then there's a big silence. Like these people don't understand hard rock because they haven't gone through rock and roll yet. And that's exactly the feeling I had when I was pitching a Google Cloud Platform to enterprises. I think Google is missing that transition story from where you are to where the future is. I think with Kubernetes, they're trying to get that and starting to have a hybrid play with an open source offering that you could install on premise. Microsoft, to me, it's like Field of Dreams. They're building, they have a strong presence with Windows Server in the enterprises. They build Azure. Azure is it's not only Windows, it's also a lot of Linux. And then with Azure Stack, they give you something that you can install, some Azure version you can install on premise. What happened in the past few years, actually I would say in the past year, is that when Docker started to get adoption, it became central into changing the whole industry. So the whole industry reorganized around containers. And so what we see today in the container ecosystem is that we see that new stack where at the bottom you have the equivalent of the hardware. So that's virtualization if you're behind the firewall on the left with VMware. And then your cloud provider resources, infrastructure as a service. So Azure, Amazon Web Services, and Google Compute Engine. Then on top of that, you install an operating system. And usually it was Linux. Now following CoreOS lead, who started to create that small Linux distro that is just designed to run containers, All the other players from Red Hat with Atomic, Ubuntu with Ubuntu Core, VMware with Photon, created a small Linux distro that is just designed to run containers. Rancher OS is the one that I find the most interesting because they go all the way where you just have the Linux kernel and 2 Docker engines, system Docker for running your system services, and then userland Docker for running your workloads. On top of that, you have Docker. On the left, you have all the ecosystem of plugin providers, people who enhance Docker. For example, Weave for networking. It provides you software-defined networking for containers, or Flutter for moving volumes around in a cluster. And then on the right, there's orchestration, which is what we'll focus on today. I have a few slides about the business opportunity if you need to talk to your manager to explain why you came to JavaOne this week. These are kind of the business reasons why you would do that. One of the reasons is that as developers, we love complexity. I think building your application, breaking it out, the big monolith that we've been building in the 90s and 2000s into these microservices that can be scaled and operated independently really helps reduce complexity. Another aspect is PaaS. So PaaS were super popular, I'd say, 7 years ago, something like that, between 2008 when Google App Engine was introduced to 2 years ago when Docker appeared. So with PaaS, you, the developer, you focus on your application, you focus on your code, you push your code to the platform and the platform takes care of it. The problem with PaaS is that the model that they provide is too restrictive. Very often developers wanted to add additional services, and when Docker appeared, it enabled developers to have some of the benefits of PaaSes while being free to add whatever services they needed in there. Docker really helps being agile. And I like this quote by Adrian Cockcroft from Netflix. It really helps reduce the mean time between IDs and making stuff happen, which is what we want to do at the end. So agility really helps with dollars. What that means is that it helps developers focus on building business value as opposed to building infrastructure code. Another aspect that, another aspect that, let me just cancel that. Okay, so he wants my keychain, I'll give it to him.
Now it'll show us all your passwords?
Yeah, I guess. Another aspect that's important is DevOps. That's a movement that started, I'd say, 7 years ago. And to me, it's a continuation of Agile when people start operating, when developers start to work closer with ops in order to do continuous deployment of their applications. So in the mainframe era, the relationship between devs and ops wasn't great. In the client-server era, where you had a big Oracle database on the back end and a client-server application on the front end, it wasn't better. In the web era, like we weren't even using the same languages between devs and ops. Ops were using Perl. On the dev side, we were either C++ or Java later. And then with the cloud and the DevOps movement lately, devs and ops have started collaborating much more. DevOps is more about people and processes more than about products. But I think Docker is really the right level of abstraction for dev and ops to work together. So Docker, at the heart of it, it's essentially a simple tool that allows you to leverage Linux kernel features, which are namespaces, that allow you to isolate your processes, and C groups that allow to control the resources that you're providing to these processes. Another innovation that Docker brought that VMs didn't have is this notion of layers. So images are built in layers that you can inherit, which means that if you're running 15 different processes that are all based on Ubuntu, you download Ubuntu only once, and then the layer for Nginx or for my Spring application will be just 2 different layers that are pulled by the engine. And so that allows you to not to have to download gigabytes every time you launch a new process, which was the case with VMs. So Docker's mission is to build tools for build, ship, and run application. So in terms of tools, we have Docker itself. So if you're a Java developer, very often you start with the Docker Java image. So you write a Docker file. It's a very simple declarative file where you declare what you want in your image. And you can inherit from the official Java image or build your own custom base image that developers within your company can inherit. So there you copy your source code and you can compile it in there, or you can compile it in a CI/CD system and then build the image at the end of it. Once you've done that, you build your image with Docker build, and then you run it with Docker run. So Docker Compose, very often your application is, okay, you have your main process that's your Java application, for example, but it relies on 2 or 3 services, maybe MongoDB for the backend database, or Oracle, or Redis for caching. You can assemble what is called a compose file, which is a declarative format, pretty simple, where you define all your images, the links between them. And then when you're done, you do a Docker Compose up in the directory where that file is, and Compose is going to spin off all your containers and give you access to the logs for these containers. So it's a very useful tool for onboarding developers. When you have new developers, the Docker file is the equivalent of the README, and the Compose file is the equivalent of the whole documentation for how developers can get started. So now your developers just need to have a Git clone of the repository and Docker Compose up, and they're up and running right away. There's been a bunch of blog posts about how people are using it this way. Now, another aspect of Docker is when you want to run Docker processes on a host, you need to install Docker Engine on it. So lots of people have lots of scripts for provisioning it, and you can use Puppet or Chef or Ansible or one of the existing DevOps tools for that. We try to make it super simple with a tool that's called Docker Machine that lets you create in any virtualization provider or any cloud provider a host that has Docker Engine already installed and configured securely for you. So that's an example of creating a machine in Azure. There, I'm using the Azure driver. I specify my Azure subscription and cert, the type of machine I want, and then the name of the machine. And once I've done that, I have my machine up and running, and I can start using it right away in Docker. So it works for all cloud providers, virtualization providers. When I started talking about Docker at Microsoft and training my colleagues about Docker, I went in on the command line right away. And one of the comments they had is, where's the UI? And I said, sorry guys, there's no UI. A few months later, Docker acquired that company called Kitematic. So now we have a UI that's called Kitematic. It's cross-platform, so it works on Mac, Windows, and I think they're working on a Linux version. It's based on Electron Shell. So it's in JavaScript, Electron Shell, and then it's cross-platform with that. Okay, so we looked at the build part. Now let's look at the ship. So how do you ship your application? If it's an open source application or an official image, you use Docker Hub. So that's our hosted a hub for storing images. So when you do a Docker build, after that you can do a Docker push of your image in the hub. And Hub allows you to have one private image, and you can buy subscription to have more private images. So Hub is really where ops and devs are collaborating together. That's where access control is set for images and things like that. Now, Docker, all that I talked about for now is mostly open source products. Docker needs to make money. The way we make money is with offerings for the enterprise. So we have Docker Trusted Registry. That's a registry like Hub that you can install behind the firewall. And that has LDAP integration, and that's LDAP Active Directory and other enterprise features. So that's the way that you can set up your own registry for a work group inside of a company. So that's Trusted Registry. And let's take a look at the run. On the run side, we have a philosophy of Docker of batteries included but removable or swappable, which means plugins. So we have a bunch of plugins for orchestration. We have scheduler plugins. I'll tell you about that for Mesos, if you don't like the one that's in Swarm. For engine, we have volume plugins. There's one for Azure, one for EBS, and there's Flocker, which was the first one that was done. And I think they were based on how is it called? The Solaris ZFS. Then we have network plugins. So Docker has networking, and I'll tell you a little bit more about that. There are 6 different plugins for networking. We have the one that's included, but you can use Weave, Calico, or Cisco. And for service discovery, it's pluggable as well. You can use Zookeeper, etcd, or Console. So now let's talk a little bit about the Docker orchestration offering. It's called Swarm. So when you're using Docker, you're in your terminal, and your command line targets one engine. What Swarm is essentially a daemon that sits in front of your cluster that talks to all of the machine clusters through the Docker API. And then using your client, you're talking the same Docker API to Docker Swarm. In terms of load balancing, so that's one of the things that was missing from Swarm. There's an open source project that's called Interlock. I'll show you if I have some time. Docker Swarm, compared to Kubernetes, doesn't have the notion of service. So when you're provisioning all your, for example, let's say you have a front end and you have 10 instances of it, you still need to do the load balancing by yourself. What Interlock is it's a Go program that you can run as a container. And what it does is that it listens to the event stream from the Swarm engine. And every time there's a new container that's plugged in there that has a -- host equals something, it's just regenerating a HA proxy configuration or Nginx configuration on the fly and restarts Nginx or HA proxy. So it allows you to basically do discovery in an automated way. Project Orca is something that we announced at DockerCon, and it's an enterprise offering for running containers. So we did a demo at DockerCon last June. It's in private beta right now. There will be a public beta pretty soon. And then, so Orca gathers together Swarm, Interlock, and a bunch of other components for building, shipping, and running containers, and for auditing them, and it's doing log management, and etc. Tutum is an offering that lets you bring your own IaaS or your own infrastructure, and then orchestrate Docker containers on top of it. And so Tutum joined Docker last week. I didn't have time to do a demo of Tutum in there, but that's something I highly advise you to take a look at. It's really a very, very cool platform for developers. So lots of enterprises are using Docker today. And one of the things that happened is that last year there's been a lot of talk where people were saying Docker became like a de facto standard, but we want a real standard right now. Because everybody's using it, the whole industry is standardizing on it, so you need to have a formal standard. So what we announced at DockerCon last June is the creation of the Open Container Initiative with nearly everybody in the industry, from CoreOS to Microsoft, Google, Amazon. There are like 35 companies in there. And in there, what we're standardizing on is the format of the bundle for a Docker image, for a container image, an image bundle. So what's on the disk where you're going to run your container, and then the configuration of how to specify how you want to create your container, like the namespaces and C groups that you want to set in there. And OCI specification is trying to be multi-architecture, so it should work for Intel as well as ARM and PowerPC. And it's also multi-operating system, which means it works as well on Linux. So that's the main section right now. But Microsoft is contributing on the Windows side as well. So it should be a spec that works across platform. And Microsoft on their side, they're busy implementing Docker for Windows, which means you were talking about that a little bit before. So Docker for Windows is not running Linux containers on Windows. It's a re-implementation of the Docker backend in terms of Windows isolation primitives. So it allows you to have the benefit of containers, but for Windows applications that are running only on Windows. But then you can use the same Docker tools for your Java and Windows applications. So that's OCI. OCI, the charter is being finalized right now. We're in the last stages of finalizing it. And there's already a draft of the spec, 0.01, that's available on the GitHub site for it. And what's more interesting is the plumbing aspect, which is OCI has a reference implementation that's called runC. So runC is a reference implementation of the OCI spec. It means that you can use that, and runC is based on libcontainer, which is the same code that Docker is using. And so runC lets you run containers without using Docker. So you use another way to create your images, or you get them from Docker Hub and you export them on the file system. Then you can craft a JSON config file for how to specify the isolation of the container you want to run, and then you use runC for creating the container. One of the things that's interesting in runC is that it has some features that Docker doesn't expose yet, like CRY-U, for example, for snapshot and restore of containers. And if you look at the DockerCon closing keynote from last June, my colleagues Arnaud and Michael did a demo of like running a container with runC and then snapshotting it and moving it from Amsterdam to Hong Kong, and they were playing Quake or Doom in there, and they could play without the end user seeing any change in there. So runC is really interesting. Another, I was talking about plumbing. One of the efforts that we announced at DockerCon last June is that we're going to take a lot of the plumbing that Docker is based on and make them as separate projects. And so runC was the first one. Notary is the second one. It's a tool for security, for determining that the image that you're running is really the one that you intended to run. And it's based on an article called Tough, the update framework. That's kind of cutting-edge security for distributing operating system images. So in terms of plumbing, Notary and runC, there will be more. And the move in Docker right now is to split the engine into these little tools and then reassemble the engine based on them. So for Docker 1.10, one of the goals is to have running containers based on runC in there. So that's the next release. I think next week there's a release of 1.9, Docker 1.9. The RC2 is already available, so you can play with it. The new stuff that's in there is network management. So we have a network, a Docker network top-level command. There's also a Docker volume top-level command. These were available in Docker experimental. Now they're in the main branch. So it supports multi-host networking out of the box, and I'm going to demo that to you. And then volume management, both of them are extensible through plugins. Node discovery is now built in. So you have the new options, cluster store and cluster advertise, that will let your Docker host discover each other. And then there are a bunch of refactoring in the builder, some new log drivers. And one of the, for those of you who are interested in security, one of the big things that arrived, I think, thanks to IBM, it's in experimental, it's not in 1.9 per se, is user namespaces, the first phase of user namespaces exposed in Docker. So the roadmap for Docker Engine in terms of runtime, as I told you, it's a runC integration. There are some enhancements in distribution, stabilizing networking, and better support for IPv6. And then stabilizing and including user namespaces. So let's talk about orchestration. So let's talk about Swarm. I told you it's an engine that you, just a process that you put in front of your cluster. So as a user, you just interact with Swarm as with a single Docker engine, but you can use constraints that Swarm will use for scheduling your engine on one or the other node. You can use labels for that as well. And then the Swarm scheduler allows you to do constraints based on memory, CPU, and networking. You can apply filters, so it filters containers based on the constraints, and then it uses a strategy, and the strategy is pluggable. So there you can say, I want to do bin pack, where I want all my containers on as little machines as I can, or I can use spread to spread them equally across the cluster. And you're using constraints and affinities for tuning that. So Swarm is fully integrated with Machine and Compose, which means you can deploy a Swarm cluster using Docker Machine, and then you can use Docker Compose targeting a Swarm instance, and that's what I'll show you. That's the demo I was just finishing doing. And there's a Mesos integration. So the Mesos integration, Mesos has a two-level scheduling engine where you have the Mesos master. And if you're building a framework in Mesos, the master is going to give your framework some offers, and then your framework can decide to accept them or refuse them. So the most famous framework is Marathon. There's Spark. There's one for Hadoop. What we've done is that we worked with Mesosphere to create a Swarm Mesos framework that just takes some offers from the Mesos master and schedule your containers there. So you, the user, you're interacting with Swarm the same way as usual. You just specify some constraints, and then the Swarm framework is going to use Mesos offers from the master to schedule your containers in the Mesos cluster. So what's new in Swarm? There's lots of news in Swarm for 1.0. So the first one is that Swarm is going 1.0. So that means it's ready for production. So we've been focusing on stability, scalability, and performance. And the big thing is the integration with the new networking feature. So now we have network overlays that are cross-host on Docker itself, and it's integrated with Swarm as well. So that makes Swarm plus Docker plus the networking aspect a pretty good platform for orchestrating container. So in terms of production readiness, when in the past 6 months I've been talking about Swarm a lot, and people were asking me who's running that in production, does it scale to more than 100 nodes and things like that. So they made lots of enhancement to the scheduler in this release, and the result of it is that last week they ran some scalability test on Amazon on more than 1,000 nodes, and it works really well. So what that means, and actually they maxed out their EC2 provisioning limit. So they asked Amazon to bump it up to 10,000 to be able to do some testing in there. I think they're doing that this week. And the 99th percentile latency, which is the important thing, is still pretty good. So which means it scales to 1,000 of nodes, but running containers on 1,000 node is not an issue in terms of performance. Same thing for the scheduling duration. So the stress tests are new. The platform integration means that you can do multi-host networking with Swarm now. And then interlock is used for load balancing. So in terms of roadmap for Swarm, the big thing is that Swarm and Engine are going to come closer. So right now they've been doing some refactoring at the API level to have a common API layer. But in the future, the goal is to have Swarm and Engine becoming the same product. And considering Engine as a single node Swarm cluster. So now let's talk about Mesos. So Mesos is an open source Apache project. It's been, I think it's been designed by Twitter initially. It's been used in production in lots of different places, including Netflix. And it's very, it's rock solid, it's well known. And it has a bunch of frameworks. So Mesos does the resource management, and then you can provide your own scheduling in what they call a Mesos framework. And so that's what I was describing before. You have the Mesos master who's managing resources, and then it provides offers to your scheduler, and your scheduler can do what it wants there. So with Mesos, there are lots of people using Mesos. For example, Microsoft Container Service is based on Apache Mesos. And Swarm now, as I told you, is integrated with Mesos. Kubernetes is a different beast. So Kubernetes adds a bunch of new higher level abstractions on top of Docker containers. So Kubernetes has this notion of pod where you're bringing together several containers together, and that pod that has several containers together that can share local files that have the same volume, they have the same networking, so they're provisioned as they have a pod as a single IP address in the system. So it's a nice abstraction for building services where you have more than one service that you want to schedule together. And so the pod is the unit of replication in Kubernetes. In addition to pods, they have this notion of replication controller. So once you have created a pod and put it in the system, then you create a replication controller and you say, I want to have always 5 of these running. And then you can assign tags to them. And then on top of that, based on these tags that you have assigned to your pods, you have the notion of service. And so a service is essentially a query on some labels that will return you a set of pods that Kubernetes is going to do load balancing on. So Kubernetes provides its own load balancing, and it's very dynamic, being based on labels and pods. Cloud Foundry and Bluemix. So Cloud Foundry is a big platform as a service system. You see the whole diagram here. It has a router, a cloud controller. There's a huge system in there. It's based on build packs. The notion in Cloud Foundry is that you focus on your code, adhering to certain build packs, like the Java build pack or Ruby. And then operators of the system manage all the VMs of your Cloud Foundry cluster using a system called Bosch. That's itself a distributed system. So it's a pretty complex system. But for developers, it's very easy to use. You focus on your code, and then you push it over there. Recently, they just realized once Docker became very popular, that developers didn't want to be limited to what was in build packs, and they wanted to add a bunch of stuff and run Docker services. And they said, okay, we have an orchestration engine within Cloud Foundry. Let's put it to use for orchestrating containers. So they have this new project called Diego. That's a subcomponent of Cloud Foundry. That's an orchestrator for containers. They're using a technology called Garden, so they have their own isolation technology called Garden for creating isolated processes. And the backend for Garden was initially based on LXC, I think. And recently they decided to move to runC. So they're going to use runC for running containers within Cloud Foundry. And they created that new project that's smaller than Cloud Foundry that's called Lattice, that just has the load balancer, the router, and the scheduling engine. So Lattice is kind of their entry into becoming a container orchestration engine. Bluemix took a different tack. They have an offering that's called Bluemix from IBM, and it's built on top of OpenStack. So at the bottom they have OpenStack, then they build Docker on top of that. They deploy Cloud Foundry, and they have a Docker service in addition to that. So that's Bluemix. And then you have the SaaS, the software as a service, fully managed orchestration services. All the big 3 cloud providers have one. So Amazon has ECS, Google has Google Container Engine that uses the same tools that Kubernetes does. And then Microsoft introduced last month Microsoft Azure Container Service that's built on top of Mesos. And then there's Tutum. So Tutum is an interesting system in there where they tackle everything from build to running your container to provisioning your clusters. And to provision your cluster, they tell you, okay, give me your Amazon credentials or your Azure credentials. You can provision machines in Azure or Amazon with them, and you can also bring your own hosts that are behind the firewall. And then they install Docker Engine, and they manage the Docker engines in there, and then you use the Tutum command line to provision your workloads on that. And they do the whole thing where they do CI, CD, as well as running your containers. So right now there's some effort internally at Docker to have Orca, which is the on-premise offering by Docker, and Tutum to converge. because they joined us last week. One interesting offering is Triton from Giant. So Giant is the ex-Solaris guys from Sun who created that company called Giant, where they said there were so many gems in Solaris for running clouds that we're going to create a cloud provider based on it, and that's Giant. And last year they introduced Triton, which is a Docker service. So you have essentially access to the whole Giant data center shown to you as a Docker endpoint. So in summary, Swarm is kind of Docker style, Docker orchestration. You can provision it with Docker machine. It's pretty easy to provision. It's easy to leverage your existing infrastructure with it. It's ready for production. It runs on more than 1,000 nodes, and stay tuned for the latest load testing on that. Mesos, Twitter style, it's aligned with Swarm. It's pretty mature, and it's running in lots of different places. But it works very well with Swarm. Fleet is one that I haven't talked about from CoreOS. So CoreOS now, they used to have Fleet, which was pretty low level and very simple. Now they have a commercial offering on top of that has Kubernetes on top of it. So Kubernetes is pretty heavy duty. There are lots of concepts in there. In my personal tests, when I run Kubernetes, it runs really well on Google Compute Engine, and it's simple to install there. If you try to install it on Amazon or Azure, it gets more hairy. Like, not all the features are supported, and you can feel that this is really geared towards Google infrastructure. DIS is an interesting one that I haven't had time to talk about as well. It's like a Heroku-style workflow on top of Docker, and it's based on Kubernetes. It used to be based on Fleet, and now it's on Kubernetes. Cloud Foundry, I talked about it, and then you have others like Giant and Tutu. Okay, let's go into a demo. So for the demo, because it's JavaOne, I just took a sample application. So that's a Spring. Let me see if I can show you. Oh, yeah. That's a Spring Boot application that my friend Josh Long wrote. He's from Pivotal. And so he wrote this simple Spring Boot application that has REST services, that has a very nice JavaScript-based UI, and that's using MongoDB with MongoFS as a backend. And what it's doing is that you upload an image, and it's adding a bunch of fun things on top of the image in the backend, and stores it in MongoFS and serves it from there. So that's a simple application with a few services. And let's take a look at how to build it with Docker. So I actually liked his application, so I went to his GitHub repo, and I sent him a pull request to say how to build it. So it's a very simple Docker file. I inherit from Java 8 here. Yeah, so I inherit from the Java 8 image. I do my build locally with Maven package. I expose port 8080, and then what I do is that I copy the jar that I have built with Maven into a location inside of the container. And then I just run java-d server, and I pass the port. I pass the MongoDB URI as an environment variable. So when I'm going to orchestrate that, I need to pass the right URI to it. And then it's a java-jar Spring Doggy. Now, when you want to run it, before Docker, you would need to run it locally, having Java install, having STS, doing my build, and then I would need to install MongoDB and configure it and all that. Now I just don't need to do any of that. I just do a compose file where I have a web app and a Mongo app here, a web service and a Mongo service. The web service is the image that I just built. And here I'm mapping port 8080 to 8080. I create a link. So that's the way that Docker was using before networking to link different containers together. So here I have a Mongo service with the links directive here, what I'm doing is that I'm telling Docker Compose to create a link between the web container and the Mongo container. That's called Mongo, which means that now from the web container, if I ping Mongo, I will ping the right container on the other side. And then I pass as an environment variable MongoDB URI with MongoDB, and Mongo, it's my host name from the link in there. The problem with that approach is that it doesn't work across a cluster, which means you were reduced in the up to Docker 1.9. When you were running that Compose file, Compose needed to schedule both my Spring application and my Mongo database on the same host. And that's the thing that we fixed with, and the way it worked is that it used to go into etc host and mess with the host in there. With Mongo 1.9 and networking, you don't need to do that anymore. So you don't use links anymore. You use the Docker network command to create networks. And then you assign your containers to a network and you give them a name. And then your containers will be available at that name. And it's integrated with Compose. So for the demo, I'm going to show you, I had to use, and I'm going to give you the GitHub URL for creating the cluster. I had to use Docker 1.9 RC2, and I use a boot to Docker image for creating my VM for that, boot to Docker ISO for provisioning my image using a Docker machine. I had to use Docker Compose Experimental 0.5 or something like the latest. So let me show you what that looks like. So let me show you how I can create, actually I have that in there. Okay, so that's my Azure one. This is that's it. So that's the, oh no, that's my Azure cluster. This one is my Swarm cluster. So let me make that bigger and show it to you in the details. Okay, so what I've done just before coming here is that, so here I set up a local URL. So I have downloaded boot to Docker 1.9 RC2 on my local machine to make it faster. Then I set that boot to Docker URL to this. And then I use Docker machine. So I create a machine using the VirtualBox driver. So it's going to create a VM locally. And I tell it, please use that ISO for the VM. And that ISO contains Docker 1.9 RC2. And you call that Swarm console. So this is going to be the VM where I deploy my console service. So I'm going to use console for discovery in there. When you're running a Swarm cluster, both for the cluster nodes to discover each other, as well as for the networking service, if you want to use overlay networking, you need to specify a discovery service when you start your daemons. So that's what you see. Yeah, actually, that's what you see there in the engine opt. In the engine opt, I say cluster store equals console and the IP address of the console service and the host. So that's used for both service discovery and networking. So I create my console. Then I'm using, so here I'm using Docker 1.9 RC1. And I'm running on the console node. I'm just running the Progrium console Docker image as a server on port 85100. After I've done that, I can do a Docker machine create with a VirtualBox driver with the same image, and there I'm using the Swarm option. So you can see I'm saying -- Swarm, which means I want a Swarm integration in there. The Swarm image that I'm running is 1.00 RC2, so that's really the latest. and I want that node to run as a Swarm master. So that means Docker machine is going to install Swarm and run it as a master on that machine. I pass the Swarm discovery URL, so all these parameters passed to that flag, they're going to be used in, when launching Swarm. And then I can pass some engine options when I create my machine. And here, as an engine option, I'm telling the engine, when you're running in there, use that console URL as a cluster discovery. And actually, I'm just going to show you what that looks like. So if I go there, so if I do a curl on that console URL, and I'm looking at all the key values, and I'm pretty printing it in with a Python tool. Boop, boop, boop. Wow, there's a bunch of stuff in there. And it's pretty slow. Is it the same? Maybe it's not the same one, sorry. Oops. Let me Docker machine ls. So I'm showing you all the Docker machines I have running on that system. You can see I have 2 Swarm clusters. So this one is a regular Swarm cluster that runs locally with static IPs. And the other one is the one that I provision with a script. And the console is on port is on IP address 113. So let me go there. Okay, so you see here I have a bunch of metadata in console about the various networks that have been created on my machine, as well as the machines in the cluster itself and the different daemons. So both Swarm and Docker are using that console instance to do bookkeeping for the various stuff that are running there. So I create that first machine, that's my master. Then I create a second VM that's just a Swarm node. So here you have a Swarm node. It has the same discovery URL. It's called SWL demo 1. And then so that's the piece that that needs to be fixed in 1.9 final. So there are still a few init things to change in the boot to Docker profile for starting Docker. So that these 2 lines will just disappear. And then once I've done that, I can do an eval of Docker machine of -- swarm to demo 0. What that will do is that it will set my Docker client it will set my Docker environment variables to talk to that cluster. So when I do that, if I do env grep docker, so here you can see that I'm talking to the right machine on port 3376, and that's my Swarm. That's my Swarm master. So now I'm going to use the Docker 19 RC1 and to say Docker info. And once I do Docker info, I can here I'm talking to a Swarm master. So here I can see lots of details about the master. It has 2 nodes. So that cluster has 2 nodes. If it had 100, I would see 100 in there. I can see the CPU and the memory for each of these machines, the various labels that it's been launched with. And if I do a Docker 1.9 RC1 PS, I can see all the containers that are running on that cluster. And see here you can see that I have 2 containers. I have a Mongo image that's running on Swarm demo 1. And I have a Spring Doggy image on Swarm demo 1 as well. And I have an Nginx on Swarm demo 2. Okay, so after I've done that, I can create a network. So let's actually create a new one. So I can say Docker network create. There I say -d overlay. So it's going to create an overlay network. And I'm going to call it JavaOne. Okay. So now when I do a Docker network ls, I can see that I have my new JavaOne overlay network. And I can see all the other networks that have been created on that machine. So that allows me to create different networks for different applications. Applications that are on the same network can talk together, but applications on different networks don't see each other. So it gives you one more level of isolation with Docker networking. Okay, and then I can try it out. So here I'm going to start a simple example. So I'm going to run a container named WebJ1. I'm going to put it on the JavaOne network. And I want it, I pass a constraint where I say I want it on the Swarm Demo 1 machine. And I'm going to call it Nginx. Boom. It's provision. If I do RC1 logs, I can see that, yeah, actually I don't see much. And now I'm just going to run another command where, so here I'm going to run -it, which means it's going to launch that in a terminal. It's going to destroy the container right after that. I'm going to run that into the JavaOne network. I want to run that on Swarm Demo 1 this time. I run busybox and I do a wget of the container that I just triggered before that. So how did I call it? WebJ1. So here so I'm going to trigger to start a new container on the other machine. So I ask Swarm to schedule it on the other machine. And then in that container, I'm pinging or I'm curling the web page that's hosted by Nginx, just using the host name that I have defined in there. All right, that works. Okay, so that one works. And now the all-in-one demo, that's what you see in there. Maybe I'll stop it later, but I just wanted to show you how that worked before. What I've done in there is that I modified my compose file. So, okay, so this is the initial compose file. That's Docker 1.8 type compose file where you say, I'm going to run Spring Doggy. I link it to Mongo. I have another container with Mongo. That can run only on one host. So because in Swarm it wasn't integrated. Compose, Swarm, and Docker were not integrated, and the networking wasn't in there. Now, with networking, it looks something like that, where I have my web container. I don't need to specify any link. I have my environment variable, and I have my Mongo image. This time, I'm naming my Mongo image to the name that, and actually, I haven't digged into the Compose documentation yet. But here, I'm putting it to the name of the container that Compose is going to create when I do a Docker Compose up for this. And when I do that, I run it with a special flag that's experimental a special flag that's experimental in Docker Compose that you can see there. I run it. I do a Docker Compose, so I use 1.5, which is really the experimental version of Compose. -x networking, so that tells Compose this swarm that you're talking to, it's using networking. And then I use my, with networking YAML that I have created in there. And you can see it's creating Mongo 1 and then Web 1. And when I go at that URL, which is where, so that's my demo 1, that's my Swarm Demo 1 IP address. When I go in there, I have my Spring application that's working. So at least we can see that the initial app is running. And when I go to desktop, I can take one of these. I'm going to just take Scott Guthrie's picture in there, and I drop it in there. And if I go there, boom. So what it's been doing there is that it took the image, stored it in MongoFS, modified it, stored it in MongoFS, and serving it to me from MongoFS, which is on another host. So that's kind of in a summary what Docker orchestration with the new networking stuff lets you do. There's a lot more things that you can do with it, like creating different networks for different applications that I haven't shown yet. But one of the things that I wanted to really convey here is that now Compose, Swarm, and Machine are fully integrated together, and that they together they become a really decent orchestration system. All right, so I hope that gave you a desire to write the whale and start your first container today. If you go to that last URL, Dave Tucker Docker Network Demos, you'll see the script that I was talking about, and I'll probably post more details about that demo on my GitHub repo, github/Chanezon. Later today. Later today. Oh, sorry, I'm just going to keep that for if you want to take a picture of that. Yeah, so that's kind of really cutting edge. If you try all that in 2 weeks, it should just work out of the box. Famous last words, I know. Okay, thank you very much. And I think I ran a little bit out of time, so I'll stay out there for Q&A. Thank you.
Okay, that's more sound than I expected. All right. So probably should get going since we have an hour and lots to discuss. So my name is Mike Keith. This is Jason Haley. We work for Oracle. And this talk kind of came from us starting something entirely new. We didn't really know anything a couple of years ago about the mobile space. We're both server-side developers and are sort of very strong on server-side architecture. And then we kind of ended up on this new project about mobile cloud stuff. And we didn't really know much about mobility. We knew about the cloud. We've been doing some work there, but as far as a mobile cloud platform, we didn't. So we did a lot of investigation. We did some homework, looked around an awful lot, read a lot, and finally kind of got a grasp of the landscape and where things were going. And then we started working on a product at Oracle that is called the Mobile Cloud Service. And the result of all the things that we learned, in general, we thought we could kind of abstract that out and provide an overview to people about where mobile server-side is going in general. So that's what this talk is. It's about mobile cloud service for the enterprise. This is not about applications. How many people here are mobile developers, people that write apps for the mobile device? Okay, so there's just a few of you. Can we close the door and lock these guys in, because this may not be very interesting for you. We're essentially going to be talking about the server side, because that's all we know. But it does become relevant to the client side, to the mobile device, because this is the new world of developing mobile applications. This is how things will happen in the future for enterprise mobile apps. With that in mind, we'll move along and talk about mobile devices for just a second. I remember a time when I didn't want to carry more than one device on me. I swore that I would buy a smartphone when it was really smart, and when it could do everything that I wanted it to do, and that would be my one device. I didn't buy into the fact that I needed one device to do one thing and another to do another thing. But as it turned out, it becomes really hard to run an IDE on a phone. There's just lots of things you don't want to do on certain types of devices. So it then became the norm for people to come into a conference room and open up their laptop, lay down their tablet, put their phone down beside it, and who knows what else, their watch and their glasses, or our devices are starting to proliferate. And devices have their own purpose. And we expect to buy a device that's fit for that purpose. And we use a device in a given context. So devices are not actually getting fewer to do more things, they're getting more and more specialized. Now, and I was quite surprised when I saw, the Fitbit or the whatever your favorite brand name is that tracks your life in a bracelet. That's sort of very special, and yet you're wearing a whole device for that. Wearables are becoming more and more popular. So the ubiquity of mobile devices is probably not under question, and we're not going to get a lot of questions about that one. However, I think the philosophy that each device does mean something specific in a specific context and is meaningful for a specific type of application is probably not well understood by many people. But what we want at the enterprise is to be able to develop an application that is multi-channel, meaning that we can provide the application logic, not have to rewrite it for every single channel you're developing it for, but that each of those channels has and supports that application in a way that makes sense for that device, that is contextually sound and appropriate. And that's where the challenges of enterprise applications and mobile devices come in. You have all of your data sitting in these back ends. If you talk to an insurance company or some of these companies with lots and lots of resources and people and money and data, it's all sitting in a few places, very, very protected, guarded places with locked doors and cooling and certain gray-haired people with beards who can access it. Well, this data is just the beginning. You have to integrate with that data from all of your applications. And it turns out that more people are worried about one thing than any other, and that one thing is security. So they keep their data locked up, and they're used to knowing that the data is locked up. If you go to a mobile device and the data is now wandering around wherever the guy who's holding it is wandering around, then that makes IT people a little bit nervous. They don't like the fact that the data is out of their control. And that lends to security problems. And they're right. I've seen people at airport security walk off and leave their laptop or their phone and just forget it there. That's precious data they've left there, and that's made it vulnerable. So there's security, and then there's the problem of developing the client side. With every device comes some native OS or proprietary APIs, and those APIs may require, if you decide to go native, may require a whole bunch of development. And so the questions, all of these questions are part of the problem that IT people have to answer when they say we're developing a mobile strategy. And then there are the process problems. I don't know how many people work for bigger companies that have been around for a while and that have a lot of processes in place, but I work for Oracle, and Oracle's been around a long time. It has a lot of processes in place, and changing those processes has not been easy. It's never easy in a big corporation to change. And when Oracle changed to suddenly become a cloud company, that took a lot of getting used to. We had to go from releasing a product potentially every 1 to 2 years to now our cloud product ships an update or an upgrade of sort of new features every quarter and a patch release every 2 to 4 weeks. And this was a huge change for us. And this is just an example of process changes that exist out there and that make things difficult for mobile applications. And then, of course, everybody wants it done yesterday, and we know that there's pressure from all sides on IT staff. So Jason's going to show us some of the other problems in a more concrete way.
Yeah, so I mean, you talk about applications, and you know, it's not that big a deal. You know, you want to get all this stuff in there. This is the type of app that I'm sure a lot of you have seen in the past. You know, fairly straightforward human resources application. You've got a profile photo, some basic employee information, how long they've been with the company, information from their last evaluation, you know, their office location, that sort of thing. You know, that's manageable. You know, I can do that. I can write that type of application. But just start to split it up, and you realize, well, there's actually a lot of different pieces of information in this. To break it down again, there's a lot of information, and it's a lot of information coming from a lot of different places. So in this case, the profile photo might be coming out of cloud storage somewhere. Your basic human resources information could be from your on-premise HRM system. Your social network information could, you know, it's coming out of the web. You've got your talent information, so your last set of eval reports, you know, how's this employee doing? That could be on some cloud talent management application. You got your Google Maps pulling out your location, all that sort of stuff. There's a lot of information in there. So all of a sudden, this simple HR app got pretty complicated pretty fast. Are you going to leave this up to your application developer to try and figure it all out? If they're writing Android apps and iOS apps, so they're going to have to worry about writing push notifications to the two different types of systems. What about analytics? How do you capture analytics if everything's being written on the mobile device? Do you store your metrics on the device? Do you call up all the people using your app and say, can I download all these metrics now to do some analysis? You can't do that. The client guy is already worrying about what dev tools he's going to be using, so you don't want to confuse the topic even more with that. And then the big problem is the integration. So we talked about a lot of those back-end systems where this data is coming from. It can be from all sorts of systems. They can be on-premise. They can be hosted in the cloud elsewhere. All sorts of different companies. The protocols, how you communicate with these is all going to be different. Securing them is going to be different. It's a really big challenge. And we're just talking about one simple human resources application. If you're working for a big company, you're going to have dozens and dozens of these applications. Are you going to do it all over again? Have each app developer learn how to integrate with SAP or with the Oracle database? Not likely. So we'll take a bit of a look now at the platform itself. So basically, So these are the problems that the app developer faces. That's where the platform comes into play. That's there to basically abstract a lot of those problems away, simplify the life of the application developer so that he doesn't have to worry about all these details. The platform should be doing that for you, and it'll provide that framework to allow you to write multiple applications shared with those using those reusable pieces that you've created. So we'll take another closer look at the platform now, start to drill down. But first we'll take a bit of another look at some of the different apps that you might be writing. So B2C and B2E, business to consumer versus business to employee. So when you're talking about the business to consumer, B2C, this is your typical Angry Birds app. You're trying to reach out to the masses. You can't really trust them because you have no idea who they are for the most part, and it's a large number of users. You have no control over the device. You don't know, again, if you're reaching out to as many customers as possible, they could be using iOS, they could be using Android. You don't know what version of the OS they're using. You don't know what configurations they have on their mobile device. You don't know what other applications they have. The sky's the limit. The permutations of things you might have to worry about can just grow and grow. And user profile. For the most part, these will be anonymous. You may have minimal profile information. Typically, if you do self-registration, when you first download the app, you might give them a little bit of information, but for the most part, these users are anonymous. You don't know anything about them. Contrast that to your B2E app. So these are for your enterprise applications for your employees. For the most part, you trust them. You hope you trust your employees. You're talking about a much smaller scale in terms of number of users. You have somewhat more control over the device itself. Your employees are still going to be bringing in their own device. A company like Oracle isn't going to buy mobile devices for 100,000 plus employees. So you're going to have a multitude of devices, but it is fair in that situation to add a few more constraints to the environment. You can require, before your employees use certain apps, that they're on a minimum OS version, that they have certain configurations enabled, and they may have certain other applications installed as well. The flip side to that is you've also got, because it's their own devices, you're also putting potentially critical corporate information on that, possibly sensitive data, but it's your employee's device. So that's where the MAM and MDM come into play. Those are mobile application management and mobile device management. I won't go into too much detail on those today, but in a nutshell, if that device ever gets compromised, if it's lost or stolen, you could potentially wipe it remotely. And even if it's not that, it allows you to make sure that the data on that device, any corporate information, is properly secured. And in this case, unlike the B2C apps, you typically have a good idea of who your users are. You trust them; they're your employees. They typically have identity stored within your local IDM system. And it's a bit of a hybrid to these types of apps. These are sort of the two extremes, and there's everything in the middle. If you look at a banking application, that's out there for the masses, large number of users, but you can typically trust them because you'll have information about them. They typically hold bank accounts at your bank, so there's a bit more profile information, things like that. We'll take a high-level look at the platform itself. So on the left, you've got your devices. So this is the application developer's realm. You're dealing with multiple OSs, multiple device types, native, et cetera, but that's completely decoupled from the platform itself. So your app developer is free to use whatever tools they want in whatever fashion they want. The only thing that they worry about is they're going to be talking to APIs hosted on your platform, and for the most part, those will be done over REST. At the top is sort of another layer, the management layer, where you do all your monitoring, administration, configuration. Again, we'll typically talk through REST, through these management APIs that your platform will expose for those types of operations. The thing that's interesting about this view is, depending on what your role is at the company, when you log into this console and start doing your work, you're going to typically get a different view. if you're this guy over here who's the application developer and you log in, the main thing you're interested in, and what you'll likely see, is a list of all the APIs that are available to you, what are the parameters that are required, and so on. If you're a system administrator and you log in, you'll be able to see how the system is performing, there have been any outages, things like that. Or again, if you're a business type, you can log in and look at various analytics reports to find out, how is my application being used? Is it being accepted? Is it being used more in North America or in Asia? On the right, these are the external systems. We alluded to those earlier. These basically put the enterprise in MBAS. That's where all the real critical information is going to be. You're hitting your external databases, your human resource systems. And the communication to those could be different. It could be SOAP, could be REST, different security protocols like we talked about before. All those pieces are essentially external to the system. The platform, the heart of it, is what's in the middle. Its job is to really simplify going from point A to point B. I said before, the app developer, he's just worrying about the APIs he needs to talk to. And the platform is what helps your server-side developers take care of all the hard work in talking to those back-end systems and providing all the APIs and all the utilities that your mobile application developer can use. I'll hand over to Mike again.
So API management. How many people here have heard of, or aware of this whole idea of API management? Okay, about half of you. So for the other half of you, to kind of fill you in on what's going on in the API management world, API management is about the ability to define a set of APIs through some API definition language, and there are a number of definition languages out there, and then be able to attach some kind of implementation to that API definition. And that implementation then is decoupled from the definition itself. The user, just like, if you all know Java, you know how Java works. You have an interface and you have a class that implements the interface, and the interface separates the client from the implementation. Makes sense. Well, that's exactly what an API manager does, but in a more generic way. API management tools tend to be more REST-oriented, and they allow you to define the API in terms of some RESTful spec, like RAML or some such thing, and then allow you to upload the implementation for that API, and that implementation may take any form. And the important thing is that your implementation is decoupled from the API that it implements. And then the API manager provides a way to secure your API. And that might take any number of forms as well, and we'll talk about how that works shortly. But the idea is that API managers provide a whole backbone for invoking and supporting hosting APIs. And that API catalog that Jason alluded to in the previous slide, where the mobile developer wants to look at all the APIs that they can invoke, this API catalog would be typically provided by the API manager. It can list all the APIs that it hosts. And of course, there has to be some runtime hosting that goes on there. You have to run the implementation somewhere, and this happens, again, on the API manager level. And then the last thing API managers do is they can monitor and allow you to find out what's going on to your APIs, who's calling them and how often, and how long those APIs are taking to be run, and so forth. So API management has come to be a very valuable thing, and is, I think, sort of blossoming right now. And there are a number of companies out there that are sort of strictly API managers, and making a pretty good business at it. Well, we're talking about mobile backend as a service. And mobile backend as a service, I think of that as actually API management plus. It starts with API management because it is about multi-channel, right? We determined that at the beginning of the presentation, that you may have all kinds of different devices and channels that you'll need to support. But you have a set of additional core services in an MBAS that provide mobile features for you. And this goes above and beyond what any API manager would do. These special services for mobile would be things like push notification or geolocation, these sorts of things, special analytics for mobile devices. These are features that the mobile backend as a service platform will provide on the server side, in addition to all the API management facilities that you're going to get. And then it has to provide some really nice mechanism to be able to connect to external data sources. Because remember, that's where all the money is. That's where the data is. That's where the real resource-rich stuff exists, at the sort of final data level. And these external data sources are what people really need to access in order to get their system going. This is where the data comes from. The analytics we've talked about already, they're pretty valuable. Again, the mobile events from mobile devices can get registered on the server side. You need the support on the server side for these types of analytics features and events. So MBAS takes the lead from, I would say, from API management and then carries it off into the mobile space and provides much more. Now we're going to dig right into the platform itself on a feature-by-feature level. The first thing on the this is similar to what Jason was showing. On the left, we see the devices that are accessing the cloud service. And these devices are essentially making REST calls to APIs that exist on the platform. So the platform API management layer is sitting there in the mobile cloud service, and these guys are invoking that through some REST call. And it usually helps if there is some sort of SDK there. It doesn't need to be there, but if the mobile cloud service provides some kind of SDK to run on the particular platform that you're running on, then it makes for much easier invocations. It will take care of some of the security wrapping, creating tokens for you, making REST invocations for you. Anything that might take a little bit of work can be handled by some SDK layer that sits there. And then on the other side, on the far right, are the external apps and systems. And those external apps and systems we talked about as being external data, but if you look a little more closely, they could come from any of three big categories. The first is another cloud service. The cloud services themselves are fairly broad and specialized, and so you might, from this cloud service, invoke other cloud services. It's more and more common to do that. Each service provides its own special benefits. And then we have the on-premise packaged applications. And these applications are typically quite protected by the customer. They may have a lot of special types of data there. And then you have custom applications that might have very custom protocols involved there. And so you might have data that you want to access in each of those. And as mentioned already, REST and SOAP are probably the more common protocols that you use to get to them. And one of the problems that we found as we were investigating this problem is the idea that some of these backends actually require kind of a session interface. They require statefulness on the part of the caller. And if we're coming into a mobile cloud platform and there are RESTful calls going all the way through the connector, then you don't really have a great solution to call these stateful session-based backends. And so this is a problem that the mobile cloud service has to deal with and figure out some way to do. And I think there's probably different solutions for that. One is that you store some kind of state as some sort of identifier that gets put in the storage service, and then the client device just stores that identifier and passes that in as kind of a session ID, as it were, and then its own code goes and looks up that state in the storage service, then goes off and calls a connector with that state. That's one way. There are others as well, but that does it is a little problematic when it's sort of an impedance mismatch when you have a RESTful system speaking to stateful systems in the back end. So it's not unique to this cloud platform by any stretch. But the connectors themselves need to be configurable. They need to be configurable so that you can be flexible in terms of how you define and connect to these different kinds of back-end data sources.
So next thing we'll look at, the next feature we'll look at is push notifications. So with push notifications, we're talking about mass messaging, mass marketing, if you will, to all the users of your application. You want your platform to provide you with useful notification APIs that really gloss over or abstract away the details of dealing with all the different protocols that exist. Apple has their own APNS, Google has GCM, Windows has their own protocol. You don't want your You don't want your application developer to worry about the details of each of these when he's writing his client app, or even your server-side developer when he's writing his app. You don't want him to have to worry about the details of talking to each individual service that's out there. Your platform should provide a generic API for you that allows you to do it, and it will take care of the nitty-gritty details underneath the covers. When you're sending out these notifications, your platform in these APIs, it should allow for different ways of getting that information out there, different filters. Do you want to send your notification out to every single user of your application? Basically some sort of notice to say, hey, you know, there's a new version out there, it's got some really cool features, you might want to check it out. You might also want to filter them out based on role. We looked at that HR application earlier. If you're a manager, HR might want to send a notice out to all managers using this application to remind them, hey, your employee evaluations are due next week. You better get on it. Another way is location. You can make the use of the contextual, the locality information of your device, its GPS, to send out notifications to particular users in a particular location. So if they're using your an application from your favorite big box store, and that store is having a flash sale, you might want to push notification to everyone in a particular store and say, hey, you know, we got a clearance sale on socks in aisle 5. You want to go check that out? So the API that the platform provides should allow you to do those types of things. And there's still problems with push notifications. I mean, there's no standard for them. Like we saw before, Apple's got their own, Google's got their own. There's no standards on how these are done. There's no quality of service standards. How do you deal with timeouts, delivery interruptions, those types of things? That is the kind of stuff you want out of your platform. It should handle those types of issues. It should handle the retries to the servers just to make sure that those messages get through when you want them to get through. It shouldn't be up to your app developer to worry about. Next big thing is analytics. So you want to find stuff out. So you've got your application out there. Great, you built it. Is anyone using it? How are they using it? You know, or could they possibly use it in different ways, or are they using it in ways other than you expected them to? Well, the first thing you need to do before you can start analyzing is you need data to analyze. So those are the metrics or the events that you might have generated in the system. And there's different types of events. And your platform should provide APIs that allow you to generate these different types. You might want to generate custom events from the client-side device. So this is one of those occasions where, you know what, your app developer actually does want to store information about certain things that happen. You know, if someone hit the big red button on page 5 of the application, they might want to trigger an event so that gets registered in the platform so that data can be analyzed after. Custom code. We'll talk about this a little bit more later, but this is essentially the business logic that your server-side developer would be writing in the platform itself. He can also generate custom events that are specific to your application, to your business area. And through all that, the platform itself is going to constantly be generating events as well. When our API is called? What time was the API call? When did the request come in? Any outages that might happen? Every time one of those things happen, the platform's gathering all sorts of data that you can use later on to analyze. The important thing about these events too is you're not just triggering that something happened. You're collecting a whole bunch of contextual information at the same time. You're capturing where was that event triggered? Where's the device? Where's the person who triggered it? You'll capture that type of stuff. What time did it happen? If you have profile information, you might capture, you know, are they male, female, age, that type of information. Mike alluded to at the beginning about all the different devices that exist out there. You know, you got your smartphones, tablets, smartwatches. As more and more devices come out, you're also going to want to capture more and more contextual information along with some of these events. In the case of a Fitbit or your favorite health device, you might be able to capture the heart rate. So you trigger an event. You know, every time they run a mile, you might want to trigger an event and capture their heart rate at the same time if you've got a monitor built into it. And you can use that information later to perform analytics. So now that you've got the data, you want to analyze it. And there's two broad categories of analytics. There's sort of the application business level analytics. You're looking at, I mentioned before, is the usage of my application mainly in North America versus Europe? Is it the male population that's using this app more than the female population? Are they using Android? Are they using Apple? Those types of things. And you've also got your system level analytics that is more for your system administrator. He might want to look at the throughput. He can see how many calls, how many requests are coming into the system per minute, how many outages there were, all those types of things. Here's a couple of slides. Hopefully it's clear enough. Just a couple of examples of, a couple of reports you might get. So this is showing how many active users there are by region. So it's using the locality, the contextual information of the device to say, where are the users who are using my application? Well, in this case, you can see it's a strongly weighed towards the U.S. So that's where the bulk of your customer base resides, and some in Europe as well. And just to say that one, so this sort of here is kind of an example of not so much system level, but these are the types of analytics that you're probably going to be getting for free. So your platform is registering every request that comes in, the users, et cetera, and that contextual information, and you should be able to get this type of information for every single application that you write. But you can also write your own custom events like we talked about before, and this is a bit of an example here. There's this fix-it-fast application that we often talk about. It has to do with you've got problems with your appliances and you call out a technician, this fictional application. Well, the writers of this application decided to generate events about every time a request order or every time a technician is dispatched. The customer logs an entry saying, I've got a problem. I need someone to come out. Here's my service call. They can trigger events for that. They can trigger events when the order was accepted and when it's been completed. So this is completely 100% specific to your business case, but you can write very powerful events and then analytic reports to look it over afterwards. And the business guys really love this stuff because then they can find out who is their market, how are they using things. You can see with APIs, if you look at your application, it's broken up by APIs. You can see which APIs are being used versus which ones aren't. If you see a whole slew of APIs not being used, it might be an indication that your app isn't written very well. Users might not be able to navigate easily to that page, and that's why they're not hitting it. Or they might just not be interested in that part of your application. But at least this way and you can start to make decisions based on concrete information. User management. Mike, you're up.
So this kind of falls under the security category. User management just is a term that we use to define the ability to manage users and what users can do from within the system. And you can typically do this in one of two ways. The first is declarative. Declarative just means that you define, when you define the API, what kinds of users can access that API. And that's normally done through the definition of roles. This kind of follows on from JavaE-based security, where you define roles and then you define which roles are required for a given API. And then once you've defined that, then the user that calls or invokes that API must have that role assigned to them. However, how many applications and customers do you know that are just happy with the features they have? Very few. They all want to do things themselves, to be able to customize stuff. And so that's where you need typically some programmatic way of saying, can this user access this or not? And it might be defined or decided based on some parameterization of some kind, or whatever it is that is domain specific that the user or customer wants to define. So the programmatic way is just that the custom code, as it gets invoked, has some API that it invokes to determine what this user is, which roles it has, what it's authorized to do, and then it can programmatically decide whether to allow that invoker on through into the system and carry on, or to throw it back out again. Earlier on, it was discussed this separation between the two different types of applications. There was the business to consumer, or B2C, in which you had all these untrusted clients all using your application. And when you think about that, how does an untrusted client use the app and access server-side logic? What user are they using? So there has to be some notion of self-registration, or some way to say, I'm a new user, let me in, I'm somebody. And then that somebody gets remembered somewhere, but there's not really any more information than that. It's just the somebody. And we call that essentially anonymous access. You're a somebody, you're allowed in, but you probably can't do very much. And this anonymous access support needs to be explicitly supported in the mobile cloud platform on the server. Okay, a couple of things that appeared in the middle of the cloud just now. And the first is object storage, and the second was database storage. So there needs to be some kind of supported storage for these applications to be able to store their data for whatever reason. Normally they're going to be reading their data in from the enterprise, out through some from some connector, but you may or may not be writing out to that through that connector. You might just be writing to some database that's accessible to the cloud, and that database might be in one of those two forms, either an object storage system or a relational database system. The object storage service, we see these all over. This is nothing different from what you see around us. Most clouds have some sort of object storage service. They're unstructured, they're typically just blobs of data, and quite often key value stores. And there are lots of them that are slightly different out there, but mostly very much the same. They allow sometimes name spacing to separate where things are being stored through some hierarchical space. You can definitely add attributes to the data. And normally the most common type of data that's being stored is a blob of JSON. And so if you have a really good storage service, then you provide additional features to query on the JSON or do lookups based on that. You have JSON objects that are read-write specific to just JSON, and that kind of helps you. It provides a little more convenience using the storage service. And finally, the other thing about storage services is that they're easier to use if they have some kind of collection of things or container-based API. And that allows you to categorize the pieces of data that you're storing and to find them a little more easy than if you didn't have some sort of container. It provides some sort of basic querying, if you will, that you don't normally have with structured stores. And you can do that a number of different ways if you don't have containers, but we find that most of them have some level of collection or container that you put these things in. The relational store, well, it's not really much different from any other relational store. It's just accessible from the mobile cloud service. It might be some other cloud service as a database cloud service, or it might be something local to within the cloud service itself and hosted. At Oracle, we chose to actually supply both, where you can define some data internally within the mobile cloud service, or you can access some remote mobile cloud service, which is a database service. But regardless, you, as a tenant, you need to be able to control that database and have some management capabilities. And that allows you to create schemas or perhaps modify the tables, but keep that restricted to the code itself as opposed to coming in from client devices. One thing you don't want to have happen is a client device coming in and deleting a table or changing the table structure on you or the schema or something of that nature. So you kind of lock it down to being local to the server normally, and that provides the security that most people really want out of a database.
Right, so custom code is the next one. It shows up somewhere inside the cloud here. Oh, there it is, right down the bottom right. Custom code is where you get to add your own personality, I guess, to the platform. We've been talking a lot so far about the things that the platform provides for you out of the box. So using the API management layer, when you go into it, you'll see a list of APIs that provide the analytics APIs, the event generation, object storage, all that type of stuff. Custom code is where you get to create your own APIs and add to that asset catalog. This is where you get a chance to build reusable chunks of business logic, register them, and have them available for use by your application developers in whatever application that they write. So I mean, really, it becomes just another service. It's able to access any other service in the system, typically. The reason for that is the business logic is also where you're going to start aggregating information from all these services. we looked at earlier at the connectors, the back-end systems. You know, maybe talking to SAP, Talio, whatever else. These are complicated systems returning a lot of different data. You don't want to send all that to your client device. It's an awful lot of data using up a lot of bandwidth, and it's just way too complicated. It's more complicated than you want your app developer to have to worry about. So here's where you write your custom code. You insert that business logic, and you use it to call out to those back-end systems. It'll collect data from multiple systems, aggregate the data, shape it, transform it in a way that's suitable for consumption by your application device. You also want to support multiple languages, or potentially support multiple languages in your platform. JavaScript seems to be the predominant language of choice right now for mobile development. Nothing saying you can't use Java. Have that in your platform. Ruby, anything else. You're almost getting a mini PaaS at that point. You have this mini code repository or code engine to, you know, depend on what's supported. You write your code, you upload it to the system, and then you have access to it. Where you want to be careful with custom code is, so up until now, we've been talking about what the platform does, what the platform provides. You as the platform provider sort of trust yourself, especially when you're talking about a cloud-hosted service, you trust yourself to write safe code. But as soon as you allow your client to write custom code and inject that into your system, you need to start worrying about it. So you really want to be able to sandbox that code and make sure they're not going to do anything malicious to your system. It's one thing if, you know, you're dealing with on-premise and, you know, you got a developer writing bad or malicious code. He's going to take down your own company. He's going to be in a whole lot of trouble, but at least he's only impacting where he works. When you're talking about a cloud system, when you allow them to write custom code and inject it into your system, you've got multiple tenants all using the same cloud service. You want to make darn sure that they're not going to be able to bring down your system, do anything malicious to access other customer data or anything of the sorts. So yeah, so you just make sure they don't have any kind of access to the underlying infrastructure or execution environment or anything like that. Geolocation. We talked about context that the various devices help provide. Geolocation is probably one of the most common ones. I think the one that everyone is most familiar with now. I think every smartphone has a GPS in it. You're going to want your platform to provide you APIs to help find out, well, where is that device? You know, the device that's currently invoking stuff, where is it right now? Where is it in relation to other devices or other locations, other points of interest that you might have related to your application? Like we talked about earlier, we want to send a push notification to everyone that's in your big box store. You need to know where that device is in relationship to that store's location. If they're nowhere near that store, there's no point in sending them a push notification. So that's where you make use of it here. And things like geolocation, locality, really starts to provide value add to just about any domain. I mean, we see it all the time and we take it for granted. If you do a search on your phone and you say, you know, find me a Chinese restaurant, you take for granted that it's going to use your location to find you Chinese restaurants in your area. Or you say, you know what, I need to go out and get some home renovation supplies. You know, till what time is the Home Depot open? You expect it to always return the closest Home Depot to you. You don't care about the Home Depot that's 500 miles away from you across the country. We just expect that. It should know, and that's where the locality comes into play, the geolocation. And you can, as you start mixing in geolocation with other contextual information, it can become more and more powerful. Start using temporality. You know, it'll look at the current time. When you say, you know, find me all the Italian restaurants, not only can it start giving you the local ones, it'll only tell you which ones are currently open. And as more and more devices are created, you know, we talked about the Fitbits and the stuff earlier, they're each going to add their own type of contextuality. And if you're writing an application, a mobile application that's built for those types of devices, you're going to want to make use of that specialized contextuality and build that into your app. So make your queries, the data that you return, smarter based on the information that the device itself is giving you. So PSR, oops, sorry. Might cover up the last bit.
Okay, PSR stands for performance, scalability, and reliability. These are things that you just expect out of a cloud service. You're not typically going to expect your cloud service to go down. And you also hope that as your mobile device scales out and you have more and more customers or employees or whatever's, that your service is also going to be scalable and support that increased demand. So that's obviously just going to be a basic must-have. The thing that just showed up there now is the integration with the development tools. When you do custom code development, then you're all used to using certain development tools. We generally use Git or Hudson, these kinds of state-of-the-art modern-day tools that we want to use when we do cloud development as well. And so you have to integrate with these tools so that you have the same sorts of life cycle that you are used to. It can't be hard to do development in the cloud. It must be sort of the same in the end, or easier if possible. And finally, it needs to be rock solid secure. We don't want data leaking out. We don't want it stored in some cases if it shouldn't be. If it's proprietary or confidential, it has to pass through the system and not yet leave any footprint, not get stored anywhere accidentally. The data can't be accessible when it shouldn't be. All these kinds of things. It all sort of goes around the mobile platform itself, supporting secure protocols and being able to provide the support for client custom code to be able to control who accesses what when. And all of these bits of security come together in the forms of security protocols. OAuth, I don't know, how many people here use OAuth or have heard of OAuth 2? Yeah, more than half of you. That's good. I mean, OAuth 2 has become very, very popular now, and as most of you now know, it's being used in many, many places. And this is, I think, a must-have as well when it comes to the client devices being able to get authorized or authenticated by the server. Talked about SSL a little bit. Essentially, you want your data to be protected going between the device and the mobile cloud platform. But you also, when it comes time to pushing that data or pulling that data from the connector into your back end, then you want that also to be protectable. And so you want to support SSL along those paths and be able to support certificates and things to be uploaded into the mobile cloud service. So all this management of certificates and keys and token propagation, if you have identity of a user, you want to propagate that identity all the way through to the back end from the mobile device. You don't want to have some other identity. You may have that specific user necessary as it gets through to the connector. So identity propagation also needs to be supported. These are all just sort of aspects of a secure system, and they all need to be there. And I believe that most of the enterprise MBASs support this kind of thing. So we just wanted to, I think we've got a little bit of time left for a demo. How does it look? About 10 minutes. So we've talked about in general purposes in MBAS, but since we've been working on one, we thought, well, if we're going to show them one, we may as well show them the one we built. So we do have that one. Let me see if I can find it. So this is the one that we have called the Oracle Cloud Service. That is a mobile cloud service. And we log into a domain. Oops. Can't actually see what I'm typing here, so I should probably be careful. So I'll just log into this mobile cloud service. This is kind of a development instance that we use, so that's my out in case anything goes wrong. This just kind of welcomes you out, and then the thing that we defined that represents the stuff that sits on the server side is what we call a mobile backend. Since these are all mobile backends as a service, it makes sense that we call them a mobile backend. So we go into mobile backends. I'll create a new one. Yikes. Okay, and I'll call it GeoMBE. So this is a mobile backend. I don't know how visible it is. It's kind of, let me push this out a little bit again. You can see that there's authentication keys. The authentication keys here provide, depending on which authentication mechanism you want to use, you might use OAuth from some devices. Some devices you may not want to use OAuth, in which case you would use just basic authentication. But the device then puts the client ID and the client secret. I'll show you the client secret if you promise not to tell anyone. There, that's the client secret for this mobile backend. So now you can all access my mobile backend. It doesn't do anything because I just created it, of course, but you can do it. So these are the things that the mobile application developer would include in their mobile app when they go and get an OAuth token. The next thing I want to do is I want to create some sort of connector. So not my computer, and I'm not used to the little, there we go. Actually, it's Jason's brand new computer too, so.
Don't crash it.
So I'm going to create a new connector. So a new REST connector. And my REST connector is going to be, it's going to be called GeoCon. And it's going to talk to www.geonames.com. It's kind of a geo service. It provides a web service. Let's create that. Whoops. Okay, so that's my connector. I need some rules. Let me push this back in. What do the rules give me? Well, to access this web service, I've defined a user. So anytime I want to call this connector, this backend, I want to pass that user in automatically. I don't want to have to be passing it in from the API. I want it to be automatically passed in. So the thing I'm going to do is pass in that. It has to be passed in as username. And the other thing this thing takes is a country code. Because the API that we're going to be using it for expects a country. And we're from Canada, so I'm going to use Canada as a country. And I'm going to save this. Security, this gives us a chance to choose what security policy, if there's any propagation that needs to happen across to the connector. We're not going to do anything in this case. And here's a cool thing. Now I want to test it. I want to test this connector right from my browser. So I need test credentials. The GeoMBE. I have to run it inside the context of an MBE. There. So now I've got some information there. What I can do as well is I can specify a specific URL in here. So here, whoops, caps lock is off. Let me see what that was called. called postal code lookup JSON. And I'm going to test this API with passing in postal code, my own postal code. And we'll see if it worked. Whoops, 404. I've messed up the URL here a little bit. Postal code lookup JSON. I see that I actually made a mistake here when I typed in the name of the URL. It's actually, instead of www, it's API. Resave that. Go back to test. So I just made a change to the connector, so the base URL and now we can go back to this again. What was it again? Look up. Postal code lookup JSON. Oh, I missed an A in there. That's the problem when I wear glasses, when I have to look close. Any other typos before I try this out? That looks good to me. I think it should work. Do you think it should work? You see something? I can't hear. Well, let's try it and I'll see what fails. Oh, I see the, no, that's all right. I've done something else wrong here. Postal code lookup, API geo names, postal code lookup JSON, and the username, country code. So that all looks good. And what's its problem? Well, I've made some sort of typo somewhere, but I don't know what it is. I've been going back and forth.
Country code is use.
Did I type it wrong? No. All good ideas. All good ideas, but none of them right. Yeah. Gee. I can't get to the service right now. The problem is that it's... Oh, did you go into VPN?
Yeah, probably not.
Okay, that's why. There's our answer. We actually have to, because it was an internal service, you have to be on VPN. I don't think we are. So ends the demo. The next step would have been to define an API which calls into this connector and decouples it from the implementation itself, and then invoking the connector. And the nice thing about at least our service is that we allow you to kind of test this in line. You can test your connector and test your APIs. We have this thing called a mock service, and that mock service provides a way to that mock service provides a way to actually test your APIs and connectors out just in line and make sure that you've done things right. Now, obviously, I wasn't able to do that here, but once we get our connectivity back, maybe the next time around we'll show you again. Anyway, hopefully you got the idea of what we're talking about is a mobile backend as a service. This is sort of the next up and coming thing for mobile. It's the beginning of how to use mobile within an enterprise. It's not the Angry Birds user typically. It's going to be when an enterprise needs to deploy mobile applications for all their people, this is what they're going to use. And that's all the time we have, I guess. If there's any questions, I guess you can come and see us afterwards. Thanks for coming. Yeah, I knew it was because we were using the browser.
That's great. Thank you so much. I'm curious, on latency, right? I mean, you normally, if you have your servers in the US and your market base is China, does the cloud replicate? Do you
What you typically do in those cases is you have a data center that's more local. So normally,
do you provide that though? I mean, this is cloud, right? Does Oracle provide your ability to do that? Or I can say, you know what, I'm going to have US replicate this in China too. Does it automatically do that?
yeah, Oracle doesn't do that right now with its data centers. It doesn't have replication across data centers like that automatically for you.
So I'd
typically,
have to create a cloud service in China and create a cloud service there?
right, you'd have to create one if that's what you want. I mean, you could, depending on what your connectivity is like, it might be all right, but chances are it's not going to be.
No, it usually isn't.
It usually isn't. So
I mean, if you have your data here, I mean, think about the latency of the thing that has to hit just to get the data back.
So what Oracle does provide is kind of schedulers as a service kind of thing. So you could schedule a copy or a backup being to occur across data centers, and you'd be able to communicate across those and copy data.
But the cost would be like two separate ones.
It'd be two separate services. Yeah.
Just one more question. How are you dealing with the situation of, I mean, like for example, in my case, we were looking at, depending on the device, we have to change the content and sometimes we send out rendering information for sheer level of dynamic behavior. How is that handled in the situation, in the system? Like for example, if it's an iPhone versus Android versus some other micro device.
Yeah.
Actually, the rendering changes.
Yeah.
We have had cases where we had to completely push the rendering out.
Yeah.
In a sense. So, how does the system deal with that problem?
Well, because you can access the context on the server side, then you can make decisions based on that information. So if you've got the OS information passed in every API call, then the API that returns the UI can basically define based on the device type.
And what about, actually a follow-up on his question, what do you do in terms of basically disaster recovery? The whole system goes down. What do you do in that case, and how does that work out?
Well, that's the beauty of the cloud, right? Cloud takes care of disaster recovery. If you're sitting in a data center, a cloud data center, you're assuming that it's secure, right? Because that's you're putting your,
Yeah, it's not necessarily going to replicate it from Chicago to Beijing, but yeah, the data centers themselves should be resilient and come back up.
Yeah.
Thanks.
You're welcome. Hi.
Thank you. My question is this: so, what's the typical deployable components in your system? So how application at server side develop? So do I give you, let's say, I give you a jar or some raw file? So how would I deploy on?
Well, Jason was talking about custom code.
Yeah, so at this point, it's essentially it's a jar, it's an archive, or actually it's a zip file at the moment that contains the your custom JavaScript that you've written that conforms to the API that's been defined, and that's what gets uploaded as of today, because there isn't a standard format for this yet. So that's.
So let's say I have a kind of like application features developed for a hospital. Is this something we can say, oh, can we use the Oracle this infrastructure to deploy on this and to figure out is this a correct scenario to do?
So you're saying you have some kind of reusable domain-specific components,
right?
And you'd like to reuse them, or you're wondering if Oracle provides those for a hospital or some domain-specific?
We developed this for hospital.
Okay.
And we want to say, okay, where do we deploy this? We don't want to deal with infrastructure, dynamics, and also the feature of see where the client comes in. So is this something?
There is. Yeah, we actually have something that we're doing right now that is at Oracle called a marketplace.
Oh, I see.
Where you would essentially make your pieces available
Right.
for MCS pieces, and that any other MCS customer could then sort of purchase these from your company
Right.
and be able to use them in their MCS application.
I see.
And that's the sort of thing you're talking about, right? Where they're kind of these things that, that healthcare applications would build and then use your pieces.
Yeah, you'd essentially go to the marketplace, and if you've posted these healthcare, for the most part, probably a number of healthcare APIs, then they could go to the marketplace, purchase them, and import those into their API management catalog, so that it's then available in their system for their own applications to use.
Right. So then maybe I missed this demo. So what's this for? What's this your system?
Ours is the hosting for applications that want to. So the idea is that from a mobile app, you don't want to have to deploy all the logic, the enterprise logic, in every mobile application. You want that mobile logic to be decoupled from the mobile app, to be in this sort of middleware, this platform area. And that's where you can host all the analytics capture, you can host all of the custom code logic to be written in some whatever other language. You can host all the notifications and cause notifications to happen on all the devices. It's sort of it's a whole platform management layer. You can control the data on your devices by wiping it if it gets lost. These kinds of things. This is all the way you manage the enterprise mobile space.
So you mean, let's say, sorry. You mean if I have a mobile app developed for iOS, and so instead of I go to Apple App Store, I deploy it to Oracle?
Yeah, you would deploy to our marketplace and allow. If it's an iPhone app itself, I mean, you can do that in the App Store anywhere you want. But the pieces that you're using from the Oracle system are what you would. They're not necessarily the mobile app. Those are the server-side pieces for your platform. That's what you'd host on the Oracle Marketplace.
All right. Okay. Cool. Thanks a lot.
You're welcome.
Yeah, absolutely. Of course, we're just get out there.
Get out of their way so that they don't.
Including you now.
So for your offering, what is your runtime gateway? For the Oracle API.
So we have our own. So basically we have our own API management layer that's handles all of that. And it all goes through
my name is Stefan.
Oh, Stefan, hey, nice to meet you.
I know it's your
authentication. No, I didn't want to get another demo working, but I didn't.
Is enterprise Java still relevant by IBS?
Oh, okay. I did see that.
That's pretty good because the things we've talked about in general.
Okay.
But also, we talked about more
in our
everybody's doing it.
Yeah.
Jumping on the bandwagon.
Your server-side logic. You could basically sell it to them, and this is like a B2B case where I'm talking to the other guy about.
So what's your plan with the Mac to basically make that your main machine?
Probably, yeah.
I would if I were you. What do you run on that? Do you run some variant of Linux?
Ubuntu. It's just because I've used it on my home machines for probably like 10 or 12 years now. So
that's no excuse.
I'm more familiar with apt-get and stuff than Yum.
Right.
Run their own service, they just happen to install your software in their service. It's the same software, same application, but it's now theirs. It's under their name and their. It allows.
So how much memory does that thing have?
I think 8.
Oh, okay.
And that was an upgrade from 4.
How long have you had it?
Actually,
2530, that's not too old.
That's allowed. I think it's 2 years old now.
Right.
It might have 8 standard. I think it was the one before that was 4, and then I got Tom out to buy an extra 4 gig.
I remember buying a laptop that only came with 1 meg. Those are the days.
It's really a matter of preference, I guess, when it comes down to it. But you do see that there's a trend from voice over to all. Sometimes it means authentication. Oh yeah, definitely. No one from forecasts problems or whatnot.
Oh, right. Did you end up? Yeah. Okay, I don't know. I just told
It's very cool.
You know this application. Did you see the PR star?
Yeah.
That was dedicated to you.
Which one are you seeing?
So how many demos are you going to run? With this crowd, the more the merrier.
I've currently got probably, well, there's kind of 2 apps and then a couple of different ways to run things.
Yeah.
So there's probably like 3 or 4 kind of demos, but I can always pull out the examples project if I need to.
Were you intending to go through the GitHub or just showing people what's where? Because when I did this at the Microservice Architecture Day, months and months ago, we had a bit of structure. We didn't have like the separate docs repo stuff in there. I think it was just before Bob and you reorged the examples.
Oh yeah, because it was separate repos for a while.
I mean,
yeah.
it was quite interesting to show people exactly how much stuff's there and how they can contribute.
Yeah, we could. Well, I think the last slide is talking about keeping in touch, so I can always just do it after that.
Yeah, okay.
That works.
So I'll do mine, and
Hey.
then I'll hand back to you. And you can wrap
Yeah,
up.
there's like a couple of slides at the end.
You're in 3. Did
Yep.
you see you up there yet? You working?
So what do you want us to do for
Okay,
mics?
I'm not too big, am I?
Mics? Do we just?
Mike's, that's a good question. How are you guys gonna handle it? Yeah, I'm way. Yeah,
Well,
so
I
that's
think
a VGA out or no HDMI?
It's HDMI. I think what that is going to
I
be.
oversized it for the last session, only on the VGA input though. It shouldn't oversize everything. Yeah, there you go.
Okay.
Or no, what do we, where's your Prez?
Okay, I know what I need to do. That's fine.
Yeah. Let's see. 3 is HDMI, so that should be pixel per pixel, even though it's really not.
You're now mirroring, and you weren't mirroring before, is that?
Yeah.
Yeah.
So
It's
it was like
extended, it
2
gets-
pages on the one workspace. Yeah. Damn, it shows that at the bottom. Speaker notes.
No! What?
Yeah, I know.
No. You got many speaker notes?
There's a couple in there.
Okay. So would you prefer us to use these?
Well, the last guys, it's
Does
all
that work?
your preference. Yeah, that works fine as long
Okay,
as you guys
that
don't
might be
walk
fine.
too
Okay.
far.
Yeah.
The cameraman's over there. You guys are being webcast. I think they're on YouTube or something. So this guy, Cliff, he's been asking if you guys do tag team each other and just talk.
Yeah.
That you kind of stay closer, because for him to pan across back and forth for video reasons, it's
Well,
kind
it's
of
going to
hectic.
be him talking, then
or
I'll
you?
talk,
Okay, yeah,
then
that's
people-
perfect.
Yeah.
That's perfect. Then you don't have that
I
issue.
kind of hover in the background.
Yeah, that's fine. That's fine. And then, if you're not moving, then you don't need a lav really. But if you do want to chime in anytime, these will be open. So, But otherwise, you're just back and forth in the podium. No second source, right? You guys are on the same Prez.
Yeah.
There's no other
Yeah.
switch for you to
Keep
make
it
here.
simple.
Yeah, good enough. That makes things easy. And no one's used their Oracle laptop all day, so whatever. I just wonder if this closed, is it still receiving Prezes? Did you guys send any of your Prezes to them?
Yeah.
You did? Okay.
They said none of them would be loaded though.
None of them will be loaded here, right?
Yeah.
That's what they told us. They said if you had your own machine, what was the issue? If you were going to give us something, if it didn't work with your machine, that you would give us the presentation, we would load it on here, but no one's had a problem with their own machines. But I remember Oracle, like a lot of larger shows, you have to use their templates.
They used to do that, but
yeah.
they stopped doing that about 5 years ago.
Did they really? Yeah. Why has it been that long? Or I just haven't noticed.
They used to have like you had to send in your slide deck using their template,
Yeah.
and then they would send it back to you saying you've got to change this word or whatever. They'd
Yeah.
actually review them. They don't do that anymore.
That's probably too cumbersome.
Yeah.
I never could understand why they did that, but that's, you know, that's them. And you guys.
They're not at the moment, but they will be tonight.
Google's Open World. I think they have it.
Not right now, no.
Right.
Where all the developers go to the show
Yeah.
and use their own
everybody uses
contractors. But they used them in the past. They used to have to use their branding type thing. You know, I guess they're going away. I have no opinion. I don't care as long as it works.
Yeah, that's the important thing. Yeah.
Okay, guys. So you're off now. You just switched off, right? Good.
So we start. Due to start at
We start right
5:30.
an hour, yeah.
5:30.
So we're on.
So when we finish, I'm gonna have to jump quickly because I got an awards party I'm supposed to go to. Okay. So I'll let you wrap up already.
Did you show the guys? No, they haven't seen what they look like. You're on half. I didn't tell them you're on half the screen.
We're on half of that screen.
Yeah, no, you're all the way on that one, but the one on the web, that's the YouTube shot, right?
Right.
They split it with your content.
Oh, okay.
So if you're only got a viewing box so big, right?
Yeah.
They have half of that's your slide. The other
So
half's
you get
you
like
guys.
your nose or something.
Yeah.
Okay.
So, you want to take a look, you guys? See what it looks
Oh,
like.
could do. Yeah.
I'll stay here. You can look. Maybe you'll be able to see the. Easy for me to say.
So,
What's
we're
the
gonna-
story,
we're gonna
dude?
float the rooms for the last half
All
hour.
right.
So
I'm
about
cheap.
5:55.
I'm probably open to the web. So Oracle's being cheap. I remember the days we used to have the. What's crazy? I didn't even realize for the last few years I've been doing this Oracle show that this is Java.
Yeah, because
What happened? Wait, Java's Oracle now? I know.
Ellison bought Java, and then they combined them. Remember, it used to be 2 gravy shows, now it's 1 gravy.
Really?
That's,
I don't remember that.
Shows.
I thought it was either.
When do you go back?
Friday morning.
Oh, okay. So you're staying for Elton then?
Yeah.
Are you a big Elton fan?
I enjoy it, yeah. My wife's extremely jealous.
Yeah, so is mine. Hey, John.
I made the comment, shall I send you some pictures? And she's like, no fucking way, unless it's like a video of Elton saying how much he loves her, kind of thing.
So every time I've been at these, I stopped doing it now, but the first time I went to see it was the Black Eyed Peas.
Oh, yeah.
And that was a really good one. And no, actually, the first time was Smash Mouth. Remember Smash Mouth?
That was before me. Before I started going.
So they're doing this concert, and I'm taking pictures, and I'm recording, and I'm sending them to my wife, thinking she's in bed, she'll be asleep because of the 8-hour time difference. And then she starts texting me back saying, "My phone is waking me up. Stop doing this, and also stop rubbing it in." We're expecting some more people.
Does this
I really wanted to ask him that question to see what his response would be.
The standards one,
Yeah,
I know. Yeah.
what's the value of standards? He's like, given their customer base, I figured he would answer the way he did.
Hi, Ian.
There he is.
You had a proper room too.
This is a proper room. I enjoyed that. That was a good session. Hey, appreciate that.
Yeah, good turnout.
Yeah. Could have done with bigger room. Next year we have to do this job. We're gonna get an even bigger room. yeah.
Did you get the invitation from Andy Rubinger for dinner on the Wednesday before Elton had?
Yeah, the one that starts at 5.
Yeah.
Yeah. How does that work? Because I think you booked it from like 5 to 6 or something, but I saw that the buses leave at 5:30.
Did he?
Yeah.
Oh. Did that last time. Well, we basically ended up scoffing down the Rubiner's meal and then running out of the restaurant and calling Uber. We didn't go on the buses. We got Uber cabs.
Or maybe he's playing that again.
Yeah,
I don't know.
I'll check with him. Please tell me you're not doing the demo. We're not fixing code.
Just pre-compiling stuff, so it's already there.
So everything's sorted out with the transition?
Yeah.
You sure you want to do it? Just double checking.
The development platform stuff is cool.
Yeah.
But I feel like it's going to be a political shitstorm for a long time.
Possibly, yeah.
Yeah.
But that could be a good thing.
Well, maybe, yeah. But I hate politics, so. And I kind of got. And actually, there was a call today where Pete talked about the changes with Alexi and Max.
Yeah.
And he basically said that he wants to operate under the slightly different to everyone else, where it's the manager is also the lead architect.
Right.
And it's like, I don't want to have to be a manager just to be the architect.
Yeah.
So, I think I have fun with Bob. Swarm is great. There's lots of stuff to do there.
Yeah.
So.
Yeah. I insisted that we had to offer it to you. So it wouldn't have been fair. Yeah,
Well,
it would be better for you to turn around and say, no, I'm not interested, than for you to
Found
out and go,
that's not bad. Yeah, no. Yeah, so I agreed with Pete that I'd finish up at Christmas and start on Swarm in the new year.
Yeah. Well, I mean, obviously you'll be doing bits of Swarm between now and then anyway.
Hopefully a bit more in December once the November release for the platform is done.
Yeah. Good. And you'll report to Bruno.
Yeah, I think I've met him once, like 4 years ago, but I've heard that it's it can be. What was Max informed me that he's even worse than Rodney in terms of how much communication you have with them.
What does that mean?
Well, because apparently, obviously Rodney doesn't always have a lot of communication with the people under him, but that was when he was managing 50 guys.
Yeah.
And Max said that when he was with Bruno, he had even less contact with
Okay.
him. But obviously, if Bruno's
Bruno's
just
a lot of people
managing
at that
Swarm
point. Yeah.
and Gavin and
Yeah, and
RMP,
Bob.
then that's not many people to worry about.
Yeah. Minutes or so.
Hope a few more people show up.
I don't know. It's 5:30.
Well, there is that.
Yeah. What I wouldn't want to have is, because I have had these sessions before, the last session on the last day, the job. Because then if it's packed, what you're thinking, are they really interested? Or are
Because
they
there's
all
just
just
nothing
sat
else
here
else to
killing
do.
time before they get in a cab and go to the bloody airport?
Well, was kind of surprised that Athletes at Killian talk is on Thursday.
Is it?
Yeah,
Oh.
they're testing microservices
Yeah,
with the
I
Killian.
didn't think
yeah,
they put it
that's
on that
Thursday.
late.
Yeah.
Well, the community keynote's on Thursday as well.
Mm.
Unfortunately, I will be in the air by that point. My flight's about 2 o'clock Thursday afternoon.
Okay.
Probably won't get back to that 1 o'clock Friday. Do you live a little bit further away than you do?
Yeah, just a little. I'd like to be living that far away, but...
Would you?
Oh yeah. My wife and I are going to move back to England or Europe at some point.
Ah, okay. Right.
Probably not until the kids have finished high school though.
Why? Better education system in Europe.
Yeah, no, it's more a case of being around her parents and the family while they're growing up. That's why we're in Boston.
Yeah. Free grandparenting.
Yeah, free babysitting. Yeah, because we were because we owned a flat in Islington after we left Australia. Actually, no, before. But it was like, yeah, we knew we wouldn't be raising kids in London.
Yeah.
We thought about moving out, a little bit out, but we knew it was going to be too tough.
It's our hub. Yeah, seriously, come to Newcastle. Cost of living's a hell of a lot less than London. So, how old are your kids?
4 and nearly 7.
Oh, okay, so you're talking about quite a while. You've got at least a decade.
Probably. Though we'd like to move sooner, but yeah. You don't want to cause too much disruption to the school years.
Yeah. So whereabouts in Boston?
We live in Pembroke. It's about 30 miles south. It's near, it's like 15 minutes from Plymouth.
Oh, okay. Right.
Hey guys, just one other note. When you reference your slides for this one.
Oh, because of the way the YouTube video is.
Yeah. It looks real good that way.
Okay.
Thanks, guys.
Yeah, get out to the Western office. It's quite a slog from where you are then, really, isn't it?
It's about an hour and 15, hour and 30, depending on traffic.
Do you know we're opening an office in Cambridge?
That would be about just as long.
Right, yeah.
I'd heard rumours, but I hadn't heard if it was happening. But the first time I stepped foot in Westford was in July for the face-to-face for the developer platform.
Oh, okay.
It's like 4.5 years and hadn't stepped foot in the office.
Yeah. Well, I go there as often as I can, which isn't that often. They like to see all that, the hub of everything. Really, most of the work that we do is outside the US.
Well, as I say, Westford's really only a hub for real stuff, isn't it?
Yeah. See, they should be serving beer. They are serving beer.
Just not
they should
here.
be serving beer here.
I gotta head out about 10 minutes early.
Okay. No worries. No, great to see you.
It's a JCP thing.
Okay.
The awards. They do. I'm going to be there as well.
I figured show up late.
You'll be alright. Well, I'm not showing up till after 6:30. Time did you make it?
28.
Okay.
So probably a couple of minutes. Well, at least put that on.
What?
At least put that on.
Yeah, it's looking alright. Looks yellow on the screen. Is it yellow? I mean, it looks orange there.
I think it's kind of a yellow-orange.
Is it a James Cobb one?
Yeah. No.
Or somebody who works for James?
Was it Brock? Can't remember his first name. The one that everyone complained, oh god, another Brock.
Not Mike Brock, he left.
No.
Oh, well.
There was comparisons to that. I can't, is it Aiden? Aiden Brock, maybe?
But he must work for...
Yeah, he works for James.
Okay.
Oh jeez, Ed.
That's not fair. That's not fair. You should have done this yourself. Well, I'm going for I'm going for lead.
I'll get that too. You know what I'll do? I'll hang them off the side.
So what are the yeah, you were decades worth. You know,
Well, I guess it is more than decades. Now it's up to 2 decades. Now I'm at 15. Well, I'm gonna have
Good to see you.
Have a good talk.
Yeah.
Okay, welcome everyone to our talk on Java E7 applications as a microservice with Wildfly Swarm. My name is Ken Finnegan, and over here is Mark Little, and we'll be talking to you today about Wildfly Swarm. So we'll start off with a traditional Hello World example. So if we have a look at the code here, we've got a very simple, oops, let's make that a bit bigger. Got a very simple JavaOne resource with a root path and just returning some text. So now if we do a we run the Uber jar, and that has now started, and we'll go see what it gives us. So oops. So you can see there, micro print again, make that a bit bigger. Hello from Wildfly Swarm. So that's a very simple example to show you what we can do with this. So microservices are decoupled, obviously, typically have independent release cycles. They provide micro functionality, not lines of code. They're ideally self-contained, and they can be scaled independently of each other. And as Amazon has taught us, all aspects should be owned by a 2-pizza team at most. So microservices in Java EE. You could consider them unexpected bedfellows in the sense that Java EE has a perception of being large, bloated, not always the quickest and easiest to do things with. So you wouldn't naturally assume that they're a fit for microservices. But on the other hand, there's millions of developers that know Java EE already through its robust and mature components, the scalable, standards compliant components that integrate well with each other. So if we have all these standards compliant components and APIs, why create something new just because we're talking about microservices? Also, not everyone wants to use all of Java EE. Sometimes you want to use bits and pieces, and stripping down EAP and Wildfly has been a common request in the past. So we're trying to make that a bit easier with Wildfly Swarm. So kind of an evolution of development over the years. Probably most of you have dealt with ears in the past. Hopefully not too many of you are still dealing with them now. Are there anyone still using ears right now? Oh, wow. I feel sorry for you. From there we kind of moved on to the multiple war approach, but still containing lots of jars inside them. So we're now kind of moving to a Uber jar approach where the war and any jars that are required to run it are inside a single executable jar. And that kind of fits very nicely with the microservices view of the world. So Wildfly Swarm. It allows Java EE components to become independently deployable services so that applications can deploy only the components they need. It reuses existing Wildfly, so we're not creating new pieces that haven't been used for years before. It provides self-contained services. It allows you to build your application as an Uber jar, and we're not limited to just Wildfly subsystems. For example, we've already got some Swarm fractions that utilize Netflix, so Ribbon and Hystrix. So this is a JavaOne resource. Oops, there we go. JavaOne resource, as you know it today. It's got a path of persons, a database helper that's injected, and a couple of paths there for getting a list of people and getting a particular person. With Wildfly Swarm, that's what your JAX-RS resource would look like. Once again, a path, injecting a database helper, and the list of persons and getting a single person. So I don't know if anyone spotted the difference. If you didn't, don't feel too bad, because they're identical. And that's the goal we're going for with Wildfly Swarm. We want to make it something that doesn't impact your application development in any way. It allows you to take what you already have and simply package it and deploy it in a slightly different manner. So this is kind of another way to look at it. So if you take your app and it's JAX-RS, in the old model at the top there, you can see that we also on Wildfly have things like EJB3, transactions, batch, callbar, messaging, a whole bunch of stuff that you may not ever go near with your application. So with Swarm, it gives us the opportunity to basically say, I only need JAX-RS, so build that part of Wildfly into my application and ignore everything else. So ease of use. That's critical for Wildfly Swarm. We're exposing Wildfly subsystems as fractions, and I'll go through shortly what fractions are and how they work. We provide a Maven plugin to add to your build process, which then generates the Uber jar. We also have support for Gradle at present, and where the process of generating the jar is in a abstracted way, so that you could essentially create custom builders for any particular build tool you needed. At the moment, we've just done it for Maven and Gradle. And obviously, as I mentioned before, our goal is to keep your application code unchanged. We don't want you to be adding a whole bunch of annotations or extra classes just to make it work with Wildfly Swarm. And we can do that by utilizing sensible defaults. Now, obviously, if you want to go beyond that, there will be some extra things you need to do, and we'll cover that in a bit. So what is a fraction? Minimally, it's a module XML that says I need one or more jars, and it may have other dependencies in terms of saying it depends on other modules. So, for instance, it might depend on the JAX JavaX API or transaction API or a JPA or potentially anything else. So this is typically used for pieces that are not Wildfly subsystems. So this is how we've added RxJava, RxNetty, and things like that. It's also used as a way to activate Wildfly modules that are not active by default. Our build tool reads through the module definitions from the subsystems of Wildfly and basically excludes anything that's optional. And this means that we can reduce the size of the Uber jar in most cases without impacting functionality. And this is our way of adding that back in. So for instance, JAX-RS and Weld CDI subsystems, they operate independently, but there are some overlap to allow them to work together. So by default, we don't activate those and make them available in either of those subsystems. So we create a separate fraction that pulls the two together and says, I need to activate this particular Wildfly module to make this work together. So in addition to that, most of our fractions that relate to Wildfly subsystems create an API for defining how it can be configured, which utilizes a new API we've created that is generated from the Wildfly subsystem meta model. So instead of having to create your standalone XML stanzas and configuration, you're able to do that through Java APIs. And it also allows us to create custom archive types. We use shrink wrap for defining the archives that are deployed in Wildfly Swarm. And through this, we've created JAX-RS archives, and for Ribbon, we have a special archive for that. We also have a runtime that defines how the default fraction configuration is added into the Wildfly server. And also there's module XMLs for all those pieces so that they can be found through the class loaders. So fractions can be inherited from one another, and this is done through Maven dependencies. So for example, the JAX-RS fraction needs a servlet container, so it depends on the undertow fraction. And this allows us to provide higher order fractions that mean you only have to specify one or maybe two fractions in your application to get it to work, which keeps your POM relatively clean and makes it a lot easier to add. Another benefit of fractions is aggregation. So we can define new fractions that combine others. So I gave an example of the JAX-RS and CDI working together. That simply adds the two fractions into one. And there are others that allow you to combine on other pieces. And it also means you could potentially, if you wanted to, create a fraction for internal use within your company that had a whole series of other fractions defined to allow you to then simply add one fraction dependency into your projects. And everyone got the same combination of JAX-RS, JPA, data sources, data sources, yep, or anything like that. So at the moment, we have these fractions created. At the top, we've got a bunch of Wildfly subsystems. So JAX-RS, CDI, JPA. Recently, we've added Hawkula and Infinispan. And of course, in there we have Keycloak as well. Some of the non-Wildfly pieces we have as fractions are Ribbon, Hystrix, and we have a Ribbon secured, which is Ribbon but integrated into Keycloak to provide security for APIs. And then we have some custom ones such as Logstash, which uses the existing Wildfly logging subsystem but provides some custom configuration so it can integrate with Logstash. And that list is constantly growing, and we're always adding new ones. So why do I care about fractions? Well, for the most part, you shouldn't need to. They are the building blocks of Wildfly Swarm, so it's a good idea to know what they are and have somewhat of an understanding of how they hang together. But in 99% of cases, you're never going to need to develop your own. There may be the 1% of cases that you need to do something such as the aggregating fraction to pull lots of different pieces in together, but most of the time you wouldn't need to worry about that. And if there's something that isn't in that 99% already, let us know and we'll try and add it. So in terms of development, the fractions we provide replace any existing Maven dependencies you might have. So if you have references to like the JavaE APIs, you can safely remove those as we bring those in as provided dependencies through Maven to allow you to have access to all the APIs that you need. So now we're going to convert a JavaE 7 application to use Wildfly Swarm. So for this, I've taken a sample from Arun, which is a simple JAX-RS example using JavaE 7. So if we have a look at the project here, let's make that a little bigger. Yeah. Why is that not working? Okay, that's misbehaving. We'll try again later. So it has obviously a JAX-RS resource. Do you know how to expand in JBDS? I thought it was Control Plus, but it's not working. Tools are great fun, aren't they? So we have an application path. We have a person entity which is defined as a JAXB XML root element. We have a database helper which essentially creates a whole bunch of entries on load, and then a JAX-RS resource. So that's a basic JAX-RS example which runs on Wildfly today. So to make it work with Swarm, what we'll do is add, oops. add a version number in there. Then we'll pull out the existing dependency and add a couple of dependencies on fractions. So we need the JavaOne Wells fraction to give us CDI and JavaOne. And we also need a JavaOne and JaxB fraction to give us the JaxB binding of XML root element and add that support. And then the only other thing we need to do is down here in the plugins,
Sorry, those are in the provided scope or in the...
they're in the compile scope. Anything that's a Java E API will be pulled in as a provided, so it won't be added.
JBoss comes with its own JavaScript implementation.
I believe so, yes. Okay, so and now I'm just adding the plugin that is used to generate the Uber jar. And we need an execution section. And we want the package goal. So if we save that, and then we, need to stop that one. And if we go to where it's located, and if we simply do a maven clean install, this was what happens when you get the name of something wrong. Maybe it's that. There we go. Let me just turn my internet on again. I thought this was working a while ago. This is not good. No, it looks the same. Let me see. Let me cheat. Yeah. Oops. Let's try that again. Okay, so you can see the Swarm plugin is running. And it'll take a minute to figure out all the module XMLs and which jars need to be included, so it can bundle them all into the Uber jar. So that's complete. And now if we run the Swarm Uber jar, That will start up JaxRS, CDI, as you can see there. Whoops. Oh, that one. So if we run that, it's the same page as you would get running on Wildfly, and if we call the JaxRS endpoint, make that a little smaller, that's all the data that came from the JaxRS endpoint. So as you can see, oh, yeah.
So this Uber jar then launched Wildfly, but if I wanted multiple Uber jars to run at the same time, then I guess I'd have multiple different Wildflies, but it set them up to all the listen on different ports.
Yes. You can do that through, so if we've got that one running there, if we come over to here, no, it's I think that's the right parameter. Nope. Actually, no. What we might try is.
Perhaps to generalize the question a little bit, I mean, Wildfly has a pretty complicated configuration XML, right? So if I need to configure things in there that affected the Uber jar, how do I do that?
Why don't you main?
Yep. Okay, so we'll get to that. So just to recap, all we changed was we added the Maven plugin for Swarm with a goal of package, and we added the two fractions for JaxRS with CDI and JaxB with JaxRS. We didn't impact your application in any way, and that was all we had to do. So to come to your question, to main or not to main, so that was not using a separate main class, it was just running everything that you would have in a normal WAR and figuring things out and just basically using safe defaults. So when we don't create a main, you get your default container created, and any fractions that are on the class path are created with their default configuration. And the primary user artifact that is deployed is a WAR, typically. So if you want to provide a main, it gives you the opportunity to create the container yourself and provide custom configuration of the fractions. And any fractions that you don't explicitly provide custom configuration for, we'll just do the default configuration as if there was no main. It also allows you to create some custom content within the archive that's actually deployed within Wildfly. So to utilize a custom main, it's simply a case of adding a main class configuration to the plugin so that we know what you want to run. And so this is an example of a custom main. So to run you through it, we start out with creating a data sources fraction and specifying a JDBC driver, and obviously the driver class names, and the driver module name there refers to a JBoss module that we've defined that contains the H2 jar so that it can be found. Yeah. If you want to create custom configuration, you would need to write this by hand at the moment. But we're open to ideas about how to not do that and have it build it for you, maybe through properties or things like that. And then we define a data source and specify the driver name, which we created in the step before, and obviously the connection URL and username password. And then in the middle here, we're telling Swarm to not use the default JPA configuration. So the JPA fraction has a default setup that will create the example DS data source that is common in Wildfly. So we're telling it to not do that so that we can create our own. You could have not prevented it from doing that, but you would have just ended up with 2 data sources created in your Uber jar, and one of them you're not using. So we figured that made sense. And then down at the bottom here, we're using shrink wrap to create the JAX-RS archive, and we're adding our classes and any web inf resources such as the persistence XML and a default load SQL, and then we're adding the dependencies and telling the container to deploy it. So that's an example of doing a custom main where you specify the configuration that's equivalent to standalone XML.
So we can add our own encryption mechanism for passwords, right? If we do upload this one.
Yes.
Instead of using Picket link or something.
Yep. And pretty much with the generated API of the Wildfly meta model, what you can configure in here is limitless. Basically, all the properties that you can set in the standalone XML are available as a Java API. We're still in the process of making all of those available, but there's quite a few subsystems that we've added that way at the moment. So obviously you saw it's pretty easy to build. Maven package or Maven install. There's nothing special about that. And running it, you saw me use java-jar to run the Uber jar. We also are able to, so I'll stop this now and I'll do a Maven clean to remove anything that was there before. And then we'll do a Maven Wildfly swarm run. And this uses the same build tool that is there to generate the Uber jar to basically build an in-memory Uber jar, which it then starts. So that's now up, and if we go to localhost 8080, and it's working as it was before. And I'll also show you another way, which through the IDE. So we don't have a main here, so what we do is we say that we want to create a configuration for run, to run a Java application, and the class is org wildfly swarm swarm. Now that's the default main class that the swarm plugin will use as the main class for your Uber jar if you don't specify your own. So there is one there, it's just you don't need to create it, and this is the one that does all the defaults and standard configuration. So I've created that there. Oh, what is going on? Okay. And if we run that, we can see in the console that Wildfly is starting up and configuring CDI and weld. And if we go back over to the browser, and it's working again. So we've provided you 3 different ways to run to make it easier for testing and trying things out.
So the runtime just needs a JDK, right? I can take this job, any VM which has JDK, I can run it.
That's correct. Yeah. Sorry? Yes, we do require JDK 8, but so some of you may still be on 7 and hopefully not 6. So that's the one requirement we do have. And now it's time to hand over to Mark.
Yep, thanks Ken. So I'm not going to risk the demo gods. So there's no demos in any of the next 4 or 5 slides that I'm going to talk about. So anybody who's been looking at microservices over the last 12 months or so, particularly stuff that Martin Fowler has been talking about, you will have heard a number of things that are bad, purportedly bad practices with microservices, and transactions, or at least distributed transactions, is one of them. things like, transactions should be contained within a single service. Each microservice should be deployed with its own database, and it should only use and consume data that comes from that database. And who needs atomicity anyway? It's completely overrated, and transactions limit scalability. But obviously, coming at microservices from an EE perspective, as we do with Swarm, you've got transactions in there. JTA has been one of the core parts of J2E since the 1.0 release. So how do you kind of, as they say, square that circle? That one? Yay. So first of all, I think it's important, and hopefully most people in here, if you're Wildfly, EAP, or some other variant of an application server developer, you'll know about transactions. But just do this anyway. Use transactions when you need them. Many of the problems that people complain about with transactions often come about because they're misused. They're used in areas where it really didn't make any sense to have them. Particularly distributed transactions. So, use them when you need ACID semantics. They give you guaranteed consensus in the presence of failures. They're really, really good, whether it's, the transaction service that we've got in Wildfly or, something like Kix from IBM. They've been developed to give you this guarantee of reliability and recoverability. And obviously, they give you isolation and consistency as a result. Now, relaxing ACID semantics is possible. And over the last 20 years, there's been a lot of work gone into relaxing various properties, whether it's the A, C, I, or D. And there are a number of standards that are around. Some of them, Ian Robinson, who's in the front row here, gave a talk earlier about whether enterprise Java is still relevant today. And he mentioned briefly, he didn't give the number of it, but he mentioned briefly about a JSR that he and I was on it, tried to push into, well, actually we did get it adopted eventually, but nobody ever implemented, JSR 95, which was about adding the ability to relax ACID semantics, having extended transactions in J2E. Like I say, I don't think anybody ever, well, we implemented it, but nobody ever actually put it into an app server. But that work is there, and, did you? Yeah. Okay. How's that working out for you? And then there's things called recoverable transactions, which is which are ability to build applications where you can roll back state changes like you can with transactions, with ACID transactions, as long as there are no crashes. If things fail, then you lose everything. But everything's essentially in memory, so you can make changes, roll back, make more changes, roll back, and everything works really, really fast because you've got no durability in this case. But the caveat is, if you get a crash, then you've lost all the state changes you made whenever you committed your transaction. So what we want to do with Swarm, and what I've been putting into Swarm is obviously we have to have the ability to have JTA transactions. It's a given, EE7, EE8, as Swarm will eventually become. You've got to have transactions in there. But then also to kind of extend that, Ken touched on, and we'll mention a little bit more later on about things we're doing with Netflix, for instance. So, adding going the extra mile and adding things in to Swarm that people expect now, and also expect more as they move towards a microservices architecture. And these kind of additional transactional semantics, we think are something that people will want to have, not necessarily for every single application. Like I said before, don't overuse transactions, but to have that flexibility so you can get some level of guarantees. So first of all, this is just the example that you can get from the Swarm GitHub account today about how you can write a JAX-RS and JTA resource. Pretty simple. Anybody who's used JTA and JAX-RS will probably you'll be able to understand what's there. But we've got the usual JAX-RS annotations. We've got within the begin commit method, we've got a call out to JNDI to get the user transaction, find that, start the transaction. So it's just a traditional JTA transaction, and then we'll do something. In this, we don't actually touch any state. It's just an example. We then commit it, or we can roll it back. So this is kind of to Ken's point earlier. this is exactly the same kind of application that you would write with vanilla EAP or vanilla, WebLogic or WebSphere. There's nothing special here about it because it happens to run in Swarm. And then here's the main. Nothing. We're not overriding any of the defaults in here, so I've only provided the main here just to kind of show you what you could do. If you don't have a main, as Ken mentioned earlier, Swarm will create a default one for you, and that default one will look spookily like this, look exactly like this, because we're not changing anything. But essentially, the main gives you the ability to go above and beyond the defaults. So in here, we're creating a new container subsystem. We create the transactions fraction. Those two numbers there are the transaction manager port and the recovery manager port, respectively. So you could change those. If you want to run multiple instances on the same machine, for instance, you might go in and configure those numbers so each time you build it, or more appropriately, you might want to do it more dynamically and have a property file where the jar, when you fire up the executable jar, it looks at a property file, and each instance that you're running is in a separate directory, has its own property file, reads the two values from that, and then runs dynamically that way. But then we start the container, we create the JAX-RS resource, and then we deploy it and we run it. And if you go, like I said, to the GitHub account and you try that example out, essentially you'll be able to go, if I go back one, you'll be able to go to a different URL for each one of the methods in this example, and you'll be able to see it say, begin, OK, commit, OK, or begin and roll back. So just vanilla JTA, nothing special about that. What I mentioned earlier about relaxing ACID semantics. So what we're trying to do here is, anybody heard of software transactional memory? If you've heard of hardware transactional memory, then software transactional memory is kind of like that, but in software rather than in hardware. What we're trying to do here is provide a software transactional memory model for people to develop applications within Swarm that are essentially going to be just recoverable. They're not, as I said before, they're not going to be durable. If you have a crash, then you're going to lose everything. But you get, with that trade-off, you do get the ability to have very, very fast changes and rollbacks and trying alternate mechanisms. So we've developed a framework for building transactions. It's integrated with JTA, so you can start JTA transactions. You can actually start doing things with databases. If you start doing things with databases, then you start to mix durability with non-durable, and the framework recognizes it and will actually promote what was a software transactional memory transaction with no durability suddenly starts to have durability. So you get, in a way, you get all or nothing semantics. You're either all no durable or you're all durable, and the framework will dynamically modify that. Another thing, which I haven't got an example for in the next few slides, but that I did want to just mention, though, is compensation transactions. So this JSR 95 that I mentioned just before builds on some work that we did in the OMG, and that work then got taken essentially into web services and web services transactions, where there are a number of models for doing compensation-based transactions. So a traditional ACID transaction, if you roll back, as the name implies, it undoes everything that was done before to get you back to the state you were in before you start the transaction. So it's as if the transaction didn't run. With a compensation transaction, you attempt to do a forward compensation. So you execute some additional work to try and return you to the state you're in before. But there's no guarantee you'll get there. But there are trade-offs in a compensation transaction. You're not holding locks for a long duration of time, and not all the updates that you do may have to be in memory. So as I know IBM have, we've done work with compensation transactions within web services and now outside of web services, and that work is also being imported into Swarm. So you'll be able to develop your Swarm-based applications with compensating transactions. Just conscious of the time here. I just put up a quick example. I noticed as Ken was going through that, I did a cut and paste error when I was trying to get that little box in there as small as possible. I missed something out, but I'll go through it in a second. So this is just to try and give you an idea of the software transactional memory framework that we've got. So you define your POJO essentially. All of the annotations that you see here they're there explicitly so I can call them out and tell you what they are, but they're all defaulted. So if you don't have them, there's a sensible default that's used. So this is, as the first annotation says, this is going to be an optimistically managed POJO. What that means is we're going to assume that locks aren't required to be validated until the end of the transaction. So we won't acquire a lock and then block somebody else from getting, if I want a write lock, a pessimistic one essentially would be get a write lock, that write lock is obtained at the point that I do the increment here, for instance. And if somebody else comes in and gets a write lock and makes a state change, they won't be able to get that write lock because you can only have one write lock. You can have multiple readers, but you can only have a single writer. Well, with optimistic, somebody else could come in and get a write lock. But then they may decide when they're doing their application, actually, I've decided I don't want to do this anyway, so I'm going to roll back my transaction. And their state change is completely undone, and the first person who got the write lock, when they get to the end of the transaction, they won't even know that the second writer was in there because, it was as if they never actually executed their transaction. So we've got optimistic for this particular POJO, and then these methods, as I said, defaults, but we're defining that we are essentially getting a read lock for that value, for the method value. We've got write lock for increment, write lock for decrement. And we're defining what the state is here. So this is if we were to want to save the state so we can roll it back on the event of undoing a transaction, we need to know what state's important. So you can annotate the state. If you don't annotate the state, then again, the defaults are things like volatiles aren't saved. Statics obviously aren't saved. Everything else is essentially saved. Whereas the assumption is that volatiles, you can regenerate them through probably through the operations that are invoked here. The box here, which is where I made the cut and paste error, just shows you how you would use that. So we create an instance of this class here, which is supposed to be my example. And then you essentially the line that's missing would show you that you drop it into this STM container. Everybody's using the word containers for one reason or another. This is not a Docker container, okay? This is a Java container, and it's not even an application server container. Then we start a transaction, could be a JTA transaction, it's not here, but it could be. We begin the transaction, we increment and commit. It really is meant to be dead simple. And in this case, it's completely local to the Swarm instance. If we were to do distributed transactions, we could have JMS calling out, and if we had a JMS or a remote interaction, then we would make sure that we would flow the transaction context from one microservice to another. And that transaction context could be a compensation context, as I mentioned before. So anyway, I just want to give you a quick overview of what we're trying to do with transactions, which many people think are not necessarily conducive with microservices, but we would disagree. In some applications, we think they're not only necessary, they're different variants that you may want to choose from. Okay, I'll pass it back to Ken.
Thanks, Mark. So I'd like to announce that today we released 1.0.0 Alpha 5 of Wildfly Swarm, and that's what I was using in the examples today. It's been a while coming, but it's got a lot of good stuff in it. So as I mentioned before, we've actually now got Infinispan as a fraction, but we're also looking to add additional fractions all the time, one of them being camel, because I know that's quite popular. And obviously, we'd like to add additional support for other frameworks, such as Spring. If anyone wants to help us out with that, by all means, get in touch. We're going to give the UberJar a bit of a diet, see if we can't shrink it down a bit. I know size isn't critical, but some people view it that way. It's not the be and all and end all. Whether it's 10 meg or 40 meg, it's still going to run fast. But some people view size as being an issue. We're going to improve the testing of Swarm-based applications to make it a lot easier. We currently have some support for using a Killian, but we need to improve that. And we also need to finish going through and having the fractions use the Java-generated API instead of handcrafted code that mimics what standalone XML does. And then we're always looking for ways to improve the APIs that we have and you need to use when you're generating your own main. So if you find it a bit clunky to do certain things, let us know. We'll always look to improve it. So how to keep in touch. We've obviously got GitHub organization. We've got Twitter. We have an IRC room, which we're all in. There's a website, which is currently under the Wildfly one, but we will be changing that shortly. There's a lovely short URL here for the user guide. I don't expect you to try and copy that down now. These slides will be up in the presentation GitHub repo on Wildfly Swarm this evening, and we're very much interested in feedback and input on direction. And just before we have final questions, what I'll do is show you some of the things we have. So that's our organization. So we have an examples repo, which I'll have a look at in a second, and the main Wildfly Swarm repo. The Swarm presentations, which is where this will go tonight. And you can see there's some other presentations that we've done over the last few months. This is the config API is the generated meta model. The user guide is the actual code for the user guide. And then Booker here is an example that we've developed using Ribbon. So it combines JAX-RS resources and makes them available through Ribbon and uses Wildfly JGroups as the service discovery mechanism instead of Eureka. And we've got some other things we're working on there. But if we have a look at Wildfly Swarm itself, you can see that these are all the fractions we currently have. So there's quite a few. I think we need to come up with a better way to separate them out there so it's not all just one big glob. But you can see there's data sources, EJB, we've got Archaeos, we've got Hystrix, Infinispan, multiple JAX-RS, depending on some of these ones are like the combination ones, which is just the module XML definition.
Quick question.
Yeah.
Does this swarm affect the OpenShift 3 EAP image in the future? Because right now I think it is doing the same thing what we spent. Okay. On the fly it is adding the config.
I don't think.
Swarm's not in OpenShift, and EAP is not doing this in OpenShift.
But in future we may expect, right?
Oh yeah, I mean our intention is to put Swarm onto OpenShift. I mean,
Yeah,
you guys are actually
yeah. We're currently working on getting it working in OpenShift with service discovery and everything right now. Making the Booker example work on OpenShift is what we're looking at right now. Obviously, in the examples here, I can show you that we've got a Dockerized version of the JAX-RS example. So it's very easy to add Swarm into Docker as a way to fire up multiple instances a bit easier to manage the ports. And we have quite a few examples here. So we've got some data source deployment ones. We've got various JAX-RS and JPA examples. Some of them, like the JPA JAX-RS CDI, is simply a WAR which without a main, so it figures things out for you. And then we've got some shrink wrap examples, which is the main that I showed you earlier, which has all the data source and JPA definitions configuration in it. And yeah, so we've got some Ribbon examples here of how to use Ribbon. And let's just have a quick look. So as an example, that's how you would have a main for using with Ribbon. And I don't know why it's commented out, but essentially you take the archive and you want to convert it to a Ribbon archive. Let's see if I can find one that actually has something meaningful there. I think this one will. Yeah. Well, so this is saying we're making the deployment secured to protect it with any role, and that's our way of integrating Ribbon with Keycloak. Yes.
People know what Keycloak is the first one, and the second one is you might want to advertise your movie theater with Netflix stuff.
Yes. So firstly, for those who aren't aware, Keycloak is a JBoss project for securing your resources and APIs and pretty much anything. I think it's the replacement to Picket Link, or at least parts of Picket Link.
Encapsulates.
Yeah.
Encapsulate.
Okay, there we go. Got to get the right terminology. And tomorrow sometime in the afternoon in the Red Hat booth, I'll be talking about Wildfly Swarm and Netflix and Ribbon and how we all work with that, and demoing some of that as well. And then I'll be doing a slight variation of this talk on Wednesday in the Red Hat booth as well. Thanks very much for coming. Are there any final questions? Yes?
How does this fit into CI/CD type toolchain?
You should repeat the question. Yeah. So the question was, how does this impact the CI/CD toolchain? I don't think it really does, because this is just another way to package things, and it would just be that the toolchain would. You disagree?
Well, his question wasn't how it would impact, how it would fit in.
Yeah.
It's actually subtly different.
Exports differently for each deployment into a VM, rather than just having one single or multiple deployments into an E container. I mean, I would love to have every deployment that I have be minimized to just the tools that it needs, instead of one app server with a super with all the things deployed in there. I'm just trying to figure out how I would manage that in the same VM space.
So we're doing a lot of work with CI/CD at the moment. We're not integrating the work that's going on in Swarm with that at this stage, because Swarm's still fairly new, and there's a lot more work that we need to do in Swarm before we actually get there. But it absolutely will be integrated in what we come out with. Yeah, you can do. Yeah, I'm on record as saying that. So, yeah.
Any other questions? Yes.
Yeah, so we've been following the project for a while. Kind of curious to get your take on it's in alpha status. It has been for a while. It seems like you're spitting out a lot of other fractions, but what's really blocking like a 1.0, or what are some reasons maybe not to use this on a production workload now?
In the past, one of the big issues has been there's been a lot of churn internally in terms of how things are working, and we haven't wanted to move out of the alpha until we've kind of nailed that down for a couple of releases. I think we're probably getting close to a point where we can move towards betas. Maybe in the next 3 months, I would like to see us do that. In terms of a final, I don't really know at this stage. We need to sit down and figure that out.
And in terms of support, I mean, Red Hat won't support it until we actually make it into EAP. You know, we'll do community support, but, you know, it has to go into EAP, which will be a version of EAP 7, which it will go into.
Okay, so any final words of caution for looking at production workloads before it's 1.0? Would you not recommend that? Or relatively simple apps that are using JavaOne?
Should be okay. I mean, it's based on Wildfly. Ultimately, it's Wildfly underneath, and Wildfly is, you know, despite the fact of the name change, it has a long heritage, and you know, it's very stable.
Yeah, I guess that's the important point to make with Swarm, is that we're really just a different way to package it at its core. So we're not changing the subsystems and how they work. We're just configuring them in a slightly different way as opposed to standalone XML. But the guts of the subsystem is as it is in Wildfly. So it's been around for a while. They all work very well in production today. So there should be no reason that Swarm would suddenly add lots of issues to that.
And it's one of the things where, you know, we would like community feedback. You know, take it, deploy it. Okay, if it takes down your nuclear reactor, don't come back and complain to us. But if you find issues with it that aren't life-threatening, definitely let us know. Okay, if they are life-threatening, let him know.
Yes.
So will EAP 7 contain Swarm, or will it be part of EAP 7, or will they be two separate things? Too early?
Yeah, too early to say. And there'll be 7 something.
7 something.
Yeah.
With the Swarm, did you see any runtime changes? Suppose my logging subsystem, I generally use info, but I want to debug something. How I can make to debug more when it's running? Because I don't get standalone handling, right?
Well, there is no way to change the logging level while it's running.
You want to stop it and redeploy one more with your own logging level?
Yes.
Although, well, so I had a similar question when I gave this presentation in London.
Oh, okay.
And so I answered on the fly, and I went back to Bob and confirmed. if you wrote your own main,
Yes.
and the main was polling for, you know, an update to the log4j file, for
Yes.
instance, then if you noticed a change, then you could go back and you could change the configuration within your main. So you-
Yes.
you
So,
could do
so by default, it doesn't do that, but you can code around it.
Few patterns, right? You can run multiple separate container to sample
Yeah.
the launch.
you could generate multiple fat jars. One that's, you know, myapp-info.fatjar, myapp-warning.fatjar, if you really wanted to, or you could have one that just polls. Yeah.
Any other questions?
Is there a model where you could include, I suppose, the server configuration effectively like another fraction, I suppose?
Well, we do have I think we've got an issue that's been raised that basically asks for us to take an existing standalone XML and basically build the fractions from that. That's not something we've done yet, but it should, in theory, be possible.
Because that would be more familiar for people.
Yes.
Presumably you wouldn't have to write any mains at all. Or
I would think you wouldn't have to. Yeah.
This is part of the conversation we were having yesterday.
Yeah. Depending on how the fractions are written, as they stand today, it wouldn't work like that, but we probably need to change it so it can.
So can you use the CLI with Swarm?
No.
Replacing our CLI. Almost, kind of.
Well, it's, yeah. I think we're almost out of time, but in terms of the CLI, it's not something we're bundling in Swarm, and there is no way to do the equivalent of the CLI commands on Swarm instance. Okay, if that's it, thanks very much for coming, everyone.
We have to do the CLI in Swarm. You realise that, don't you?
Begrudgingly.
We do have to.
Oh, yeah, we're talking about it. I'm curious.
I've got to go, but well done.
Oh, thank you.
Yeah. You managed to cope with the demo gods really well. But I'll see you later on, okay? Let me know if you have any problems with that Mac. You shouldn't.
I shouldn't, but no, yeah. Like, is everyone going out later or something, or?
I've got
You've got lots of
and
stuff. Yeah,
so,
okay.
Yeah. If anything's happening, Andy will
must be dying.
Sorry?
You guys must be dying at the time shift. I lived in Britain for 10 years.
Oh, well, he's in London. I live in Boston. Used to live in London, but not at the moment.
I used to fly back to California to visit my family. Thank you very much.
No problem.
Just a quick question. Are
Yes.
any fragments that would help me with building a health check and monitoring stack on top of the endpoints that you have?
At the moment, we've obviously started adding a fraction for Hawkula, which is a JBoss project for monitoring and metrics. But we're also looking to maybe create something a bit simpler that doesn't require a whole nother system running to provide the info to. It maybe just logs it out somewhere. And as of yet, we don't have any kind of health check, but it's something we need to look at.
Okay, so you're actually still building the...
Yeah, we've only been working on this for 8 months, maybe.
Okay. So that's still fairly new.
Still very early days, and we're always looking for help. So if you're interested in, like, certainly go ahead and create issues for things that you think we should do and that aren't there already. And if you want to help out with stuff, by all means, that would be great.
Okay, and how extensible would it be? For example, you were mentioning the integration with OpenShift, so that would be Kubernetes, right?
Yeah.
So etcd and that kind of stuff. Is that something that I would be able to just plug in?
I'm not too familiar with what Ben's been doing for the integration of Booker with OpenShift, but I think we're trying to do it in a way where you don't have to do anything OpenShift specific. It kind of all happens magically in the background.
And is there a way to actually do the magic yourself?
He's doing it through the JGroups SPI.
Yeah, I think so.
Yes, it's JGroup space. So I mean, by default with this poker demo that we have, it's just all multicast. So he's doing it through a JGroups SPI for OpenShift, and somehow he's
fabricate stuff.
Yeah, so basically I think what we're doing is we do the multicast with JGroups, and we're basically going to change the JGroups to use the kubeping implementation instead of multicast. And he's currently working on that to get that working on OpenShift.
Thanks a lot.
But by all means, come into the free node chat room and ask around. Everyone's there and always willing to help out.
Okay, well, thanks a lot.
Thank you. Yeah, I know.
darn demos.
Yeah, and that is why I'm not trying to do a Hystrix demo for tomorrow.
Okay. Yeah, you know, one of the things I did.
Well, plus I started thinking about it yesterday, last night, and I was trying to think how it would work, and I got to realizing that I don't want to half-ass something just to get a demo to work and then go, oh shit, that's not the right way to do it.
Right. Well, I think that we need to tweak the order a little bit of how we present this. Having sat down through an iteration of it, I think we should just show all the XML dependencies first, and then go into fractions and describe what the fractions do after we kind of show them. Just do these things, first, here it is running, right, Java.jar.
Yeah.
Then here's how we did it, modify the POM.xml, and then say, well, you notice my dependencies were fractions, now here's what fractions are. So do it in that order, and I think it'll flow a little bit better.
Okay. I might try and change that for Wednesday's booth talk.
Yeah. And, it's okay, I mean, yeah, it's okay, it's just, that was the first time that we've had a chance to actually see it.
I know I actually had that thought the other day of whether it it was talking about fractions before they were kind of really shown, and it was.
I just want to say hi. My name is Travis. I work for